Hello and welcome to the first tutorial of our Excel VBA course, where we begin our quest to gain Excel Jedi powers so that we can handle or manipulate almost any data within our Excel spreadsheet and handle any problem. Our first tutorial is going to be to look at recording macros. Now, those of you who have taken the Excel Superhero course, we would have covered recording macros there. Now, the examples used will be a little bit different, some of them, so it is completely up to you whether you skip this chapter and go straight into the VBA elements, or whether you sit through these as a kind of recap and a bit of a refresher and see some slightly different examples used. There will be some VBA elements covering in this section as well, but for the most part it will be looking at recording. And this is very important. We'll look at the differences as the course evolves, but recording a macro will never look beyond. It can be a very helpful tool no matter how far you get in VBA. It won't generate the best code and stuff, we'll look at that, or be that powerful, nowhere near. But it's an important element to help us learn, understand, get code to tweak, in much the same reason that you may spell check work or have a dictionary at home. Why do you? Do you not know that language? Of course you do. But you forget how things are spelled, you look at words you're not familiar with, this kind of stuff. And in much the same way with recording, we can't write code for every single feature that Excel has. We don't even know them all. Nobody does. So it's an important step to start with. And as an example here, what we want to be able to do is, on this worksheet on screen, I want to protect the formulas on it. Now, this spreadsheet only has 3 cells with a formula in, so this may be a basic example. But I want this macro, a little clicky button on our toolbar. When I click it, I want it to be able to lock down the cells that have a formula on the spreadsheet. I don't want to have to be able to tell the macro. And so, look, they're in these 3 cells here, B10 to D10. I don't want to have to do that. Whatever's going on in that spreadsheet, I'll click a button. Excel will figure out where the formulas are, lock them down. That's what I want to happen. So before we get going with recording our macro, we're going to have a little rehearsal. We're going to plan and research our steps. And this will become, we'll recap on this as the course goes on. And into the VBA elements, it will be more important that, although it's not imperative, it's a good idea to plan our stuff before we look at recording it. We want to make sure we know what we're doing and the best way of doing it before we get going. I want to make sure it even works. So, my plan here is that we are going to select the square in the top left to select all the cells of the spreadsheet. I don't know whether these cells are locked or unlocked. I can't guarantee this because I don't know what other people are doing on this spreadsheet. I want to go into the Format Cells dialog box any way we're comfortable in doing so, to the Protection tab, so that with this locked box, I'm going to turn it on and turn it off to ensure that them cells are unlocked. So when I click OK, they're now unlocked. I get these little triangles warning me where the formulas are. Are you crazy? Why would you do that to formulas? I'm not going to. What I'm next going to do is I'm going to the Find and Select button on the Home tab, and sorry, I'm not going to go to Special. I'm going to Formulas. I'm going to select all the cells of this spreadsheet that have a formula in them. So when I click that, it selects the cells with a formula, selecting only them 3. That feature is a lot more powerful than it might initially look. The fact that Excel figures out where the formulas are and selects them. Very relative way of working, extremely powerful, very useful. I'm then going back into Format Cells, Protection tab, and locking them. 3 down, the warning disappears, and then I'm going to be going to Review and Protecting the sheet. And I won't worry about a password or any of these other features for now. It's just an example of recording a macro. Those of you who took the Excel Superhero course, we would have done worksheet protection on that. So the reasons why we're unlocking cells and locking cells and the features in here will be more, you'll understand things more or you may know it from outside doing that course. But now I've protected that sheet, that is done. Now I haven't recorded a macro yet, I've just kind of rehearsed what I want to do. Next step is, if I'm happy with doing that and it seemed to work okay, is to record it. So in the future I'll have a button that will run that macro and do that job. Because I don't know what that was, 8 clicks? I didn't really count as I was doing it. Nothing crazy, but certainly would be more helpful. So I'm just going to backtrack my steps. I'm going to unprotect that, and I won't bother unlocking locking. It's irrelevant for the recording to work. And I'm going to start recording the macro. To do this, I'm going to the View tab and the drop down arrow for the macros button. Now I do have a record macro button actually in the bottom left of my screen down here, we can see. So I could go that way, I could go the developer tab way, but I'm going to go this way as I'm here already and look at recording a macro. First thing it will ask is, what would you like to call the macro? I'm going to call it protect formulas. Let's try and spell that correctly. Protect formulas. That sounds like a good name for me, that's what I'm doing. Now you're not allowed to use spaces in macro names, so I've got an underscore here to skip around that issue. Shortcut key. Would I like to use a shortcut key for this? Now personally no. I'm not a big fan of this feature. It's not to say it can't be useful, but personally not a fan of it. If I did choose Control P, you know, it doesn't even warn me, but that will become the shortcut key for this macro, therefore replacing print in the scope of this macro. You know, and if I chose R, I'll choose R then. You know, copying series to the right, or F, which is find. So, potentially dangerous. You cannot undo a macro. Your Control Z or your spinny blue arrow will be disabled after running a macro. You cannot undo it. Your saving grace, if this has made a mistake, is to close the spreadsheet down, saying no to saving changes. So potentially dangerous. This macro is quite harmless. People can just unprotect it if they know the password. But personally, not a big fan of the benefits. You might as well have a clicky button. It's not that important, as to I've seen it do bad things in the past. Where do I want to store the macro? Now we're going to store it in this workbook, meaning this macro, you know, the scope of the macro, it's only available when this workbook is open. So I can email this workbook to others and the macro will be travelled with it for distribution. But I have to have this file open. I have access to it and have it open. The personal macro workbook, the other useful setting in there, which you'll see at some point during this course, makes this macro global for you. So the word personal, it's available only to you. So in your login, your kind of roaming profile in a business scenario. And this macro is available in any file that you use. You don't have to have it open. It's a hidden file, this personal workbook. Sort of like a template. And it just sits behind the scenes, making these macros available to you at any file that you use, not for others. So pros and cons to them two different settings. For now I'm going for this workbook. I won't worry with a description, but here, actually let's type one in. I'll just say that this macro protects cells containing formulas on the current sheet. There you go, that's what it does. And I'll click OK. So that's going to begin to record our macro. I can see in the bottom left hand corner of my screen that there's a blue square on the status bar. That's my stop button. We'll be pressing that when we want to finish recording. So let's get this job done. This video is getting a little bit larger in length. So, running through our steps. The square in the top left to select all the cells on this whole worksheet. Home tab, arrow in the corner of that number group to open up the format cells dialog box, or however you'd like to get that done. Protection tab, make sure they're unlocked. I'm going to turn it on and turn it off again to force that into play, and to click OK so the cells are unlocked. And I can see the green triangles appear there. Straight into the Find and Select button on the Home tab, and tell it to select all the cells that contain a formula. It grabs them free. Back into the Format Cells dialog box using this arrow or some other approach. Protection tab, lock the cells. Lock the selected cells. Done. Now what I'm going to do is go into, what I might do actually first is I'm going to click a vacant cell to deselect them. Review tab, protect the sheet, and just click OK. I don't want to change any of them settings. That is protected. I'm going to go straight to that blue square down the bottom and stop the recording. I see the blue square disappear, replaced with the record macro button. So my macro is done. No nice messages appearing, saying congratulations, Alan. That is a fantastic macro you've just created. Well played. Nothing like that. We have to have a little bit of faith that it must have worked. I don't have a clicky button at the moment to run that. We're going to look at different techniques for that over the coming tutorials. But for now, we have our first macro. Hello and welcome to this tutorial where we will look at saving a spreadsheet that contains a macro as a macro enabled file. Now I have a spreadsheet open at the moment which is currently in the state of after the very first video, where we have recorded or we have written a macro, and at the moment it's still as a .xlsx type, file type. So it's a normal spreadsheet, but it contains a macro. If I was to go up and look at saving this file with my floppy disk button at the top there, immediately I should get this warning, where Excel warns me that there is a VB project on here and that I shouldn't save it as a macro-free workbook. If I want to continue saving as macro-free, I could click yes. But otherwise I should click no and choose macro enabled from the file type list. If I save as a macro-free workbook, it will remove my macro. So that is not a good idea. And if we're saving macros to files, we have to save them as macro enabled files. Very good that we get this warning. So that's kind of protecting us in a way from such a mistake. But important that we do so. Now I could click no here and it would immediately take me to immediately take me to my save as dialog box. Alternatively, I can look at doing that manually just through file save as. I'm going to click no as I'm at this stage, so I get the save as dialog box, which will be familiar with anyhow. Depending on the version of Windows you have, it may look a bit different to this. But saving just as any file. And what I'm going to do is down the bottom here, where it's currently saving as an Excel workbook, I'm going to change that to an Excel macro enabled, where are you, workbook, which has a .xlsm extension. I'll click that and I'll keep it as the same name, protect formulas. That will work just fine. And I'm going to save that. So now it's a .xlsm file type. And I'll look at closing that file down. So now we've saved it, it's going to keep the macro so that it will be available in future versions. If I close that file down and look at opening that file up again, protect formulas, immediately it opens back up. Notice that I get what they call a message bar, I believe, this yellow bar along the top, with security warning saying that macros have been disabled. Would I like to enable them? Save it as a macro enabled file, seeing a .xlm extension at the top there, which you may not see on your version of Excel. It's a setting you can choose on or off. Does not immediately enable them. If I send this to to Fred, who works in the Hong Kong office, then, the macro is not going to be immediately available to him, or it depends on his security settings, to be fair. But it is there. They would have to enable them. This is a security feature to ensure that if you've downloaded this file off the internet, or you've been emailed it from somebody you've not met before, a new client maybe, then you're initially protected. It might be dangerous. Unfortunately, people do use this as a way of delivering malicious software, so you do have to be careful. It is programming, but for the most part in a business scenario, you probably know this individual. It may even be yourself, and we can enable it. Just to mention on that scenario there, that if I go into my File tab, and if I go to my Options button, and into the Trust Center settings, and I have this macro settings option, because you can change your macro security settings. Now, this is probably controlled by IT within your company, so it's not my place to tell you what you should or should not do here, or even if you're able to do it. That should be controlled centrally. But from a personal viewpoint, it's up to you what you do here. Notice the option to enable all macros and you'll never get that setting again can be chosen. They say it's not recommended. Microsoft aren't going to say, oh yeah, go and do that, because you could be sent something malicious. It's potentially dangerous. So the default, and the one I keep because I get sent a lot of files, is to disable all macros but with the notification. But there are other settings there. You can full on disable them or allow everything should you be that free in your life. But that is us saving it as a macro enabled file, essential if you do have a macro on a file. Hello and welcome to this tutorial where we're going to look at adding a button onto our quick access toolbar which will run our macro. So I have this spreadsheet that contains a macro, but at the moment there is no way of triggering it. I don't have a clickable button to run that macro. The only way I could run it at the moment is to go to my View tab, into the Macros dialog box, which I can use at the top half of my Macros button here, and to run the macro. And that's not a bad idea, just to test it works okay before you take things any further. But that's not good enough for when you have a macro and you want it to, you want to just click a button and it will do the business. And we're going to look at 3 different places you can add a button over coming tutorials, but possibly the most common place to add a button will be the toolbar at the top of our screen, known as your quick access toolbar. You can see I've got the standard save, undo, redo buttons up there already, and I've also got a paste special values button up there, a button I use a lot and I've added at some point in time. Never a bad idea, stepping aside from macros for a moment, to look at personalising that and customising it to your needs, so that you can work, much more productively day by day, using the features you use a lot much quicker. Good shortcuts. For now though, I'm going for the drop down arrow on the end, and we're going for more commands because we're hunting out our macro. More commands. Drop down arrow at the top of this kind of middle section saying popular commands. We're going to change to say macros to show all the macros that we have. Now there's quite a lot showing on mine because I've got the analysis toolpack add-in installed, which is what all this other stuff is. You may even have more than what I've got there. You may have similar add-ins provided. You may have other macros. But I can see as I scroll through, whether you only have this or whether you have tons of stuff in there, I can find protect formulas. The macro are recorded in the first lesson of this section of the course. And I'm going to add that across to the right. So the button goes across, it maintains that name with the underscore in there. and it has this flowchart icon. Now, first thing I'm going to mention here is at the top of this right hand side it says for all documents. So this button will be available to me in any file that I use. Now, thinking about that for a moment, in the first tutorial I saved this macro to this file only. So by making this button available in any file, it'd be redundant anywhere else. If I opened up a different file and click this button, it will moan at me and say, "Where is your macro? I cannot find the macro to run." So it might make more sense, well, that's not a terrible thing to keep it as it is, to remove that button. And I'm going to change this drop down arrow at the top here to this file only. Now, I believe I'm right in saying that that functionality came out in the 2010 version of Excel. So depending on what version of Excel you're using, you may not be able to create a toolbar specifically for one type of file. But I believe it was 2010 and then onwards that became available. If not, just save it to the general toolbar. It's not a terrible thing. But I'm going to add that across now, so this button is only available, along with the others, although I don't see them, only in this file. And my next step is going to be to use this modifier button at the bottom of the right hand side, where most importantly really I can look at changing the name. And I'm going to change to protect cells with formulas. I can use spaces now for a better display name. I don't have to worry about things I can't do, such as using spaces or starting with numbers in my name. I can also change the image. Now, there's not many images there that really say protect formulas. I'm going to quick scan to see if there's anything half decent. I might go for an anchor, maybe that sort of similar. I don't know, not really. I'm going to choose that anchor because I like it. And I'm going to click OK. So now my icon is an anchor, and my name is Protect Cells with Formulas. If I click OK, that button becomes available on my spreadsheet. And if I went to review for a moment and unprotected this sheet, because it is still actually protected, and then I went and hit that anchor button, it protects the spreadsheet again. If I go back to review, it's protected. So that's gone through them steps of unlocking everything, selecting the cells of formulas, locking them and protecting it. Now available just at the click of a button on the end of the toolbar there. If I quickly created a new spreadsheet, if I do Control N for a new file, I can see that that anchor is not there. It is only available in that one file. If it was there, I'd click it, it would moan at me and say it can't run a macro. That's not a terrible thing. It's not ideal, but I've managed to isolate it to this file, which is, I would say, better. So we've got our first way of triggering a macro there, first of a few as this course progresses, but possibly the most popular place to put one on, because it is the quickest way of accessing it, apart from a keyboard shortcut, is that we can click that button at the top from any sheet, any ribbon tab. It's there for us. Hello and welcome to this video tutorial on customizing the ribbon. Now, fresh off the back of the last tutorial where we looked at adding buttons to our toolbar at the top to trigger the macros that we have created, we're now going to look at adding buttons to this ribbon below it. Not as quick with its access as the toolbar at the top, working this tabular structure, but the main benefit being its size of the ribbon. It's a lot larger, more potential to personalise it and to add more functions to it as to the slightly smaller toolbar. Now, to do this, I'm going to right mouse click anywhere on that ribbon and go into customise the ribbon. This is probably the fastest way of getting into this customise area. And it's probably worth mentioning that you cannot customise the ribbon in versions prior to 2010. Functionality came out in 2010. In older versions, you may be able to create your own toolbars and definitely add buttons to the toolbar like the previous tutorial. but you cannot modify the ribbon at a basic level. Not without VBA anyway. So, going into from 2010 plus, we're going to customize the ribbon. And on the right hand side, we can see the tabs currently visible and they are checked. What we're going to do is look at adding our own tab to this. Now, you are a little bit restricted to what you're allowed to do. They don't allow you to kind of remove functions from current groups or do too much to existing groups. So for example, in the dialog box and in the ribbon in the background here, we can see that the Home tab has this clipboard group and this font group, and you're a little bit restricted to what you're allowed to do to them. You see, you're not allowed to do much to their features, they're all ghosted out and so forth. But you are allowed to add your own groups to them tabs, and you're allowed to create your own tabs, and that's what we're going to look at doing. I'm going to select the Home tab in this right hand side and click New Tab at the bottom to create my own tab just after that. Now, the only reason I've selected Home is so that my tab would appear one after Home. I can always use these arrows on the right to reorder them tabs into the way that I deem appropriate. If I want it to be the first tab on there, I can make it be so. And probably more importantly, I can rename them. If you have New Tab, I don't think you're going to be happy with it being named like that. I'm going to select it, click Rename at the bottom, and name it as Macros. So I've got my own tab for all of the macros that I've generated. I'm then going to select my new group and rename that as well. They start you off with one group. Protecting data. We can add our own groups to this, but we can also rename what we have. What I'm going to do is I'm going to select my macros tab and go for the new group button at the bottom as well. I'm going to add in one more group and rename them. Now, we can add as many groups in as we want, depending on the space that we have on that ribbon. I'm going to name this Reporting Tools. Just trying to provide meaningful names where we can logically group, in this scenario, the macros that we've created. I'm now going to select my Protecting Data group, and in this kind of middle section, I'm going to choose Macros, just like we did on the previous tutorial from the drop down list at the top there, and I'm going to hunt out the macro that I want and add it across to the group that's currently selected, which is Protecting Data. And also, just like the previous tutorial, we can change the image that's visible and also the name. This time we'll do it by selecting the macro and choosing Rename at the bottom. And once again, I can call this Protect Cells with Formulas or some other kind of meaningful name, and choose hopefully a meaningful image. I'm going for the hand this time, palming people away. You cannot change that cell, it has a formula in. I'm going to click OK, and I have my new looking button. Now, I know I've named this tab Macros, and I could rename it if I wanted to be fussy here, but just for a quick example, it doesn't have to be macros only that you add to this. We're on a macros or a VBA course here, so that's going to be our primary objective. But Excel's got loads of built-in features. You're certainly not just limited to that. Why would you want to limit yourself to that? There's loads built in that we could just go and use. So just scanning down my list here, thinking, what could I use? I want to try and grab some of a feature that sort of says protection. Where am I going? I've gone straight past protection. What's my alphabet like? I've got Protect Sheet. Let's throw Protect Workbook in there. Protect Workbook. I'm going to add that across. Oh, there's Publish as PDF. That's a sort of protection sort of scenario. Surely PDFs are read-only in most cases. Yeah, then Reporting Tools, I can add more macros, etc. Let's just add one more thing in there. Let's just throw in a print area, just so we've got something in that group. So I've got my macro in there, which I've renamed for a different icon. I've also thrown in some inbuilt features as well. Now I've got all commands selected at the moment, so a huge list. Great potential for personalising stuff. Creating your macros that we'll be doing throughout this course. The world is your oyster. I'm going to click OK at the bottom to save them changes, close the box, and I have a macros tab on the ribbon just at the top there before home. There's my macro. I've also got the others that I added. I've got the protect workbook button, the print area button in these groups. Huge amount of space for more there. More potential maybe on the ribbon here, although not quite as fast to access. You have to go to the tab first. Is it protected? It's not. Let's quickly give our macro a go. Let's click that hand. Done. Sheet protected. An alternative way of triggering our macro there by customizing the ribbon. Hello and welcome to this next lesson of this course, where we are going to look at adding a button to our worksheet to trigger that macro. So I'm looking at putting a button maybe around about here on the worksheet that I can click to trigger our protect formulas macro. So we've already seen adding buttons to the toolbar at the top, probably the most popular place to put a button, then the ribbon, and now we're looking at on the sheet. The kind of third and final way for now of actioning the macro. Now to do this, up on our ribbon we will need a tab called a developer tab, which at the moment is not visible on my ribbon. You may have it on yours, you may not. It's not shown by default, so there's a fair chance you don't, unless you've dabbled with macros and VBA in the past. But it should be at the end here. Now to bring that into our view, to make it available to us, I'm going to right click anywhere along that ribbon and go for customize the ribbon. And on here I can see this checkbox on the right hand side, which I can tick for developer, which is going to make that developer tab visible on our screen. So I'm going to tick developer, click OK, and now the developer tab is available to us. And with that tab visible now, we have this insert button, roughly halfway along that list of commands we have. And I'm going for the very first control, which is our button form control. Give that a click. We will then need to draw it onto our sheet. So I've got this crosshair on my mouse. I'm just going to click and drag to roughly draw the size of a button that I want. We can always move or resize it after, so we don't need to be too accurate at this point. But as soon as I release my mouse button, Excel will prompt me for what macro I would like to assign to that button. I'm going to choose the protect formulas macro here and click OK. So now I have a clickable button that will run that macro. Next logical task here, I guess, would be to change that name. Button 1 doesn't really signify what it does, so I'm going to call it protect formulas, and I'm going to take that a step further if I can. There's trouble selecting that text there. I am going to make that text bold, and that's it. Maybe make the button a tiny bit larger. So we can play around with the formatting aspects, resize it, change the format of the text. You're limited to what you're allowed to do. I can see the amount of grey options we have along the top here. There's not that much I can do to that button, but there are some formatting elements we can do. Sorry. As soon as I click away from that button, it becomes live. So I can see as I hover my mouse that that button is now ready to go. If I was to click it, it would run that macro. If I right mouse click on it, it will then take me back into this kind of design view aspect of it. So I can look at editing that text, or maybe now just click on my button. I've got the potential to edit the text there, move it maybe, resize it, anything I might be else I might be looking at doing. The moment I click off it again, it's back and it's become live. So that is us adding our button form control onto our sheet. Now before we look at tidying this video up, it's probably worth a mention that we can also assign macros to other clickable objects, not just buttons. So for example, I could go to the Insert tab and insert a shape onto this worksheet. And some of the benefits of inserting a shape over a button may be that they're more versatile. There's a greater aspect that you can format it as there is to them grey buttons. Now I don't have to pick something crazy, I could just pick a rectangle, so it's going to look like that button, if that's the look I'm going for. But as I draw it in, the difference is clear. I've got this blue colour, and immediately the Drawing Tools tab livens up and gives me the potential to format it further should I want to. I can start typing, and that will start adding some text onto there, so I can add text just the same. That text will also need a little bit of tidying up, so I could just spend a quick 2 seconds doing that. Let's center this stuff, bold it, make it black. Here we go, looking a bit better. And the final step would be to assign the macro, the most important thing to it. To do that, I'm going to right mouse click on the shape and go to Assign Macro. Fantastic. I'm going to assign the Protect Formulas macro. Click OK, and I now have 2 buttons that will run this formula. If I click off that shape, it's live. So now if I click the shape, it's protected. Let me pop up to the Review tab and unprotect that sheet. And also if I click my button, same job. So both of them will trigger that macro. Buttons on a sheet, very popular for macros that run off kind of forms that get filled in, or to position on dashboards and other kind of analysis sheets and reports, that sort of scenario. Hello and welcome to this tutorial where we are going to start to look at editing the code of our macro. So this is what we've been waiting for. We looked at recording and adding buttons to trigger it, but now it's time to start delving into the VBA aspect. And to begin with, we're going to look at making a small addition to our existing macro to take it that step further. We've got this macro that protects the formulas of our sheet, and I have this toolbar button on my ribbon, this anchor, that will run that macro. Macro seems to work absolutely fine. The one thing that we haven't really catered for though in this macro is what to do if the sheet is already protected. So if I was to click the anchor at the moment, it would run the macro and protect the sheet, and our job is done. But what if somebody just came up and hit that button? This is what we get. We get this error, unable to set the locked property of range class. So it kind of falls apart and it can't perform its job. So I'm just going to click end on that and come back, and I'm going to unprotect the sheet myself. But what we're going to look at doing is adding some extra code there that will check if the sheet is already protected, and if it is, it's going to tell the user that and then come out of the macro. So what we've decided to do is not continue with protecting it. We're just going to kind of pull out of the macro and let the user know the issue. Now, if the user's able to, then great. If not, then maybe they weren't meant to anyway. Now in reality, what you go with this, you may decide that unprotecting it is the right choice. This is just what we're going as a demonstration of what we could do in this macro. First thing we need to do is see our code. Now to do this, I'm going to go to the View tab and the macros button on the far right hand side. I'm going to go for the top half of that button to open up the macros dialog box so that I can see our macro, our protect formulas macro. And I'm going to click edit on the right hand side to look at making some changes to that macro. And this will show us that code in what's known as the Visual Basic Editor. This is where we're going to be spending all our time throughout this course, writing our own code, changing it, learning it, everything that we need to do. So we have a separate tutorial coming up soon that's going to explain some of the key areas of this window as we delve into the code inside a little bit more hardcore. For now, all I'm concentrating on is this area in the middle where I can see the code behind our macro. I have this protect formulas macro, and then we've got these lines that are actually performing the job. They're selecting all the cells, they're unlocking them and saying that formulas are not hidden, then selecting the cells that have the formulas, locking them and keeping formulas not hidden, selecting range A3 to deselect our selection, and then performing the protection. What I'm looking at doing is before any of that happens, so before cells.select, I want to add to this code to check if the sheet is already protected. If it is, then there's no need to do any of this stuff. So I'm just going to click to the left of that line and press enter or return a couple of times to find myself a little bit of space. And I'm going to write if active sheet dot protect contents equals true, then, and I'm going to tab in, I'm going to write MSG box space, put in some speech marks and write the worksheet is already protected, closing speech marks, new line, exit sub, and an end if. So what I've written there is 4 new lines. I'm going to perform a test to see if the worksheet is already protected. If it is, I'm going to display a message box to the user with this message, and then I'm going to exit the macro. I'm going to abort that macro. And that's just a closing statement to if. The same way that you'd write an if function and use an opening and closing bracket in Excel, think of that as a closing bracket for if. Has to be there. Otherwise, if that's not the case, it's just going to continue with our macro. So not much of an explanation there on what they do. This is just a real quick example as we build our way in, try no nonsense, get in the content, get it in there. Want to look at adding to our macro and performing that little bit extra to kind of whet our appetite. What we are seeing though, especially 2 things here, an if then else statement and a message box function, an inbuilt VBA function. It is certainly not the last time we'll be seeing them in this course. They'll be coming back later with stronger explanations as to how to write them and why we use them, but they are 2 extremely common lines of code, and as I say, it's certainly not the last time we'll be seeing them throughout this course. For now, I'm going to click this X in the very top right hand corner, the very top X, to close down this window. What state I'm in at the moment, my worksheet is not protected. Let's click the anchor, does the job. It's now protected. Let's press the anchor again, and I get this message box telling me the worksheet is already protected. I click OK, no error this time. We've got our own customized message letting the user know what's going on. Try it again. Still protected. unprotect it and then try it, does the job. So we've added our extra lines of code, which we have to do. You can't record yourself doing that. We needed VBA to put that decision making lines of code in there, to put in that message box so that we can kind of talk to the user. These are elements that you cannot record, and this is what this course is all about. Hello and welcome to our next video tutorial, where we are going to look at using relative references whilst recording a macro. So throughout this course we're going to look at different ways that you can reference cells. Obviously very difficult to use Excel without that ability. For now we're going to look at, when recording, how we can provide this functionality of relative references. Now, first of all, we need an example of what we're going to do, and this is it. I have two sheets on this workbook. The second one is called July. So in reality this would be whatever the month is. For now it's July, next month it will be a different month. Whatever that current month is, what we want to do is we want to grab all of this data, everything that got recorded, all of these orders as they are for that month, and we want to move that information to the bottom of this sort of like master sheet. So we want to find the bottom and store it in there. We want to remove any formulas that are in play. There's not many, but there's some in here, column J. We want to remove them. We don't need them anymore. We've got the answer. We're sort of kind of archiving it to this master sheet. This sort of transactional, this kind of consolidation macro. Very common business need, this kind of situation. Okay, so without beating around the bush, we're going to get straight in and we're going to record this and move it over there. Bit of explanation as we go, very brief explanation, so we can try and concentrate as much as we can do on the coding side of things. So we're going to start a recording, View tab, bottom half of macros, record macro, and we're going to give this macro a name, which I'm going to call consolidate orders. Let's put a capital for that, do a little capital, and I'm going to store it in this workbook. No shortcut key, no description. I'll click OK, so it begins to record what we're doing. And what we're going to do is, on this July sheet, I'm going to click in cell A2 to select the very first cell of the sheet, excluding the headings. I want to keep the headings ready for the next month. Now I'm going to use a keyboard shortcut combination. I'm going to hold down Control and Shift and use the down arrow on the keyboard to select everything to the bottom of that column, and follow it with Control, Shift and the right facing arrow to select everything to the end of that row. So there's a nice quick way that I can select that list. A nice relative way of selecting as well, that large list, no matter how big or how small it may have been. Now I'm going to take a copy of that data, any way you want to copy. I'm going to go to the Home tab for it. Then I'm going to move to the Consolidate Macro sheet, that kind of master sheet here, and I'm going to scroll to the top of it and click in cell A2, which is the first kind of cell, the first record of this sheet. This time I'm going to do the Control down arrow, no Shift key, just Control down arrow, because that will move me to the last record within this list. So I'm trying to find the bottom of the list here. So I've clicked on the top record, used the Control down arrow shortcut to get to the bottom. Now what I need to do is move one more cell down, because I need to be in this new row, the next empty row. And at the moment I'm not quite there. So let's be clear, The next cell down is A2157. Now that is not the cell I want. I'm not interested in A2157. Yes, that is the name of this cell, that is the reference, but next time we run that, that is not the reference. So I don't want to be that specific about the cell. I want to record the nature of going to the next cell down, a relative way of referencing that cell. So I'm going to go to my View tab on the ribbon, the drop down arrow below Macros, and I'm going to choose the option to use relative references. I'm going to turn relative references on. So now, when I move to the next cell down, A2157, however you move into that cell, it should record the action of moving one more cell down, as opposed to the action of going to cell A2157. Once that's done, back to the drop down arrow, and I'm going to toggle that option off. So we return back to absolute cell references. Next task is to paste that information in. I'm going to go to the Home tab, drop down arrow for paste, and I'm going for the values and number formatting option. It's 1, 2, 3 and a percentage sign. I'm going to paste all of that in there. Once that's all pasted in, I can see that it keeps the area selected. Just about, it's right at the bottom of the screen there. You can see the area selected. What I'm going to do is scroll to the top and click on cell A2. So I'm just doing that to kind of deselect the area, take the user back to the top of the sheet, working with the assumption that that's probably where they'd like to be taken to when they first move to this sheet. You may disagree. But then I'm going to go to the July sheet, where that data is still selected from our copy. I'm going to go for the... Do I clear that? I don't want to see it. I'll clear it. I'm going to go to the Clear button, and I'm going to clear all. I'm going to wipe them cells clean, ready for the next kind of fresh bit of data. And I'm going to click on cell A2 there as well to deselect what was highlighted there. And then I'm going to stop this macro, because that seems to be everything we want to do. So I'm going for this blue square at the bottom of our screen, and I'm going to stop the recording. So we have ourselves a macro that grabs all the data stored that month, moves it to the bottom of the list on the Consolidate Macro sheet, pasting values and number formatting only, and then clears it from the month sheet ready for the next month's orders to be entered. This has been used to use relative references within this list, the action that we had to move one cell down once we got to the bottom of this list. Two more steps really on this video I think to do. Next step will be to create a button on our ribbon that will run, on our toolbar I'm going to go for, that will run this macro. It's a bit of a refresher here from an earlier video. Going for the drop down arrow, more commands, macros from our drop down list at the top there, find consolidate orders and add it across, and then we can look at changing the name or image for this modify button at the bottom. So I could choose that person and say to consolidate orders without the underscore there, and I've got a button that runs it. And the next step really is that we can't finish this macro without having a look at the code. That's what this course is about. So I'm going for View, top half of macros, and Edit, and this is what we have. So the very first thing was to select cell A2, select all the data, copy it, move to the other sheet. Then I've got all of this scroll row stuff. What is all that about? Now that stuff is me scrolling up with the scroll bar, just like I am now when I was on that sheet. It's completely harmless stuff, but it is ugly and adds confusion to this code and slows it down, and there's no reason to want to keep it, even though it's relatively harmless. So I'm going to select all of them active window scroll row lines that I can see there, and I'm just going to use delete on the keyboard to take them out. Now I'm going to do the same to this other bunch that I can see appear here. Just get rid of all of them and take them out. Fantastic. I'm going to take them lines out as well. So immediately our code's a little bit smaller. This line here is the relative reference using an object called offset. Not the last time we're going to see that in this course. We'll be covering offset. Really useful. One of the easier and therefore more popular ways of using relative references within a macro. Got our pay special here, followed by us, deselecting data and clearing and clicking an A2 and them other things that we did. Now, before we leave this macro, I'm going to make a couple more changes to our code, and the next step is going to be this one here. When we clicked on that July sheet, it recorded the code of sheets July.select. Now the next month is not going to be July, so that sheet's probably going to get renamed, and this code will not update itself. Therefore next month it will not work. So what I'm going to do is delete July and the speech marks, and I'm going to type 2. So I've changed the way that I reference the sheet. Instead of saying use the sheet called July, I'm saying use the second sheet of the workbook. So it's also a relative way, again, as opposed to absolute reference by the sheet name, of referencing that sheet. More on that as well as we go through this course, but I'm going to copy that as well back to the top of our code. I also want that line as the very first line. Reason being, when we started recording, we were on the July sheet, so it did not record us selecting the sheet. It just went straight into A2. The button that runs the macro is on the toolbar, so I cannot guarantee where the user is the moment they click the button. They may be on the consolidate macro sheet. So the first thing I'm going to do is move them to that sheet if that's the case, using sheet 2 because I don't know what it's called, and then onwards we go. I'll keep this one here because I'm working on the assumption that name's not going to change. Now, absolute references here, relative references here, and that is our code. Maybe if you wanted to add one more thing, I might add a message box at the bottom. Bit pointless this, but just as a nice finishing factor, and saying wow, that month's orders have been consolidated. Lovely message at the end there. Let's close that code window down. If I did want to give this a trial run, I'd need some information. So what I'm going to do is just grab a chunk of what we had there, just for demonstration purposes. If you are creating a macro, you're typically going to use a sample file, a backup of your data, rather than the real thing, just to make sure it works and you don't damage anything. So with that in mind, I can play around with existing data. It doesn't have to be accurate, as long as it's the same structure as what you'd normally do when you're kind of testing these macros out. I'm going to copy that in and pretend for the moment that this is new information that I need to archive. So I'm going to pop to my person sitting on the toolbar there, my consolidate orders button, and give it a click, and the job is done. Finishing with that message there and leaving us on this July sheet. This one is called July. Notice it continued to work when we reference it as a second sheet as well. Wow, that month's orders have been consolidated. Nice clean sheets there. Back to consolidate macro. Let's have a look at what we've got. It's going to be difficult to tell the difference to whether it worked or not. But all that data has been moved across in there. You can see the number of 26th there actually, so you can see quite clearly that has been moved to the bottom of that list. And this video was here to look at using relative references in a macro. As a byproduct, we had a look at some other elements of code, but they'll be covered again and again as we power through all of these fancy VBA techniques and just what it could do for you and your work. Hello and welcome to this video tutorial where we are going to introduce ourselves to the Visual Basic Editor. Now this is something we have seen a couple of times already, but we've not took the time to have a look around it as yet. We've always dived straight into our code. Also, the way we've got it to appear so far has been to go through editing our macros, which is not a terrible thing, but typically there is a quicker way of getting to it. And that quicker way is to go to the Developer tab and the Visual Basic button that you see on the far left. As I hover over that button, it also tells me that the keyboard shortcut of holding down Alt and pressing F11 would also open that editor. And that is the way that I would tend to work. Alt and F11 to quickly switch to the Visual Basic editor. As I'm on it, I'm going to click that Visual Basic button, and this is the editor. So along the top it still looks quite old school, you know, the old optionals of versions of Office where you have your menu bars to access various tools, and you've got the toolbar below it with various tools. The middle area is blank at the moment, and on the left hand side we've got two different windows. The first one is known as the Project Explorer, and the second one is our Properties window. Now when you go into the editor, you may not see them there by default. You typically would, they would be there straight away, but I cannot guarantee what you or somebody else may have done in the past on that machine or laptop or whatever you are using. If they do not appear there, we can get access to these from the View menu on at the top of our screen. So I'm going to see the Project Explorer here and the Properties window. They are the two windows that we can see on the left of my screen right now. Some of the options directly above that, such as the Locals window, there will be other stuff that we'll see throughout this course. Personally a big fan of the Locals window, so that will definitely get some coverage. And also things like code and objects at the top there as well. Looking at the windows we have, this Project Explorer as they call it, I can see I've got two projects. I have Book 2, which is the file open at the moment in my version of Excel. You would see all the files that you have open there if you have more than one. I can also see personal.xlsb, which is that hidden workbook, the personal macro workbook, where I could store macros so that they're globally available to me for any file. Once again, you may not see that yourself. If you've not used it before, it would not have been activated. More on that later on. But I've got two projects as they are known. Within the file I've got open, it shows me 3 sheets and then the book. So however many sheets you've got open, and they'll have their name there, and the book itself. These are different objects, different things that we can access and write code to them or use their events, this kind of stuff. If I double click on any of them objects, such as this workbook, it would open up a code window on the right for that object, so I can start to write code for it. I can see, I just double clicked on it so I know this, but right at the top of our screen I can see it says this workbook code. Handy that, because all your code windows will look the same. So it's good at the top that we can reference what object or what module am I in, what code is this. So for example, if I double click on sheet 1, I get another code window. Along the top I can see this is the code window for sheet 1. I can double click on this workbook and I'm back to there. In the top right of this screen you do get your normal kind of minimize and restore buttons that you'll be familiar with. Personally, just double clicking will get you between these windows. You may decide to close one down at some point with the X, but personally I never bother with minimizing and stuff. We can just switch between them by double clicking. Now, although I mentioned writing our code in here, and at some point in this course we will, because we'll be covering a topic called events, and that is when we're going to look at adding code to sheets and to books. If you're not running your code off a worksheet event, such as somebody moving a sheet, or to a workbook event, like somebody opening a workbook or saving a workbook, then what you should be doing is adding your code to a module. That is where Excel put our recorded code from earlier, it put it into a module. At the moment I don't see any modules on the left hand side. What I'll need to do is go to the insert menu and into module from there. And as I click module, I get this modules folder and the module itself appear. And this code window now, I can see at the top of the screen, is relating to that module, module 1. So you can create as many modules as you like, you can rename them, and you can add as many macros to them as you like. Just think of these modules as a storage container for your macros. In the same way that you probably create folders to store your emails, there's no need for you to do that whatsoever. The only reason you do that is so that you can organize them better, you can find your email within the relevant folders and so on. How many folders you create, what you call them, is completely up to you. The same idea here. I could put 20 macros all in one module. I could, put a different macro in a different module. However I decide to organize them for me or my team's benefit. Now the window below that Project Explorer is the properties window. There's not too much to say about that just yet. The only thing they're really shown in there for module 1 is the ability to rename that module as mentioned. That will come up the main area later, being when we start looking at user forms, and we'll be naming controls and playing around with a lot more of the settings that you get in there. You get a lot more properties. For now it's not offering us too much, but we'll see that as I do click on other objects I will get different properties for them. So that will be contextual depending on what object we have selected at any given point. Or be able to modify some of its properties. So for now, that is all we're going to cover, talking about this Visual Basic Editor. This is an introduction to it. If I click the X in the very top right hand corner of this editor, it will close it back down and take me back to my Excel screen. So that VBE, or that Visual Basic Editor, is a separate window entirely to Excel. It uses Excel to run, but it's a separate window. So when I click Visual Basic, it opens up. I can close it down fully and I'm back to my spreadsheet. Or indeed I can click Visual Basic to open it up. I can use my taskbar at the bottom, or look at things like minimizing and stuff to get to my spreadsheet. And I can always use things like Alt and F11 to switch back to it. It's a quick way of getting back there. And we're back into our editor. Hello and welcome to this video tutorial where we are going to look at writing our first macro. So exciting stuff. This is where we're going to start writing one from scratch. And it's just going to be a simple example to begin with, to get familiar with VBA grammar and how you can begin and lay out our macro, our code. So what we're going to look at doing is just writing a simple little macro that when we click a button we'll put today's date in cell B1 and it will increment the value in cell B2 by 1. So it should change 351 to 352, but whenever we click it, if I clicked it tomorrow, it would put in tomorrow's date as it would be, and then 353 if we had already changed it to 352, but incremented by 1. And then we might get it to display a quick little message at the end, like we saw in one of our previous tutorials. So first thing is to get that Visual Basic Editor, the VBA, open. And we can do that from the Developer tab and Visual Basic, or the keyboard shortcut of Alt and F11. So that will open our VBE. Open it pops Project Explorer on the left there, showing that I have a file open called First Macro. I've got 3 sheets in the workbook, but at the moment I do not have a module that I can use to store my code in. So I'm going to insert one. I'm going to go to the Insert menu and Module. Make sure before I do that I am somewhere within the project that you want. You may only have one project or one file there. If not, make sure you're somewhere within that hierarchy so that when you do insert the module, it appears within there. And you'll get a modules folder with a minus sign to collapse and plus to expand that list, and one module with the window immediately opened. Remember from earlier that we know that's that module 1 window, because along the top it says first macro.xlsx module 1 code. So I know the project and object that I'm in. Now we can see in the properties window just below the Project Explorer that I can rename that module if I want. So I might call it first macro. Not a legal object name. What have we done? No spaces. Remember, within macro names, and as we go through this course, obviously module names, also things like variables, and no spaces in the names that you provide. If you see that it's asking you for a caption or a label, you can generally put names in that. That's something that's visible, but not in the actual name. So a bit of a recap there. Let's change that to first macro with an underscore. Is it happy with that one? It is. And you can see it's renamed within the Project Explorer. Okay, the macro itself. Now a macro in VBA is known as a sub-procedure or subroutine. This is the proper term for it. We can call it a macro still, it's interchangeable, that name. But it's known as a subroutine or sub-procedure. And the reason for that is because we're going to start with the word sub. Space and then the name of this macro. Let's say I'm going to call it new ID. I'm clearly making this stuff up. I'm going to call it new ID. No spaces, so I've got an underscore there separating them. Another common approach is one known as camel casing, where we can join our words together using capitals to separate the changing words. I'm going to keep that now I've got it, and I'm going to press enter. So enter as usual would put you onto a new line. What it also does is put these parentheses on the end. Now we didn't have to write them, but your macros or your sub-procedures should always have them brackets at the end. At some point throughout this course we may well be using them. We'll be using it to pass arguments and variables and stuff. But for now we can just rely on the fact that Excel is going to pull it in for us. Also capitalises the S of sub. Don't know if you noticed, but I wrote that all in lowercase for speed purposes. Turns it blue to show it's a reserved keyword. It knows what that word is. You're also not allowed to use that word as a name of a macro or module or variable. It also puts end sub in, so I've got a kind of framework here for my macro. All my code would go in the middle of them 2 lines that they've created. Now it's not necessary, but a very good idea for me to press enter a couple of times to get some white space in there, and then to maybe move into the middle line and use my tab key to indent. Function wise, it is not necessary to do that stuff, but universal practice. Any macro you come across via Google or reading the book will be using this way of laying out their code. It brings clarity to it, so it's much easier for you or your colleagues to read now or at a later date. Yeah, that's what it's all about. It's about the clarity of it. And we'll see this practice, especially the indentation of code and these extra spaces, just to, there is some kind of universal way of working here, which we'll stick to as much as we can, because it's what you're going to see out there when you're doing it for real. But also you can add your personal touch on this. What makes sense to you? What's a logical way of displaying this code to make it as easy to read and understandable as you can? Remember, you might be coming back to this in 2 years' time and you'll forget all about what you did and you need to get up to speed quickly. Okay, now the first thing we're going to do is we're going to put the date in cell B1. So I've got this Visual Basic editor open. Remember that I can always restore this if I want to, and I can move it and see my spreadsheet in the background. They're two separate windows, these, and I can see that date is cell B1, ID is B2. So I'm going to write range. I've got my caps lock on there, it would seem. Let's try that again. Range, but it matters that much. It would have changed it for me. Open in parentheses, then opening double inverted commas, opening speech marks. I'm going to write B1, closing speech marks, closing parentheses. So what I'm using here is what's known as an object called range, and it is one of many ways that you can select a cell within your code. It's probably the most common way. It's the way that you'll see when you're recording macros that it goes far. It's an absolute reference to that cell B1. It has to be B1. Now I'm going to put a full stop after that, or a kind of period, and I'll get this drop down list of what are known as properties and methods. Things I can do or information I can see about that cell. So there's a large list here. All the ones with an icon showing a kind of piece of paper with a finger pointing to it is known as a property. So it's a bit of information I can view or change about this cell, such as its address, which may seem silly here because it's B1 and I've just written that, but such as its address, or what else have we got in here that's good? Throw something up for me, come on. The entire row, what row is it in? Just select it there. What's its height? Does it have a formula? This kind of stuff, information about it. All the ones with this kind of flying rubber are known as methods, and a method is an action. So we can see here, apply an advanced filter, add a comment to it, calculate it, check the spelling of it, actions you can perform on it. So properties and methods. This drop down list can really help you out at times. It doesn't matter how much you do this and how used to it you get, you will forget to spell things or the exact name of something. It can jog your memory. What I'm going to go for here is I'm going to put value, which I can see is a property, what information is inside that cell. And then I'm going to follow that with an equals. Equals is known as the assignment operator within VBA. So I'm going to assign something to the value of B1. And what I'm going to write is I'm going to write date. Now date is an inbuilt VBA function that will capture today's date from your computer's clock. Now you may know from your own experience or through going through our superhero course that in Excel normally there's a function called today that will put in today's date. For some reason in VBA it is called date, not today. Same job, different name. And you see that in a few other areas as well. For example, VBA has a function called isNumeric, which is the same as an Excel function called isNumber. They're very similar but different. But there's an inbuilt VBA function to put the date in there. Okay, I'm going to press enter to move to the next line. VBA is a procedural language. Every command, every line of code has to have its own line. I can't begin writing the next code after it. It has to go in its own line. And the next line is going to increment the ID in cell B2. So what I'm going to do is I'm going to take a copy of the line I've already got. Copy and paste is an essential programming skill. Just copy and paste however you feel comfortable to do so. I'm just going to change the 1 to a 2 and then change the date to what I need. So copy and pasting will always save you time and improve your accuracy of your code. Definitely an essential programming skill. Now this time, once again, I'm assigning something to cell B2. This time I want to increment the current value by 1. So what I'm going to end up doing is I'm going to copy that line of code again over date. And after it, put +1. So what I'm doing is some area where it's different in VBA to what we would have done normally is that the right hand side contains the calculation. So whatever value is currently in B2 +1, and then that is assigned to B2. So it looks like we're duplicating things, we're writing this twice. And you don't normally do that when you write a calculation write a formula in Excel normally. But bear in mind that equals in VBA is the assignment operator. It's a little bit different to what it is normally. So we formula on the right, or function, and then assign to what's on the left. So what we've done so far is we've seen an inbuilt VBA function. We've performed a formula and we've been referencing cells. Not a bad start to our macro, writing our talents, hey. Next up, we should look at inserting a comment. So I'm just going to move that down one more space and put it on the line above. We can add comments on its own line, on the end of a line, however we want. And these comments can be used for different reasons, but essentially it's a line of text that does not run. So you can use it mainly to leave notes for yourself, to leave comments, explaining sections of code. So if you did return to this in 2 years' time, you can read that and know what each section means rather than trying to interpret it all over again. There are also techniques to use it to kind of prevent lines of code from running when you're kind of troubleshooting errors. There are other reasons to add this in. But to add a comment in, all we do is we start with an apostrophe. And then we write our line of code. So I might put enter today's date and increment ID. And trying to explain what the next few lines of code do, so in the future when I come back to it, I don't have to interpret this. Now these are easy lines of code, so maybe a bit pointless here, and there's no reason to overdo your commenting. That doesn't make sense and it's counterproductive. As I click off that, we notice that the line goes green. Comments always green. It says a line of code that does not run. It's only there for notes for yourself. It's a notes area. Now what we've done so far when we assign these two values, just to add a little bit more information to that, we're getting familiar with VBA grammar or VBA syntax and kind of its terminology. And you'll notice that when we use VBA, we use what's known as the object model. And we'll be doing this throughout the course, using things known as collections and objects and this other terminology that may seem a little bit alien at first. But VBA is all about learning the object model. And fortunately, you know a lot of that already. Because you're an advanced Excel user, you already know a lot of things you can do in Excel. Things like print area, pivot table, charts, font formatting, protection. And you may already know this stuff at different levels. So you kind of know where to find it, and you've got a bit of understanding. It's not completely new, this. Now, unfortunately, it's not that straightforward. They will use sometimes different terms, and it might catch you out a little bit, but we've got a massive head start on it. And when we use this object model, what I mean is the lines of code we write, we always write the name of an object, like range, worksheets, pivot tables, charts, something like this, and then we put a full stop and we follow it with either a property or a method. So we perform, we assign information to it to a property, or we tell it to do something via a method. And this is a common theme we'll see, affecting a property or a method. It's always object dot property or method. And here we're assigning, or if it's a method, we might have to provide additional information. For example, if I press enter a couple of times, in my mind I'm just using a blank bit of line there, blank bit of white space, just to break these into two different sections to make it easier to read. And I'm going to write MSG box, something we saw on a previous video. And this is an inbuilt VBA function. Now, after typing that, when I press my space bar, I get this yellow box pop up. And the great thing about this, backing up what I said a moment ago, is the similarities to what you already know. And especially if you took my superhero course, we would have done a lot of different functions, over 30 different functions we would have done. And we would have spoken and seen how they're all written the same way. They have their odd little quirks at times. And this is the exact same syntax. Notice how after MSG box, they ask you to put brackets in. And then they show different arguments, different information, separated by a comma. If information is optional, it is wrapped within these square brackets. So it's saying, look, at the moment you're on one called prompt. This is mandatory. Next up is buttons, then title, then help file, then context. All four of them are optional. You don't need them unless you want them. Now, you may not know what they mean. You may look at context and think, well, what does that do? How do I use it? And we can always use Google or a book we may have at home to help back us up as a reference there. But the key skill is we know how to use it. We're getting used to terminology and VBA grammar. We know we use arguments by separating them with a comma. And this is how we get going with using it. In this example, we just want to display a simple prompt. If I want to display text, we should also know from our standard Excel skills that we wrap text within speech marks, or these double inverted commas. So I can just write the ID has been where we're going, updated. Take a bow. So I've got a silly message in there. This is mainly for the purpose of showing you this this tooltip popping up, helping you, and the similarity to functions as we begin to move our way through the day. As I click off again, VBA run what they call a syntax check, and they're tidying it up, putting spaces in, capitalizing letters, checking it makes sense, we haven't made a typo or something. But I've got another message box in there now, inbuilt VBA function. I could add a comment, a very pointless thing to do really in this example, but just to cement what we spoke a moment ago, message box to chat with user. There are loads of powerful ways to use a message box. They will be coming up again and again in this course to provide information to the user, to ask them questions and interact with them. Absolutely incredible tool. It's definitely up there with something you're going to see an awful lot in your VBA career. But here we are writing our first macro. 3 jobs is what it does, comments to lay it out, and it's neat and tidy and easy to read. And we've got a good head start here on what's known as the object model. Last thing that's left for me to do is to look at running this macro. Now there are loads of ways of doing that. The way I'm going to demonstrate to start with is this green arrow up on our toolbar known as Run Sub User Form. Mentions that F5 is the keyboard shortcut. We could use that to run this macro. But that is one way you can run your macros to test that they're working on your sample file. If I press that now, that code runs. I can see it's incremented 351 to 352. Hashes, must be a date in there, but it's not quite big enough, that column. And my message box saying I can take a bow. I'll click OK to that and I can see it's working. Let me resize that cell. And indeed, let me delete the contents of that cell. Alt and F11 to bring back my editor. So that's one way that we can run this code. Let's recap on another way we've already seen. I'm going to click outside of there. And I'm going to go to the View tab and the Macros button. A longer way of doing things, so when you're up and running, I can't see you doing it this way. But I wanted to go this way to show you that our macro is in there. So we've seen recording macros and accessing it from this dialog box. Now we've gone into the editor and written one with our own code from scratch, but it's still existing here as a macro. Macro, sub procedure, same thing. I can click run and that will run that code. So now it's gone to 353. It's the same date, so the date goes in as the same message box. You can see our macro running on that code and doing a job when required each time. All we'd need is a logical way of running it now with a kind of button on our toolbar or our sheet. That's something we've already covered, so we won't worry about that for now. We'll get on and start talking about some more VBA topics. Hello and welcome to this lesson on cleaning up recorded code. So the macro recorder is a fantastic tool that is always going to be there for you to quickly generate some code, faster than you could type it, but also to generate code on Excel features that you may not be too familiar with from the VBA side. So you may not know how to write the VBA code to create a pivot table, or merge and center cells, or delete an entire row, or something that you might be quite comfortable with from the Excel side. But you could always record yourself performing them actions and then work with the VBA code afterwards to either wrap it inside a loop, perform some decision making on it, or to tidy it up that little bit more. So the recorder is always going to be there for us, but it will generally generate more code than what you need. It generates a lot of redundant code, and it's not always the cleanest way of doing something. So, being able to work with that code after is essential, but it is certainly not to oversee what the recorder could do for you and how helpful it can be in kind of solving situations. Now we're going to look at a couple of classic examples of the recorder generating that extra code that's not necessary. And I'm just going to start up a recording for the first example. And I'm going to record a macro which I'll leave as macro 1. And all I'm going to do is enter some text in 3 different cells. So I'm going to click in cell B2 and I'm going to type a name in there. Then I'm going to move into cell B3 and I'm going to type a name in there. And I'm in cell B4 and I'm going to type a name in there. So I've just entered 3 bits of text into individual cells. If I stop my recording, and I'm going to go and have a look at the generated code by editing the macro. And this is what we get. So we can see I've got 7 lines of code to write, text inside 3 different cells. It's had to select cell B2 before it then writes the name John Steele into it, and then select cell B3 before it writes the name Sarah Harding into it, and so on. Now, it's not necessary to select a cell to perform an action on it, but you'll notice the macro recorder will generally do that. So we can shorten these statements by removing the select element and by putting it all on one line. So I'm going to take out the select element and then the following active cell.formula R1C1. We don't need that. We also don't need this period, this full stop, because I've not gone into a method like we did there with the .select. Just the range B2 equals John Steele is good enough. Now, in fact, you might, and throughout this course, you'll probably see me write .value on the end of range B2 there. So I would put a property on the end of it. Now, that's not necessary either. So we could, for this example, just remove that to show that is all you need. You will, however, throughout this course, probably see me do that. I'm preferable to putting .value there, believing that it makes code easier to read for the masses, whereas some people might not be sure what property they're accessing there. Now, maybe with this one it's obvious because text, I'm clearly putting it inside the cell, but depending what that object is, you may not know the default property or method, of which for range it is value. Okay, I'm just going to continue and clear out these select methods, and I'm also going to remove this last select, which was generated by me pressing enter after typing Tom Cruise. So it moved to the cell below, as Excel does by default. We don't need to move to that cell. I'm going to close down this editor with them 3 lines. Delete the names from the cells and click elsewhere. I'm going to run that macro, which will just re-enter them 3 names. So you've got less than half of the code that we had originally there. It was 7 lines, it's now 3. It's a quick and easy example of the redundant code that the recorder generated. However, although we've already written this ourselves on this course already, it also showed it generating code that we may not have known maybe beforehand. Okay, a simple example for now, but you've got some code that we could then work with afterwards. Okay, for a second example, I'm going to start up a recording again, which I'm going to leave as macro 2. And on this example, we're going to look at the use of a dialog box. And I'm just going to look at formatting some cells. So I'm going to select them 3 names, B2 to B4 there, and I'm just going to do a couple of examples of formatting that text. I'm going to make it bold. I'm going to change the font size to size 12, and I've decided to center align it as center align. Okay, I'll stop that recording and we'll go and have a look at what our code looks like. Macro 2 and edit, and this is what we get with uses of dialog boxes. Notice how much code we've got now, but in all of that I've got the initial selection of them 3 cells. If you wanted this to work in any given situation based on user selection, then we don't even need that. If it's always going to work on B2 to B4, then I should have that in there.
and for now I might leave that. We've then got turning it bold, we need that, and then we've got this use of the font dialog box. So even though I didn't directly use the dialog box, I changed it on the ribbon, it's recorded everything from the font dialog box. And the only thing I changed in there is the size. So I don't need this Calibri mention, and I don't need all the stuff after it. Now it's the first time on this course that we've seen this with construct as well. That we're saying with selection.font do this. Now because I'm doing only one thing to that, well, to be honest, I'm doing two because we've got bold above as well. I don't really need the with kind of construct, which is used when you're doing multiple things to an object. So I'm also going to remove the with elements of this. Let's take out these white space and move it all onto one line. So selection.font.size equals 12. And now we've got this extra with construct now, where it's looking at the alignment group, is it? But on that format cells dialog box and the alignment tab. Now the only thing I changed on there is the horizontal alignment, center. But once again, it's recorded everything else. Is wrap text on or not? Did they indent? Did they merge cells? But once again, I don't need them extra options. I just need the center align. Once again, because I've only got one thing, I don't really need the with construct either. Although, looking above, these other options are using selection too. Selection.font, selection.font again, selection.horizontal alignment. So I could get these two lines and cut and paste them within this construct and remove the selection from each one. Get rid of that white space. Maybe you had one before the sub there. And we're just looking at cleaning up the way the code looks so it's easier for people to read and to work with. And also that it's faster. We don't need to make changes to settings that don't need changing. So all I've had to do is select those three cells, and within this with construct I've performed three things to the selection: center align, bold and size 12. So if I was to close down this editor, and if I can just take those settings off, bold 11, left align, and click elsewhere. If I go to run macro 2 as it is, it will go and perform those three actions again. So a couple of examples there of cleaning up recorded code. We've got the use of dialog boxes and all this additional code being created that's not necessary. And also the way the recorder selects a cell before it performs an action to it. Two classic redundant recorded code. Hello and welcome to this lesson on working with arguments when writing VBA. So whenever you use a VBA function, or when you use an objects method in VBA, you may have to write some arguments to it. You will get some mandatory and some optional arguments supplied with your methods and functions, just like you do with inbuilt Excel functions such as VLOOKUP and if and average and so on. Now you won't always have to enter some, but quite commonly you will. This extra information for that method or function to work, or to work better. Now for a quick example of different ways that you can write those arguments, I want to use the protecting workbook feature of Excel. So to refresh our memories, if I went to the review tab and clicked protect workbook, this is the dialog box that you get. That it is used to protect the structure of the book, typically to stop people unhiding sheets or inserting sheets or moving and copying sheets, and anything that is the structure of that book. And you've also got the option of windows to protect things like freeze panes and split panes, and also a password that is optional. So structure and windows, 2 checkboxes, password, a text box, completely optional. If I cancel that, and I'm just going to pop into the editor, so if I do Alt and F11, the keyboard shortcut to open the Visual Basic Editor, and I'm going to insert a new module within my project here, my Book 1 project. Insert module, and I'm going to start up a new macro, which I'm going to call Protect Workbook, without spaces. And here we go. So what I want this to do is to protect a workbook, protect the workbook I'm currently on. I'm going to write active workbook, so I need to reference the workbook that I want to protect. Then I'm going to put dot and protect, so scanning through the different properties and methods that you can use on a workbook. This one being the active workbook, the workbook that the user currently has currently is in right now, the one that is active. And I'm going to look at protecting it. Now if I put a space after protect there, it will appear with its arguments. So first of all, it's saying that I could have put parentheses around these. I can see the parentheses around the arguments here, like you typically would with a function, but you don't see people do too often in VBA. But then it prompts us for the 3 bits of information. And the reason I wanted to display it in Excel beforehand is to refresh a memory of what the dialog box asked us for. Because we see that it asks us for the same stuff here, although in a slightly different order. It asks for the password first, then the structure, then the windows. And you might remember that in the dialog box, it asks for the structure, then the windows, then the password. So let's say for a moment I don't want to use a password. I do want to protect the structure, and I do want to protect the windows. Now one way I could write that is to put a comma in to move past the password, type true, dear me my typing, type true for the structure, and then a comma and true for windows. So because structure and windows are checkboxes, they will have a Boolean value, they have true or false logical value. And I'm just going to move away from that line by clicking elsewhere. And the editor is quite happy with that statement, that it's going to protect the workbook without a password, but it will protect the structure and Windows elements. Now if I close the editor down and look at running that macro, view macros and run protect workbook, it does indeed protect my workbook. If I click on review, I can see that it's lit up. If I go to view, I cannot freeze panes. And if I right mouse clicked on a sheet tab at the bottom, the structural elements are disabled. So that has protected the workbook with the structure and the windows that I wanted. But if I go to review and click protect workbook, it unprotects quite easily as there was no password. So if I switch back to our code, that works an absolute dream and was maybe quite fast for me to input. But I guess the counter argument on writing these parameters is quite clear, that that's not very descriptive as to what it does. Especially knowing that when we looked at the dialog box, it asks for structure, then windows, then password. But in VBA, it asks for password, then structure, then windows. So what I'm getting at here is if other people are working with this code, or if you are, unless you know the VBA side of protecting a workbook very well, you're not going to know the name of every single argument it has and the particular order that it goes in. Just think how much stuff Excel can do. It's impossible to know it all. You're just going to remember off your head the classic and typical things that you use, and the rest you'll find out as and when you need it, via Google or by recording yourself doing it and having a look at the code. So if I backtrack on this for a moment and look at recreating a startup by hitting space, another way we could write that, the last way I'll demonstrate for now, is that I could write structure colon equals true, and then comma Windows colon equals true. So I've not bothered mentioning password as I've not done it, and when entering the other arguments I've used its name. So I've said the structure is true, the Windows is true. So I'm only using the ones that are necessary. Yes, and it's quite clean to read because, as long as I'm aware of protecting the workbook, I know exactly, when I'm reading it, it says it straight off, does exactly what it says on the tin. To confirm that it works, if I close that editor and I will rerun, where am I going? Rerun this macro, run protect workbook, and that once again is protected with freeze panes and the structure, which I can undo by clicking the button because there's no password. So this was just a quick look at a couple of different ways that you can write the arguments for a method or a function. In this example it was a method, it was the protect method of active workbook. So it's something that we're going to do throughout this course. We can't escape, but you might see it entered in different ways, both by me during the course, but also back at your place of work or wherever you find yourself using VBA and looking at other people's code or your own code over the years. It may be written in different ways, and we have to get familiar with the different ways that we could see code written. Hello and welcome to this lesson on writing VBA to reference different cells, sheets and workbooks. Now, how could you have a macro or a sub-procedure without the need to reference the different cells of a sheet or the different sheets of a book? That would be one unique macro there. So we have to know different techniques for doing this, and there are loads of ways, absolutely plentiful of ways that you can reference different cells or different workbooks. And a lot of the ways you use will all depend on the context. So depending where you are at the point, or where the user is at the point that the macro is running. Are you looking at writing it to the cell the user is in, whatever that may be? Or are you looking at referencing a different sheet? Do you know that sheet by its name, or do you literally have no idea and you need another way of referencing that sheet? So this video serves as a way of looking at some of the typical examples of doing it. We're going to look at some different ways of referencing, some of the more popular ways, I would say. And what we're going to look at doing is building up a list of expenses here, pretend list of expenses, just using some different techniques. And we're going to finish off the video looking at copying that to different sheets and different books, seeing different techniques for referencing sheets and books as well, and also as a byproduct looking at copying and pasting in VBA. Okay, so first of all, I'm just going to open the Visual Basic editor. See if I use Alt and F11, and I'm going to insert a new module into this project and create a new sub-procedure which I'm going to call referencing cells. So shooting through that because it's something that we have done already during this course. And the initial way that we're going to write our first expense in is I'm going to use the range object. Now this is also something we've already used in this course. It's, dare I say, the most popular way that you're going to see a cell referenced, and the main way it's used, although you may see it in different ways that are, let's say, far too plentiful to cover in one video, where it will be about 2 hours long, is to reference it using an absolute reference. So I'm going to write in a reference here to cell A3, which is the first cell, the first vacant row, the first cell in our expenses sheet. So using the syntax of some parentheses and the speech marks or double inverted commas around A3 there, I'm going to use dot value, the property value, to write to that cell, and I'm going to assign a number 1 as it is the first ID, our first expense. Now, an essential skill of programming any language is to copy and paste. And I'm going to copy that statement 2 more times and change the references to B3 and C3, and then what I'm assigning. So I'm going to go for some notepads, and then a value. I don't know, £2 spent on some notepads. So we've got this line that will enter it straight into that row there. So if I was to hit this play button at the top of the editor to run the macro, it runs and puts the information, and as I can see in the background there, as I have my editor restored, window restored, I can see it put it into row 3. This is our first way to reference cells, something that's not really new because we've covered that sort of technique in this course. Okay, now I'm just going to put an apostrophe to the left of those lines to comment them out. We mentioned comments in an earlier video as a technique for entering notes and entering information for yourself or for others. Normally to identify different segments of code. I'm using it here to disable them lines. So rather than delete them, I thought I'd leave them there and just disable them temporarily. So when I save this file at the end, it will be available for download on the course, and we can see the code that was written. And for my next technique, I'm going to use the object called cells. Now the example I'm going to use here is not a very good example of its use, but it's just to put that object out there early doors, ready for the remainder of this course, where it will become far more important. Cells is absolutely fantastic in use with loops. It is probably the best way of referencing a cell within a type of loop called a counter loop. For this example right now, I'm going to use it to put a new expense in row 4, and note it asks us for the cell reference via index numbers. So the index number for row 4 is that it's number 4, comma, column index for A is 1. It is the first column, closing bracket, dot value. So yes, this is not a very good example. You don't really want to be referencing cells like, row 23, column 7. It's not very easy to do. It's extremely difficult, and even worse reading. It's just not the way to do things. But when this is used within looping, I say it is awesome. A scenario where you don't know the row and column reference, but have been stored in things called variables, which is another topic to come in this course. So trust me, I'm throwing it out now, so it's not completely alien later on. But it would work for us right now, if not the best technique. And I can copy these, like before. This time changing the column, but instead of to B, it's to number 2. Instead of to C, it's to number 3. And think of something else I might buy. Let's say it's an ink cartridge. And that has cost me £6. And if I play, This macro, it will not run the commented out code, only running these, and will use these index numbers to store that information. Okay, so there's a cells object. Now next up, and you might have been thinking this throughout this video, is that if we were doing this in reality, we don't know the next empty row. Sorry. Well, we'll do by looking, but we won't know it, just straight off the back when hitting a button, maybe, especially if it's from a different sheet. Oops. So what we're going to look at doing is writing some code to shoot to the bottom of this list, and then we're going to enter information into these different cells without using their specific location like we've been doing so far. So the technique I'm going to use is, in our code, I'm going to ask it to select cell A2, so the header of column A, and they're going to write the code that essentially does the same as us using control and the down cursor arrow. So we do control down, shoots to the last row in a list. Now, you might have used that technique before, and I believe I did on a previous video when we were recording on this course. And we could always record ourselves doing that. But now we're going to try and start writing this stuff. So what I'm going to write is range A2, because that's the range I'm using. And I'm going to write dot end. So one of the properties of the range object is end. I'm going to select that. Opening parentheses. So it asks us for a question. What end? XL down, left, right, or up. The same as your cursor arrows on the keyboard. I'm going to say down, XL down, closing bracket, dot select. So that line there is the same as what I just demonstrated, where it will shoot to what's currently cell A4, but in reality we would not know, the bottom of that list. Now I need to move one more cell down, because that's not the empty row, that's the bottom of the list. So I'm going to use an object. Whoops, sorry, I'm not going to use range. I'm going to use active cell first of all. Active cell is amazing. It is such a key way of referencing to know. It refers to the cell that the user is currently in. And a lot of times in your procedures you won't know that. The user's got to hit a button at any given point and you want to apply it to the cell they're currently in. But we don't want the cell I'm currently in. I want the cell below where I currently am. So I'm going to use a property here of active cell known as offset, which when I put an opening bracket after offset, which is a brilliant way of moving relatively around the worksheet. It asks me how many rows and how many columns would I like to move. I'm going to ask it to move one row down, a comma, and 0 columns across. Can we just move one row down? Closing bracket, dot select. So I'm moving one cell below the active cell. Now that I'm in that cell, I can write active cell dot value. It's now looking at putting a value into the cell I'm in. Equals, and their next ID is number 3. And now I'm going to use the active cell to reference the cells to the right of where I am for the expense and the amount. So I'm going to put active cell dot offset 0 rows down, but 1 column to the right, dot value equals train ticket. And if I copy that line, or some of that line, I'll move 2 columns to the right, and I'll put in a value of £20. So we're moving to the bottom of the list, offsetting down 1 and entering this information. Now in this case I want to click somewhere different on the sheet, and instead of just running the code, I should really comment these others out first as well, I want to step through the code so that we can see this working line by line. This is a fantastic technique for debugging errors in code, for trying to understand how somebody else's or your own code in 6 months' time works. And to do this we need the F8 key on the keyboard. Now I can also run it by using the debug menu at the top. And I want this step into approach. Let's say the keyboard shortcut is F8. So if I press F8, it will go from the first line at the top, sub-referencing cells, and every time I press F8 it will step an extra line through our code. So I'm on range A2, Excel down, and as I press it, looking on the sheet in the background there, it shoots to cell A4. So it's gone A2, Excel down, and the last row is A4. The last cell is A4. If I press F8 after offset 1 cell or 1 row, it moves 1 cell down, then puts 3 inside there. Then we're going to see it put train ticket in. Notice we don't see the cell move anymore because we're not selecting, we're just referencing it. Dot value, and then 20 in the last cell. So now we've got some code that can move relatively to the bottom of a list and input this information. So we're getting one better there. But we're going to change that a little bit more. Now, on a previous video we looked at cleaning up recorded code, and now I'm going to look at cleaning up my current code. Before I do that, I should exit what's known as break mode, which I could do actually by pressing F8 one more time, because I'm at the end of this procedure. But probably worth a mention now, I can see that I've got a yellow arrow and a yellow line here, and right at the top of the screen it's got the word break in square brackets. So it's telling me I'm in something called break mode, which some people call debugging mode, because as we see as the course progresses, you generally come in here by hitting a debug button after getting a runtime error. I'm going to hit the blue square on the toolbar, my reset button, to reset that and come out of break mode. And I want to put these 2 lines onto 1 line. There's no need to select the last row and then select the one below it. I could put that in 1 line. I could remove this select at the end of the first line there, and take out active cell from the one below it, and in 1 line I could just say range A2, Excel down, and offset 1 more off that. So I can get this working in 1 line now, which is far more effective, much cleaner. Now to be honest, I don't even need to select it, I could write the value in all in one go. But I'm not going to do that. You have to draw the line at some point, and this code needs to be readable. And to offset, a certain number of cells and stuff is just going to be confusing to people. So I'll put us in there, and then I'll use active cell to reference. So if I change this to 4, or in fact, tell you what I'll do, I won't change it to 4, because I don't know the next row, the next ID. Instead of 4, we're going to write that we want to assign active cell dot offset. What I want to do is reference the cell above, which currently has 3, and I'm going to plus 1 on top. So it's going to increment the ID number on its own. So I'm going to put to offset -1, the 1 row up, comma 0, 0 columns, closing bracket, dot value, and I'm going to plus 1. So So that should now look cell above, which is 3, plus 1 to 4, and add that in. So if I click elsewhere, and if I run this code by F8ing through, I can see it move immediately into the next empty cell, A6, add 1 on top to get 4 in there. I've got another train ticket for £20 here. I've forgotten to change that, but that can happen. I do buy a lot of train tickets, unfortunately. Really damages my wallet. And in it goes as we move through. It's now able to go right to the bottom, put it in this next empty row, and increment the ID number. I'm going to press F8 one more time. I don't need to hit the stop to exit break mode there. I can just complete the procedure as it would be. So now we've managed to get a fourth expense in using some other referencing techniques, Excel down, offset, and we've even looked at different techniques for offsetting, a little formula there. Now for the next example, I want to copy that expense sheet onto sheet 2. I've got sheet 2 on here, which currently has nothing on it. I want to copy the whole of this range, which I don't know how big that range is. I'm just going to comment out our previous code so that I keep it there for reference on this file. Actually, I could have kept that, because what I'm going to do instead is I'm going to create a new sub-procedure. Let's get rid of that locals window. We'll see it later in the course. Alright, sub copy list. And I'm going to put this in a different sub-procedure. We're going to have a couple of lines of code that are going to copy that whole list and then paste it onto a different sheet. Now first of all, to copy that whole list, once again many ways of doing so, I want to take this opportunity to see and use current region. So I'm going to write range A2. Now I've got a variety of choices of what range to use here, but I'm picking A2 as arguably the most logical cell to use, being that's the initial heading. It's something I can guarantee is there and I can use, and is easy to remember. I'm going to put dot, and I'm going to use current region, which is your kind of select all approach. It's everything in that list from A2. So as it looks around its boundary, it knows the whole list. Current region dot list of properties and methods. I'm going for copy. I want to copy the whole of that range. So in effect, copy region is the same as us kind of doing a select all from cell A2. Let's select all in here. Am I going mad? Let's do a Control A. Is that full select all was up there? So it's going to select the whole region as it knows it. It's not always going to get it right. You have to be careful with that in your range. But current region dot copy. Now I need to paste it onto sheet 2. Now I could write sheets and reference the sheet by its name. As we can see in our prompt here, I can also reference the sheet by its index number. So it would quite easily work if I just put number 2. Now in this case I want to use sheet 2, pretend that I know it by name. But once again in this course we'll see techniques like this when looping, really, going through all the index numbers, all the sheets. Just going to return to writing sheet 2 and using it by its name. Notice the reference to the sheet used the same syntax as range. That I've got the opening parentheses and the opening speech marks on there. Yes, so as well as sheets, another way you can reference is worksheets. Now it's a very fine difference between worksheets and sheets. In this example, I could use either. The main difference really is that if I reference a worksheet, I reference in a worksheet, and sheet 2 is a worksheet. So I'm referencing a sheet, I'm referencing all types of sheets in Excel. And for example, when you create a chart and you move that chart to its own sheet using the move chart functionality, you're getting a chart sheet, which is not a worksheet. So there's a very fine line between whether you're referencing all types of sheets or a worksheet. And in most cases, you can probably get away with either. But in this case, you can get away with either. But there's a very fine difference, and you need to be aware of the difference between worksheets and sheets. Now, what I'm going to do is I'm going to reference range A1 on there, the very first cell on that sheet. And I'm gonna use paste special. How useful is paste special in Excel? Now, I can't use a normal paste here. You don't get a paste on the range object. So I have to use paste special even to do a normal paste, which is all I'm going for here. So I won't put any arguments to it, like paste values only, values and number formatting, paste formulas, and all them awesome options you get with paste special. So it's to select that range and paste it onto the other sheet. If I use my F8 to step through here, that will take a copy. I can see the running ants around my range. Next one, paste it onto the other sheet, which I can't really see because I'm on expenses at the moment. I'll finish off that macro and we'll have a look at sheet 2, where I can see we have that data on there. Brilliant. So now we've looked at code for copying and pasting ranges of data. We've also seen references to different sheets and a use of a property known as current region. Okay, now in the final example here of this video, we need to look at copying to a workbook, or referencing a workbook really, but I'm going to use the opportunity to copy to it. Scroll this down, and for this technique, let's remove that. I need to create a new workbook. So I've got a new workbook here called Book 2, and if I move back to my other workbook, reference cells and sheets, and into the editor. So I've got this workbook, and now I've got one called Book 2. I'm going to copy this range to that book. Now the technique here is that on this range, I'm going to select the range. So I want to show the example, which will be extremely common as we go through our macros, that the user has already selected the range of cells. We want to be able to work with whatever that range was. And I don't know if they've selected column A, A2 to A3, or the whole list. But we're going to work with the user selection. So I'm going to write selection. Could that be any easier? Our object called selection, which always has the current selected range. Just like active cell is the cell the user is currently in. It is as easy as that, and that is crazy useful. Now I'm going to put .copy to copy that range of cells. And now I'm going to paste it all in one go. So in a previous macro we didn't select it, we copied the range and a different statement pasted it, which you may find easier to kind of read or to use. But in this example, I want to do it all in one go. So I'm going to put a space, and I'm going to write one of the arguments that you get with the copy method, which is to specify a destination. And as we saw in the previous video, if I'm writing the name of the argument, I have to put : equals, and then answer it. And I want to answer it by referencing that other workbook, a sheet on it and a cell. So I'm going to write workbooks. So once again, always as a plural. Notice it's worksheets, sheets, workbooks. Technically that's a collection. But we always use a plural. So it's workbooks, open in brackets. I want to specify the name of the book, which I don't need an extension for in this case. You could put .xlsx. And then I'm going to reference a sheet within there. I'm going to use the sheets object. I'm going to reference it as sheet 1. I haven't renamed these, so there must be a sheet 1. Then within there, I'm going to reference a range. Oh, I forgot my my full stop there. A range, which I'm going to use A1. So I've got the full kind of object model here. I'm going through a workbook onto the sheet, onto the range. If I click off that, it checks it and sees that it's happy with it. Just got a bit too far off my screen there, haven't I? Here we go. Selection.copy, and the destination is the workbook, the sheet and the range. So if I play that, so click anywhere in the procedure, make sure you're in the right procedure, hit my run sub user form button. Now I had that range selected prior, which to test this is obviously very important. If I find book 2, the data is on sheet 1, A1 of book 2. So now we have copied data to a different workbook and looked at the selection object. So that just about wraps up this video. So, longer than I would hope, but I want to try and cover some of the key ways of referencing cell sheets and books, which we're going to do throughout the course. So we are going to have that stuff ingrained in us. It will just become second nature. But quite a few different techniques there, which are going to stand us in good stead for all the more sexy macros that we're going to get putting together.
Hello and welcome to this lesson where we look at some of the different types of error that you may get when working with VBA. Now there are 3 types of error that you can come across, known as syntax errors, runtime errors and logical errors. Now we're going to ignore logical errors for the moment, because them types of errors are when your code runs but it doesn't work correctly. So there's an error in the logic. Maybe your if statement doesn't quite calculate correctly, or your loop's not working. So the only way of solving them is to look at your code, step through it and figure out where the error in the logic is. What we are going to concentrate here is syntax and runtime errors. Now later in the course we're going to look at different techniques for handling these errors, how to recognise and diagnose when the code is running. For now we just want to look at being able to recognise them. And we're going to start off with some syntax errors, which is just when there's an error in your line of code. So, for some reason it doesn't compile correctly, and VBA doesn't like the kind of language that you've used or the grammar that you've used. So for example, just using the code from the previous video, if I was to remove a closing parenthesis off the sheet 2 reference here, and I clicked on a different statement to exit that code, I get this compile error, expected list separator or closing bracket. So there's a classical, we call syntax error, where the error is in the language that you've used, and typically it's a classic typing mistake. Yes, so we can see that it immediately points to the area of code as well. So it's a very good message. It's quite clear probably that we've missed the closing bracket at the end of that sheet 2 reference. And now it's okay. Now you get similar errors in all the classic typos, missing out double inverted commas. If I clicked away to run that, expected list separator or closing bracket. Now this one's not, well, that's the same message, not quite as clear because it took me to the wrong area. So hopefully you'll notice the closing speech marks there. I believe it brings me to this area because that's where the next kind of double inverted commas or speech marks appear. So slightly deceiving there, not quite as accurate, but the same message and something that you'll get used to seeing. I'm not saying you're as bad at typing as me, but everybody's going to make typing mistakes, especially when you get tired or trying to type something quickly. Now another classic typing mistake is on the plural use of things like workbook and worksheets. Now notice as I click away that it doesn't warn me about this. It's quite happy. Because, oh yeah, worksheets, that's fine. But when I go to my play button to run this code, or my run sub user form button, it then prompts me for it, saying that a sub or function is not defined and has selected it. So some of these errors will appear as you type, and as soon as you exit that statement and go to the next line, for example, it will warn you about it there and then. Some of them, like that one, will appear when you play it. And as I do that, I can see it also goes into what called break mode. This yellow arrow has appeared where it's got sub copy list, and it's asking me to step through the code to figure it out. It's also highlighted the area, and I can see it's because it should say worksheets. If I try and play that again, it runs through. Okay, so there are different types of syntax error, and every time we've got one there, we've received this kind of message appear to give us a prompt. Now you can turn that message off. If I went up to my Tools menu and to Options, we can turn off the Auto Syntax Check. So you still get the messages when you hit the Run button and try and run your procedure, like on that Worksheets example. But examples are missing closing speech marks and closing brackets. You do not get the dialog box, or sorry, the message box. So if I recreate one of those lines again and click away, it still highlights it in red, warns me of the syntax error, but you don't get the message anymore saying, you know, that I've missed a closing parentheses. So I can always put that back in. I might recognise the red errors. Now I'm going to go and turn mine back on. It's quite common to people to turn it off as they don't like the messages popping up. You know, maybe when you're beginning with VBA, it helps you diagnose these errors, but at times they'll start to get irritating. And just like when you use, for example, Microsoft Word, and it notifies you of spelling mistakes, it doesn't prompt you to change it there and then. It just kind of puts its hand up to say that you've made some kind of spelling mistake or typo. You can come back to it at any point, you know, even next week, and deal with it then. Okay, now the other type of error is a runtime error that I wanted to look at. So for this example, I'm going to change the sheet reference to sheet 4. As we only have 2 sheets in this book, don't know if you remember from the previous lesson, but here they are, expenses and sheet 2. There is nothing called sheet 4. So, as I begin to run this, I get a runtime error. So runtime errors have a number associated with them, and we'll look at this later in the course. You can Google and get a list of these different numbers and what they mean. But you get this description anyhow: subscript out of range, so it cannot find sheet 4. Now you get this end and debug options when you get a runtime error. And if I click debug, it will take me into this break mode, as they call it, and it highlights the line that they believe the error is in. Now they're not always going to give you the correct line. They're not always as easy to solve, but hopefully most of the time they'll take you directly to the statement that has the error in, and we can look at working with it. And I know here that it was sheet 2 instead of sheet 4, and I could play that again. Now as I click away, I can see that despite changing it, I'm still in this break mode. If I played this in this example, it will probably be okay, but you might notice yourself getting can't execute code in break mode, if I remember the error correctly. So you cannot run code as a general rule whilst in break mode. So you typically go to this blue square and toolbar, this reset button, to come out of break mode and back into your code, so that if I went to run it now, it would run fine. So this video was just a quick look at 2 errors that you're gonna see as you start writing code, and I didn't want it to put you off if you started to move into the concepts of variables and loops and decision making constructs. So I wanted to get them out of the way. So later on in the course, once we've got more familiar with how to write statements and different types of error that we see, we'll look at better ways of handling them. Or maybe better is the wrong word, but other ways of handling them. But for now, 2 errors. The syntax one especially, I'm sure we'll start seeing. Hello and welcome to this video where we begin to look at using variables in our VBA code. Now when we use Excel in its typical spreadsheet environment, we are using cells to store our data, whether it be currency, date, text, percentage. Now when we write macros and using VBA to write procedure, we use variables to store our information. So unless we are looking at writing information to a cell to make it visible to the user, data should be stored in variables, as they ensure that your code runs much faster than storing data in cells, so you don't have to write to the cell and read the cell. A variable is not a physical container like a cell is. It's stored in memory, so it's much faster to access. It's not something that you can see. And there are also different data types, so it provides an area of validation for the data that it stores as well. What I'm going to use as an example here is we're going to look at filling in this invoice. Or we're not going to fill it in, it's already filled in. But we want to store information about this invoice on this invoice tracker sheet. We want this as a new entry at the bottom, similar to some of the stuff we've been doing so far, but the difference here is that I'm going to store the invoice date, invoice, client, and if I scroll down a bit, total, to a variable. Each will have its own variable before we then write it to the sheet. So I want to use an example of using 4 different types of data as well in a variable. So let's get stuck straight in. I'm going to switch to the Visual Basic editor and insert a new module and create a new procedure which I'll call using variables. And the first thing we should do is declare our variables. Now it's not mandatory to declare your variables, but it's extremely good practice. It is highly recommended. It makes your code much easier to read. It also makes it faster as it uses less memory. Let's maximize that. And it also, what's the other thing? It provides an area of validation, so we'll get type mismatch errors, as we're going to specify that one stores a number and one stores text, etc. Just like we can use validation and formatting on a worksheet normally. Now variables should always be declared as the first thing in a procedure. That is where people expect them to be found. And to declare them, we use the word dim, which stands for dimension, which is not really that important to know, but just in case you felt there was an insult, it is for dimension. Then we follow it with the name of the variable, and for this first one, it's going to be the date of the invoice, so I'm going to call it invoice date. You can't use spaces or start with numbers in variable names, the same rules as using procedure names or macro names. And then I'm going to put the word as to specify a data type for this variable. And probably no surprise that I'm going to specify this as a date. Now there are many different data types with variables. We're going to look at 4 different types here, and I've provided a sheet for download or just for viewing in this lesson, so you can have a look at that, and it lists, I think, about 15 of the main types of variable which we're going to see throughout this course. We're going to use Boolean variables and long and object and these different types. But just like there are many types of formatting on the sheet, there are many types of variable. Okay, now the second variable, so I'll use dim to declare, is going to be for the ID. So I'm going to have invoice ID, and that I'm going to store as the data type of long, which can only handle integers, negative and positive integers of quite a large value. That sheet will also mention data types of byte and integer, which are also used to store numbers but of less values. And I don't know how many IDs over time we will use, so I'm using a large number to be sure that I don't get an overload error and that it's capable of handling whatever number goes in there. Byte, for example, handles as much as 0 to 255, which is only good for small numbers like people's ages, number of spreadsheets within a book, and integer, which goes as far as, I think it's 32,766, I believe. So once again, quite a small number, I mean, much bigger than byte, but considering there's over 1 million rows in a spreadsheet, it's set, 32,000 is not that big a number. Okay, next up, we're going to have the name of the client, and that is going to be storing text. So the data type is string. We use data type called string to store text. And finally, we're going to have one to store the invoice total. So I'll call it invoice total, and that is going to be the data type of currency. So I'm taking this opportunity to store 4 different types of data. Now once again, I could declare a variable without the data type. It's not necessary. It's quite happy for me to do that. And although the name kind of gives this one away with dates, though it is recommended both to make your code readable, if it will know what's going on, but also to make it faster. If you do not specify a data type, it uses the data type called variant. Variant is like a chameleon data type. It can handle any type of data in any given situation, so it's extremely useful at times, but I believe it's 16 bytes of data at a minimum, whereas things like long handle 4 bytes. This is all on that sheet. It's something you can reference in VBA help or on that sheet I've provided. But it's a good, what is that, 8, just 4 times, at least 4 times larger, more space it's taking in memory. Okay, so they are our declarations for variables declared. Next up, we're going to initialize the variables. We're going to assign a value to them, and we want to assign the value from that invoice sheet. So if I just pop back to the invoice sheet for a moment, we can see that the date is in cell D3, number on D4, client D5, and total D27 on a sheet called invoice. Now, probably won't bother putting a button in because we've done that on this course, but I'm imagining that I would put a button around here or something on this invoice, so I know somebody's on the sheet when they run this, so I don't need to reference the invoice sheet in the procedure. I'm going to pop back to our editor, and I'm going to put invoice date equals range D3, if I remember rightly, dot value. So I'm assigning the value from D3 to a variable called invoice date. And then I'm going to do the same for the others. So I have invoice ID equals range D4 dot value. Tell you what, let me take a copy of that. in for the next one, client equals, and I'll paste that in, the value of D5, and finally the invoice total equals the value of D27. So I've assigned the 4 values to a variable. Now you might be thinking you could have just written them straight onto the other sheet. You don't need the variable. And you're right, I don't. So this maybe isn't an award-winning example of the use of variables, but it's just to get us into the concept and get us into the practice of doing them. Trust me, there will be some far more awesome examples of the use of variables before the end of this course. And if you're not appreciating their use as yet, you certainly will. They're a fundamental concept of VBA programming. Okay, next step is to get to the position where we want to input these values, which is at the bottom of the invoice tracker sheet. So I'm going to put worksheets, and I'm going to reference the invoice, or I'm going to activate the invoice tracker sheet. .activate, shooting through this. This is stuff we've done on previous lessons. Selecting a sheet, and I'm going to select the next empty cell at the bottom of this list. So I'm going to say range A2 dot end Excel down dot offset 1,0 1 row below dot select. So once again, something we've done on a previous course. One line that's going to get us the next empty cell at the bottom of column A, as that is. And now we're going to write them values in. The first one that needs writing is the ID. If I just quickly refresh our memory, this is the invoice tracker sheet. So ID, date, client, amount. Let's pop back to that. Back to our editor. Active cell. Active cell. Dot value equals, and I can put invoice ID. So the value that's in that variable can now be assigned to a cell. I'm then going to put active cell dot offset 0,1 to move 1 column to the right. Value equals. Now I want to put invoice date. I'm going to take this opportunity to mention something else. If I hold down Control and press space, that will force this list to appear. So it may help with inputting things like variables. So as I'm typing invoice, I can see my variables now appear in that normal list of properties and methods that we've been seeing so far, and we'll see a lot more of. So it's another way that might speed up the input of your variables. So that was Control and your spacebar to initiate that list. Okay, let me take a copy of this active cell dot offset, and I'll put equals client, and I'll paste it in again to say equals invoice total. And then I'll need to change them offsets to the second column along and the third column along. So now we've written the 3 variables into the active cell. Now I'm going to put one more thing in. I think I'm going to have a message box that will display the invoice ID to the user. So I'm going to say invoice ID. Let's put a space in there. Now I'm going to concatenate the ID in, which is invoice ID. I referenced a variable that has got the ID stored. So you can see it's much easier to reference the ID rather than having to say sheets, invoice, range, D4.value, which is where it is. It's much shorter code, far easier to reference. Remember, I'm on the invoice tracker sheet at the moment, so I have to reference back to invoice to get to it. Okay, I'm going to then concatenate on another piece of text, to say has been added to the tracker. So a quick little message box, say invoice ID blah has been added to the tracker. Now, one last thing I want to add to this before we play this through is this locals window that I have at the bottom of my screen at the moment. Now, if I close that down, we can bring the locals window in from the view menu. And we'll see some of these other windows by the end of the course. But this is a logical point to talk about locals, as it is used to track your variables. So I choose the locals window, it appears at the bottom of the screen, although you can move it. I love the locals window. I use it an awful lot. I say it tracks your variables as you go through your code. So the plan is to restore this window so we can see what's going on behind it. So we can both see the spreadsheet behind, and I can also see the locals window. And I'm going to use the F8 key to step through the procedure. So as soon as it starts, I can see the declaration. Type on the far right, current value in here. So the speech marks for the string there, and the name. And as we step through it, I can immediately see the initial assignment there. So it goes past the invoice date. So you can also see by hovering over the variable name in the code, you can see at the bottom that it has the correct date. We can spot an issue if there was one at that point. Continuing to press F8, I can see each bit of information getting stored in the locals window, allow me to track it to identify problems or understand somebody's procedure. Now this one, we'll see it move to the tracker in the background. I'm in row 5 somewhere by the looks of it, but as soon as I move past that, I'm in that empty cell. And then it's just going to write each variable details. Let's move this out of the way for the next one, into the appropriate cell. Bit of a mix up on formatting there. I've got accounting and currency going on. Something to deal with. Finished with a message box. Invoice ID 114, so using the variable, has been added to the tracker. So that is an introduction look at variables. The importance of declaring your variables should happen at the top of a procedure, normally followed by the initializing of the variables, although it can happen at some other point in the procedure, and then looking at writing them to cells and also a message box. The variables can accept data from message boxes, cells, functions, input boxes, user forms, anything we use in VBA, and we will be using it as a way of storing data during a macro so that we can then refer to it and use it. Hello and welcome to this video on the role of option explicit in VBA. Now by default you do not have to declare variables in VBA. So we mentioned in a previous video how important it is and the benefits of them. We're now going to look into this a little bit more, and the fact that by default you do not need to. However, if I was to demonstrate an example here, and within this code I'm going to remove the C from our invoice total here, therefore trying to imitate a typing mistake, and I'm going to use my F8 key to step through the macro. And notice in my locals window, which I still have open at the bottom, that it has created a variable called invoice total. So because our code has come across, our compiler has come across a word which it doesn't recognize as an existing variable or a reserved word in VBA, so it's therefore created a variable by that name, assuming that's what it must be. Now this may seem like good behaviour, I don't know, but this is not good. It makes it very difficult to try and track why your code is not working. And if I just double check that I'm on my invoice sheet, I am. And if I carry on stepping through this code, we will see that it assigns the total to the wrong variable now. So I don't get an error message, it just continues to work, but doesn't work correctly. What we sometimes call a logical error. So this can be much more difficult for you to track down and figure out why your code is not working. Especially when we start looking at loops and if statements and these more complex stuff. So it is definitely common practice to declare your variables. And that is what a line called option explicit will force you to do. So if I click my reset button on the toolbar to come out of break mode here and stop that, and I'll put my C back into invoice total. And above and before any other lines of code in the module, I will type the words option explicit to force you to explicitly declare your variables. So now, I should have left that out. If I just take that C back out of invoice total, and if I F8 through my code, it immediately gives me this error message saying I have a variable not defined, a compile error, and it has highlighted the word in question. So much easier for me to debug that issue now, as that word must have been typed incorrectly. Now with the words option explicit there, seeing the error message of variable not defined is not unusual, and it's so common that you've just made a typo, so you've missed the N out of range and you've put rage, or you missed a D out of end, and normally just stuff like this, and it will come up variable not defined. So it may not be a variable, just you have mistyped something, and it's far better than it warns you than it just has a guess at creating a variable in that instance and running with that. Okay, let's stop that debugging and put my C back in, and I've just typed option explicit above and before anything else in this module, and it's sectioned it off for me. Let's have a look at the tools menu and options from that menu, where we can see that there is a checkbox to require variable declaration. Now this checkbox would not work retrospectively, and it would not put option explicit in this module if it was not already there. What it does ensure though is that with that box checked, if I clicked on OK and went to insert future modules, option explicit would immediately be at the top. So for now and forever, I'll go back to module 1, option explicit will be there. And that is highly recommended that that checkbox becomes checked to ensure tools options, that checkbox there, that option explicit is always there, and you are forced to declare your variables. It is very much good practice. Okay, let's have a look before we come out of here at a couple of other examples of the importance of declaring variables. We spoke about the speed, the ease of reading, that I can see the variables already. I even know what data type they are, and we spoke about this in the previous video. Let's see a couple of more error examples. So what I'm going to do is this invoice ID variable we've got as a data type of long, which handles a huge number, an integer value, negative to positive. Remember on my previous lesson, I have an attachment there, I have a file for you to download or to view within the lesson, which lists the more popular data types. What I'm going to do is change that to byte. Byte being it handles a value between 0 and 255. It's a very small integer. Now the current value on the invoice is 114. So if I was to run that, that should be quite happy with that value. So as it goes through, I can see 114 assigned to that variable as it's the data type of byte. You can see on the end there. Now if I stop that, if I reset that, and on the invoice sheet, I'm going to change that to a number larger than 255. So that if I go back to the editor and I start stepping through my code, I receive sorry, a runtime error, number 6 at that point, an overflow error. And if I hit debug, it prompts me to the area. I can see the value has not gone in there. The value is too large for that data type, an overflow error. So without me specifying that as bytes, I would not have seen that, or even declaring it. So these are some of the important, some of the things that are really going to help you out with troubleshooting, reading what's going on and that kind of stuff. I'm going to reset that. It was just a demonstration of an overload runtime error there. I'll change that to long to handle larger values. And for another common error message related to variable declaration is if I go back to the ID and I'm going to type a letter T in front. So maybe an honest mistake. It's 321 here, so it should. Actually, it's two. That would be too much. How's my maths? 211, which should be less than 255. But a letter T in front, indicating that should be text. And I've just made an honest typing mistake. Actually, this is long now, so it should easily be in that anyhow. What am I talking about with them numbers? But if I start to F8 through this, bam, we've got another runtime error. This one caused by the letter T, which means that would be string, that is text. It's trying to assign it to a variable with a long data type, which can only handle whole numbers, negative and positive, type mismatch. So it cannot handle that type of data. And there it prompts me to it. Now, if I didn't have long on the end there, that would be quite happy to handle that, because as I F8 through, I can see my invoice ID has a data type of a variant. So it should be able to handle that value. In goes T211. And I can see the speech marks around it indicating it is stored as a string. It says there, variant currently as a string. So there's some good uses of the variant. And if we were going to use it, I would, type as variant rather than leave it blank, because that makes our code, let's reset that project, makes our code more readable. But, this is stuff that you may come across when you see other people's macros. So it's good to know this stuff, but there is certainly a best practice, and that is certainly to use option explicit, and more importantly than that, to declare your variables with a data type.
Hello and welcome to this video on variable scope, where we start to look at the accessibility of your variables across different procedures. So we've got the sub-procedure created that we've been using in the last two videos, the last two lessons, where we have sub-using variables. And at the moment, the variables that we have declared using the dim keyword at the top of our procedure are only available within this procedure. So only available to statements within this procedure. What we're going to look at doing is I'm going to create a new procedure within this code module, module 1, below this using variables 1. So I'm going to put dim add to invoice tracker. So I've created a new sub procedure called add to invoice tracker, and I'm going to cut and paste the statements that perform the add-in to the invoice tracker. So I'll put the word dim there instead of sub. That have been adding it to the invoice tracker sheet. So I've left the code in using variables that declare the variables and then assign the initial values to them. I've left them there, and I've added the ones that add them to the invoice tracker to this other procedure. Now in the using variables procedure, I will add the line call add to invoice tracker. So that line will run the other procedure, the other macro, or call it from the using variables procedure. So it will declare the variables, assign the values, run the other procedure, which will then add them to the invoice tracker sheet. Now this is good practice to break down a large macro into more manageable chunks. And this isn't a large macro, but the example, the kind of concept is not a bad idea. It's very popular. It's a very good idea to have these more manageable macros. Now I've got my locals window open at the bottom, and I'm just going to double check what sheet I'm in. I'm in the wrong sheet. I need to be in the invoice sheet where I have this new invoice. And from the editor, I'm going to use my F8 key to step through. So I'm going to click within the using variables procedure and use F8 to step through. I can immediately see the locals window declare those variables. And as I step through, I can see it assign the values to them. And then it jumps to the add to invoice tracker procedure, and I get this message for variable not defined. And if I drag that to the side, I can see it's complaining about invoice ID. I can see at the bottom in the locals window that I do not have any variables. So they have been reset, they have not carried across, and that is the problem. So I'm going to OK that and reset the procedure out of break mode. And to solve this, I'm going to cut and paste them 4 statements that declare variables below option explicit at the top of this module. So by doing that, notice the editor puts this line below the variables to section them off. I've made those variables available to all procedures within this module. So they're available module wide and not procedure wide as they were previously. So now, if I click within the using variables procedure and try stepping through the code, looking down below, if I click this plus sign next to module 1, I can see they're now available module wide. They have module scope. I can see them variables have been declared. As I move through, they are assigned the values, and then it calls the other procedure. And if I expand that module 1 again, I can see they are still available. I can see the assignments are in there. And if I restore this window so I can see behind it, we can see as I F8 through, scroll that down, then it moves to the other sheet and then assigns the values to the extra line and displays the message box. So we have made them variables available to all procedures within this one module at the moment, this code module, module 1, by putting them at the top of the module. Okay, let's reset that module, and what I'm going to do is insert another module to this project. So insert a new module, a module 2, and I'm going to cut and paste the add to invoice tracker procedure to this new module. So now they are in different code modules. Now for this to continue to work, in module 1 I will change the dim keyword to the word public, and by making these variables public, they will be available to all to procedures in all macros of this project. which we'll see a demonstration of. It's quite good practice in very large kind of macros to make a module that just holds your procedures, and and call it variables or something, so you know where they are and they kind of have their own module. I've seen that before. It's not a bad idea. But now with these as public, I've got using variables within that module, the others in the other one. Let's look at running this again. I have to make sure I'm using variables. Start F8ing through. When I expand module 1 now, I can see that they are there and they are assigned the values. Oh, hold on, I'm on the wrong sheet. Let's stop that for a moment. I need to reset my workbook. I can see them values were not correct. Let's go back to invoice. In fact, let's modify the invoice as well. Denim Motors, be 116. Let's change some of this around. Here we go, we've got a new invoice. Let's go back to our code. Okay, let's give that another try. Let's F8 through. If I expand module 1, we can see them in there. This time it should get the right information. There's the date, 116, Denim Motors, and whatever that was, 670. And it's going to call the other procedure. Module 2, let's have a look. No variables. So I expand module 2, it doesn't show any variables. But if I hover over the variable names within the procedure, I can see that they do have those values assigned to them. So as I move through this, and if I restored that to C behind, I can see the values being assigned to the lines and invoice 116 mentioned at the end. So we don't see them in the locals window because it is local. Module 2 doesn't show any variables, but they are available. The public statement ensuring that the variable, like their values are maintained, and we can see that as we kind of hover over the variable names, which is very useful when troubleshooting code and using variables in this manner. So that is variable scope. We can have variables available to a procedure, to a module, or to a project. To make them available to a procedure, we enter them at the top of the procedure. Available to a module, we enter them at the top of the module. Available to a project, at the top of the module, but with the keyword of public. Hello and welcome to this lesson where we have a look at object variables. Now these are a special type of variable, these object variables, because as their name implies, they can act as an object. So we can declare variables using data types such as a worksheet, as a workbook, as a chart, as a range. We can then assign sheets or ranges to these variables and have them act as an instance of a range or a book. They will assume all the properties and methods of one, so it can provide us with an easy way of referencing a particular sheet or range, even if we don't know, the address of the range or the name of the sheet ourselves. So as an example of this for now, I'm going to use this invoice tracker macro that we've been working on in this section of the course, and we're going to look at how we could improve it with a couple of object variables. Now we're going to see some amazing examples of these variables later on as the course, as we slowly progress after getting these concepts under a belt into some far more sexy ways of where they can be used. For now though, up where we can declare our variables, I'm going to declare another variable using the same technique that we've used so far, so the keyword of dim, and then I'm going to use the name SHT, and I'm going to specify the data type as a worksheet. So this is an object data type. Now when I press enter, the name worksheet does not go blue like the other data types do. If I'd written the word object, it would have. But I'm being far more specific as I know the type of object I want to use here. I'm going to declare another variable which I'm going to call new entry. And that data type will be as a range. So I've got one object variable that's going to act like a worksheet and another one that's going to act like a range. And what I'd like to do here is, instead of having to reference the invoice tracker worksheet by putting a statement like this and activating it to get onto the sheet, I would initially assign it to the variable sht, so then whenever I want to reference that sheet, I can simply use the word sht. Now the new entry range will act as this. So instead of mentioning to go to the bottom of the invoice tracker sheet, I will assign that once to the new entry variable. So then whenever I need to refer to it, I can refer to it as new entry, a meaningful name. What this would also mean for us now is that we don't have to activate and select stuff on the invoice tracker sheet. When somebody clicks the button, when somebody clicks the button from our invoice, it will not need to go to invoice tracker to do it. It can stay on this sheet and just reference the areas by using our object variables. Now another twist in the towel to try and strengthen the argument for what object variables can do for you is, on the invoice tracker sheet, it has been protected. So I can see on the review tab, unprotect sheet is lit up because that sheet is protected. Now we will not be able to write to it until I have unprotected that sheet, because these cells here are protected, and row 7 will be what I'm going to have to use. So let's go back to invoice and back to our code, and we'll do the assignment. So I've declared two variables in the same way as before. Now we want to assign something to them. And this is where things get a tiny bit different, because we need to use the keyword set. Whenever we assign to an object variable, we have to use the keyword set. Now this is something different to what we do, as we can see with the variables above. We do not use such a word, we can just assign straight to them. Once the word set is in, it is, as we know, sht equals, and I'm going to put worksheets invoice tracker. I could just copy the line from below and it's in. And I can now remove that because I will not have a need to activate that sheet when this is working. Now let me grab a copy of that while I have that in my mind. And in the line below I will write set new entry equals, and I'll paste that line in and remove it from where it is below. So sht is the invoice tracker sheet, but an easy name to reference now. New entry is the cell, well, it's the new entry cell. It is the first vacant cell, the bottom of column A on the invoice tracker sheet. Just realising something I've missed out there. It's going to be our sht to the left of that range. We're not on that sheet before. I need the sht there. And our first example, I guess, it's very important that we assign that before I do this, of the use of these object variables. I would have to write worksheets invoice tracker before that otherwise. Okay, that sheet is protected. We need to unprotect it before I can do this writing to the cells. So it's going to be sht.unprotect. So sht is that sheet. I can unprotect it, and below them lines I'm going to protect it again. So it's going to unprotect them write the lines in, and then protect the sheet again. Now, last thing I believe on here are these active cell lines. I'm not in that cell. Well, I'm probably not in that cell in reality when this happens. So I'm going to change that to new entry. I'm not selecting it anymore. I'm using these object variables. Let's take a copy of new entry and paste that into the other lines. And I believe we are rocking and rolling. Got my message box. Now this is our code with our object variables. Let's restore this window and check out what we've got. So I'm on the invoice sheet at the moment. As I press F8, variables are declared. And I can see SHT and new entry at the bottom with a value of nothing and acting as a worksheet and a range. Now as you move through and start assigning to these, I can see the assignments are made and I have a plus sign next to them. This shows, if I use SHT as an example, all the different information that variable now has that I could access about it, because it is functioning as a sheet object. Really useful. Protection. Okay, let's move through. Unprotected that sheet. And then we start writing to the cells. Now I can't see this behind because there's no need to activate that sheet anymore. I'm still on invoice. But if I pop back there now, I can see the first two bits of information are in and the sheet is unprotected. Let's move back to our code. Continue through. In it goes. In it goes. Protected. Let's click on that sheet. It has been protected again. Into the message box and it's over. Let's reset that. So that is, performing the same job as what we've been doing, but it's showcasing use of object variables, which we'll see some very strong examples of, especially with regards to looping and when we start getting into our more large scale projects. For now, it's an example of how to use them, how to write them. Remembering to use the keyword set when initializing to these objects. Hello and welcome to this lesson where we start looking at our first decision making construct, which is our if then else statement. Now, using if functions before in Excel, you'll be more than accomplished with these if then else statements. They are extremely similar to an if function. It's that same logical test. It will just be written a little bit differently in a VBA environment. And for this kind of introduction to it, we have a list of grades with an average of them grades, and initially we are looking at creating the macro that when run will display great if it is above 70 and poor if it is below 70. So let's go straight into our VBA environment and kick up a new module, and I'm going to write a new sub-procedure called exam performance. Okay, and then we're going to have an if then else statement that's going to write to cell, is it C9? C9, we're going to test cell B9 and write into C9 what the answer will be. Okay, so let's get going with this. So no surprise, this statement begins with the word if. Immediately following if will be the condition. So similar to an if function, in fact the first argument is its logical test. Here is our condition. Now I'm going to reference cell B9 using the range object, and I'm going to test its value to ask if it is greater than or equals to 70. If the value in range B9 is greater than or equals to 70. Then I'm going to put the word then on the end. Very popular. People, when they initially get started with this construct, to forget to put the word then on the end. And you will get an error to warn you, so it's fairly easy to diagnose. A real common thing I notice in my courses. Okay, now below that, I'm going to immediately put in my end if line. Now it's good practice. This puts in good stead when we go into loops and stuff as well, to put that kind of end of the construct in immediately. Once again, very easy to forget if you start putting in your tests and then at the end you forget your end if and you get an error message to warn you. So I'm going to put it in immediately and then jump in between and tab in. Not essential that we tab in, but it's universally recognised as the way you should write these constructs. Makes it easy for people to see the beginning and end of things like if statements and select case statements and loops and this kind of stuff. So now what we need to do is, what do you want to do if that value is greater than or equals to 70? Okay, the plan was that in cell C9 we will write to it, so dot value equals, I'm just going to put a string in there, a piece of text, of speech marks, and I was going to say great. Range C9 dot value is great. Else. So this is known as the if then else statement. You do not have to put an else statement. Let's say that I wanted to display the word great, and that was it. If it's not 70 or more, then don't do anything. Let's have a look at that. Let's say I leave that out, and I will run this macro, hit my play button, and then if I restore that for a moment to see behind, I can see the word great is there. Let's say that they have to be greater than or equals to 80, and run that code. Oop, let's delete that word first. Let's delete great from there. Run that code. However, I didn't press F8 and I ran it. Here we go. And nothing now happens because I do not have an else case. Okay, I'm going to leave that as 80 so we can see the else case now. Let me maximise that window for a moment. And we're going to put else, and I'll leave that on its own line and tab in on the second line. I'm going to copy that line of code and just change the word great to the word poor. So now we do have an else kind of action, and if I restore the window, run that again, now it says it's poor. Let's delete that and go back to our editor. So that's a good kind of introduction to an if then else statement. As I said, using if functions before, it's not massively different. It's just known to put the words then and the words else in. Now, good practice to tab in these lines. Whoops. So this kind of stuff would take some getting used to maybe, but I'm sure the kind of core idea is already there for you. Okay, what we're going to look at doing is adding on to that now though, and we're going to start adding in further tests. So what I'm going to say is if it's greater than 80, then great. If it's kind of greater than 60 but less than 80, then I know it's average, and otherwise it's kind of poor. So what I'm going to do here is I'm going to change this else statement to an else if. Now that is written all as one word and is followed by a condition, just like the initial if line there. Now I'm going to copy a line above. Let me move through that message. Let's copy that. And I'm going to ask if it's between 60 and 80. So I'm going to paste that in. I'm going to say if it's greater than or equals to 60,
Now I want to ask if it's less than 80. That's what I want to do here. If it's greater or equals 60 but less than 80. So I'm going to write in the word AND. So once again, doing if functions for an Excel, and if you've taken our superhero course, you would know about AND and OR logical functions from Excel. They're actually easier in VBA. They mean exactly the same. I'm using AND to ensure that both conditions are met, but it's easier in the way that I just write the word AND. It's just like that. And I'll follow it with the second condition, which is going to be if range B9 is less than 79. Following with the word then. Then maximise that window. This is getting a bit much, and scroll that back across. Else if range B9 blah 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 greater than or equals 60 less than 79, then do something else, which is going to be that will say average. It's probably the wrong word to use, as we've got an average function calculating the average. But you know what I mean. Let's change it to standard. I'm not happy with that. Standard. Trying to think of some kind of medium statement to say. Then after that, let's take a copy. What's the essential skill of copy and paste these in VBA? Else. And then we're going to have that as poor. So now I've got the extra condition. I have a nested if you will. Technically it's not quite a nested if, but I have that extra test it's making. If it's greater or equals 80, else if this, else. So, what was it? It's 74. So this should get standard. In it goes. Just see standard happening in the background. So that is adding to our if then else statement there. Now there's nothing stopping you adding in further else ifs. The if statement tends to get quite large and quite congested if you had too many conditions in there. And we're going to look at the select case statement in our next lesson, which is generally recognised as a better alternative when you are making decisions based on multiple tests. But here we've got an if that's capable of performing 2 tests. Hello and welcome to this lesson where we look at the select case statement. So this is our second decision making construct. It's called select case, and it's an alternative to the if statement when testing multiple conditions. It's commonly thought of to be much easier to read than the if statement when testing multiple conditions. So let's have a look at such an example. I've got the same spreadsheet that we used in the video for the if statement, but this time I want to display maybe 5 different kind of text options depending on that average value. I want to display it in C9. So the select case would hopefully display that a bit better than an if statement would, although that can also achieve this. I'm going to go straight into the editor. So B9 is what I'm testing, C9 is what I'm writing to. Quick refresher there, and let's get a module in with a sub-procedure, which I'm going to call select case example. And I'm going to get straight in and write select case. No messing around. So you will notice that a lot of these constructs that we look at throughout this course in VBA are named after the keywords they use. So it's called the select case statement, and it starts off with the word select case. Immediately following that, similar to the if statement, we put the case. So rather than the whole test, we put what it is that we're testing, which in this case is range B9.value. So that is the case. The case is range B9, the value in it. Now I'm going to put end selecting, much the same reason I mentioned on the previous video, just so you don't forget at the end. Now it's good to put the kind of framework in, if you will.
so you're not going to miss anything out. Then you can tab inside the middle and start getting stuck into the testing and what you want to do. Especially as these constructs get large, very easy to forget this stuff. So it's a habit I have and a practice that I tend to follow. Okay, we're going to say case is 91 to 100, and then I'm going to put a colon. Now you might see quite commonly that people will go to a new line and tab in a little bit. Personally, I like to write them all on one line because one of the reasons I'm using select case is to make it easier to read and take up less room in my module. By putting on a new line, it's still looking quite large. So that's probably what you're more likely going to come across. Personally for me, I put a colon and then I'm going to put what we're going to do if that's the case. So range C9 is going to display the word distinction. That's what's going to happen. If the case is between 91 and 100, range C9 will display distinction. And I'm going to take a copy of that line. I'm going to paste it in. So 5 more times. Whoops. And I'm just going to change the values. So this one will be 81 to 90. This one will be 71 to 80. This one will be 61 to 70. This one, my plan is to put else, case else. That is going to be poor. This one here I'm going to make very good. This one here is just good. This one here is that's alright. And here we go. So we've got 5 different phrases depending on the size of the score. So let's see if you agree or not that that is easier to read than what an if statement would look if it was also to do 5 different options. So it would have kind of 1 if and 3 else ifs in there to get that with an else on the end. So quite short and to the point. Let's restore this window and check out what we do. 74, so it should be the value of good. Let's play that and we get good. If I was to mix up the values a little bit, so I've got 80 now. Okay, that's still going to be good. Let's up that a little bit more. Huge score, 81. Is that all it does on the average? So we're looking at very good now, and we get very good when it's played. So this is a select case statement. It will come up in one of our projects later on. Everything we'll do will be repeated in a much more full-on example, but that is the structure of how it is written. A better alternative for multiple testing.
Hello and welcome to this lesson on using conditional loops in VBA. So the first type of loop we're going to cover in this section are conditional loops. And there are 2 types of conditional loop, the do while and the do until, which are known as do loops. And these conditional loops, a condition determines the exit point of that loop. Some of the other loops we cover in this course will run a predetermined number of times, or a number of times that Excel will know. In this scenario, we're going to create our own condition for the loop. So it's very important that we check and double check the condition of the loop before we run it. Otherwise you can find yourself in an infinite loop, a loop that cannot exit, and will just continue until you can break that loop, which can sometimes be done by pressing Control and Enter, or by pressing escape, but it's quite often the point that that you find you can't exit it. So very important to kind of save work as you go, so you have a backup. But even more important, double check your condition before you run a loop. So an example of our do loop here, I'm going to enter 10 numbers from A5. I won't do 10, I'll do 5. 5 numbers from A5 down to A9 there. And what I'm going to do is set up a loop to run through all the numbers in this list, of which there are only 5, and add 1 on top. Now I'm not going to ask it to run 5 times, I'm asking it to perform the loop on every number in the list, so until it runs out of numbers. So there will be a condition to determine the exit point. So let's switch to the editor, and I'm going to insert a new module and a new sub-procedure, which I'll call do loops. And the first one we're going to look at is the do until loop. So just like when we looked at the if then else and the select case statements, you know, these structures are commonly named after their keywords. So this is known as a do until loop, and it is written with the words do until followed by the condition that's going to determine the exit of this loop, which in this scenario is that the value of the active cell is empty, it equals nothing, and then followed with the word loop. And in between them two lines will be the statements to repeat until that condition exits this loop. So we've got a nice repetitive action. And our statements are going to be that the active cell dot value should equal the active cell dot value plus 1. So add 1 on top of the current value in the active cell. And then we're going to move one cell below. So I'm going to offset one cell below. So let's click in cell A5 to make that the active cell and step through our code using F8. So it will come in here and it will do the initial test. Say, right, is the active cell empty? No, it's not. And I have to do it until the cell is empty. Therefore, it will move into the set of statements, add 1 on top, move one cell down, and loop back round. Perform the test, move inside, add 1 on top, move one cell down, and loop back round. And it will do this until it runs out of cells. So here it goes. Is it empty? Yes, it is. Exits and continues with any other statements you may have in that procedure. So as you can imagine, loops are huge in VBA code. We will be using them an awful lot. It's one of the primary reasons you will be using macros in the first place, that you have this repetitive procedure. So that is our do until loop. I'm going to change that word until to while. So the other type of do loop is a do while loop. And I can quite easily create the same action here by changing my loop to do while and then saying do while would have said it's not empty. So if I click in cell A5, I could step through this and realise that this achieves the same objective. Now there is a difference between the logic, so it's not always going to be the case that, you know, you can pick and choose what one you want out of the two. It may be important that you choose the right one. But quite often, you know, you pick your favourite almost, the one that makes more logical sense to you, to do until it's empty or to do while it's not empty. It's worth mentioning that on both these types of loop, you can also position the test element of it after the loop statement as opposed to after do. Now I would say that you're more likely going to come across it, it's very common to see after the word do as opposed to its position now, but it's okay to do this. And what this would ensure is that the statements are actioned at least once before it performs the test. So the way we had it beforehand, it might perform the test and then not even enter the loop, just carry on. It's not relevant. Whereas now, it will perform the actions at least once before looping. So I'm going to move my statement back to the top, and I thought we'd just have one more look at a loop. So I might leave it as a do while, as that's what I have. I'm going to click on cell A5 to put my active cell at the top before I forget that when I test this. And this time I'm going to change the condition to ask it to do it while the active cell .value is less than or equal to 5. So now I'm expecting it to not do it after row 7. So it will do it to row 7, because I asked it was equal to 5, but not after it. So if we come in, is 3 less than or equal to 5? Yes it is. Add 1 on top, move down. Is that? Add 1 on top, move down. Is that? Yes it is equal to 5. So add 1 on top and move down, and then exit. So we're going to see a very strong case for these do loops. We'll be seeing them a lot throughout the rest of this course. For now, it's just a quick example of what these loops can do. And yeah, this is your conditional loop. That condition determines the exit point of that loop, just to make sure we're happy with the structure before we go any further. As mentioned, just to throw it into this lesson again, please check and double check that condition, because if that condition is not accurate, you may find yourself in an infinite loop, and that is worth telling twice. I've done it more than once. It's easy to do, which is why I'm emphasising that point. Something that don't have to worry as much about in some of the other loops you're about to look at. Hello and welcome to this lesson on using the cells object in our conditional loops. So what I've got on screen is I have the procedure from the previous lesson, where we have a do loop that is looping through a certain number of cells and is just incrementing 1 to the current value in that cell. And on the previous lesson, we used the active cell reference to a cell, and we used the offset property to move to 1 cell below. We've got dot select to actually move to that cell. Now, a more effective way, rather than selecting each cell, is to use the cells object and just to increment, to kind of reference each cell rather than to move to them. So what we can look at doing instead is to create a variable to store the row number, and then to increment that row number each time, so that we can reference each one without actually moving to it. So if we were doing this to say 60,000, 600,000 rows, this would be an incredible difference in kind of the speed that this macro is going to run. Whereas the way we have it at the moment, for 5, 10 cells, you're not going to notice any difference. But if this spreadsheet was to get larger, you will certainly notice the speed of this macro dramatically decrease as we're asking it to select every single cell in turn. So, first thing we're going to do here is, within the procedure, I'm going to declare a variable that's job is going to be to store the row number. So I'm going to call it row num, and I'm going to use it as the data type of long, which can handle large integer numbers. And then I'm going to assign the row number to that variable. So I'm going to say row num equals active cell dot row. So row there is a property of the active cell, so that when I start with this macro, and if I have cell A5 selected, for example, it will be assigned number 5. So if I demonstrate that now briefly, if I press my F8 key, I can see at the bottom the row number variable that get declared, and as I move past that initial initialization statement, I can see it take the number 5. So let's just reset that. That's working fine. And now in the loop, instead of referencing the active cell, which would still work at this point, I'm going to reference cells, opening bracket, so it'll prompt us for the row's index number, which I'm going to say is a row num, the variable that we are using to store the row number, comma, the column index, which is actually optional. The square bracket is saying it's optional, so I could omit that at this point because I'm dealing with this one column. But I'm going to type 1 in there because I believe that makes our coding more descriptive if we answer a lot of these questions rather than leave them empty. And I'm going to put a closing bracket. So at the moment that's row 5, column 1. But, you know, that will change itself as this macro moves through. So do until, you know, the cell we're referencing is empty. Now instead of active cell here, I need to change that to that again. So let's take a copy of what I've got there, that cells object, so that I reference the right place. Row num, comma 1, and I'll paste it over active cell here as well. And then I'll, instead of this line here with offset, I'm going to put row num equals row num plus 1. So what we've got now, I can make sure I'm in cell A5 in the background there. As I press F8, and it starts from row 5, say do until the cell's object is empty. Well, at the moment it's not empty. It will move in, add 1 on top, I can see in the background, and add 1 to the variable. So I can see at the bottom, next time round it will reference row 6. So as it loops round, it references row 6. Notice in the background it's not gone to row 6, but we are referring to it because it's a 6th row first column now. In it goes, adds 1 on top, I can see that in the background, and around it goes again, constantly adding 1 on top, but it's not actually moving to those cells. We're just incrementing our variable and referencing it using the cells object that I don't know if you remember, but I mentioned earlier on in the video about different techniques for referencing cells, sheets and books, that the cells object was going to be a big deal later in the course, but it didn't really make too much sense earlier maybe. And this is what I was waiting for. It is the most efficient way of referencing a cell when going through a loop. Not just a do loop, a conditional loop like this, but also some of the loops we'll see shortly, some of our counter loops, our for next loops. You know, the ability to use cells and store a variable in there, which we could be doing for the column index as well, is a far more effective approach than active cell and offset. That's not to say that active cell and offset are wrong. They're typically known to be easier to write, so unless your code warrants it, maybe you want to stick with them. It'll probably be easier for people to read and for yourself to use. But if we're dealing with large scale stuff, cells is your winner. Hello and welcome to this lesson where we have a closer look at the do loops and our conditional loops with a practical example of adding or updating to an inventory sheet. So on screen at the moment I have a small inventory sheet, choose an example with an ID, name, current stock level and a date last updated for a list of stock. And on another sheet called update, I just have a stock item, oranges 1005, which is currently on the other stock, which I'm going to use as an example, among others, of updating this inventory sheet with. Now, in my editor, if I switch to the editor, I've just used comments as a quick kind of brainstorming exercise to list some of the things we're going to need to do in this example. So I've put that I want to store the item ID, name and value in variables. So if I just restore this window for a moment, and I might indeed look at restoring this one as well to try and get a little bit of space on two screens if I can. So I want to store these three cells in variables so that when I switch to this sheet I can easily reference them rather than have to say something along the lines of worksheets, update, range A2.value. I want an easy reference. Now we want to use a do loop to search for the item ID. So the first example is this one. But in reality we don't know that. So I want to be able to look down this column looking for the ID. If it finds the ID, I want to add the delivery into the current stock level and put today's date as the date it was last updated. If it cannot find it, what I want to do is add it in as a new entry down the bottom here. With today's date, the level and this new entry. A message will be displayed to the user to say that the inventory was added, and then the cells on this update sheet will be cleared because that item has been added. We don't need them there anymore. So that is what we're planning on doing in this practical do loop exercise. So without further ado, let's get going. And the first thing on our list is to use variables to store the item ID, name and value. So feel free to have a go at this in your own time. Stop the video now. Use this sheet that I've provided to download and have a go. Otherwise, continue watching and we're going to get this job done. So I'm going to declare three variables. One I'm going to call item ID, and is going to be storing a long data type. I'm going to have another one which I'm going to call product name, which is going to store data of a string data type, and another one which I'm going to call delivery, and is going to be as I'll say an integer. We do not have the warehouse to store more than 32,000 odd, so I'm going to play with the integer value on that one. So hopefully this is a good recap for a lot of the key topics from the course so far, like the use of variables here. Now we need to assign values to them next, and these are just normal variables, they're not object variables, so you don't need the word set. I can just say item ID equals range A2 dot value, and I'm going to take a copy of that line to possibly save me some time. And the second one will be product name, and the last one will be delivery, and the range will be B2 and the last one C2. So as easy as that, we have variables declared and data assigned to them. So I can remove this first job, this first task. First bit done. So I'm imagining that the button that we're going to be clicking to add this will be on this sheet. So my references to that data are very contextual. I didn't mention a sheet to name because the way I want to set this up is that I know somebody will be on that sheet when they run it, because that's where the button will be. So I can reference it straight through range, our classic absolute reference. But when I look for the ID, next up is to search for the ID, I will need to be on the other sheet. So I'm going to reference that, or I'm going to move to that sheet now with worksheets inventory dot select. Well, let's activate. So I'm on that sheet. Activated the worksheet's called inventory. Now I want to use a do loop to search, and the plan here is that we're going to use another variable. I'm going to use a variable with a Boolean data type, which has not been mentioned in our tasks here, because we've kind of got three options as we loop through. We're either going to find the item and add the delivery amount on top along with today's date. We're going to realise that we've got to the end and we've not found it and enter it as a new product. Or we haven't found it yet and we're not at the end, so we have to move down a cell to keep looking. So we've kind of got three options there. So we need more than just your standard test. I can't just say do until we get to the bottom, because I've got other things to take into account. So what I want to do is create a Boolean variable, which is one of our true-false variables, and use it as a key as a way of exiting this loop at any given point. So I'm going to declare this variable first of all at the top. I'm going to say dim keep searching equals true. Sorry, not equals true, as Boolean, jumping ahead of myself there, a Boolean data type. And then, as you might have guessed from that last bit, I'm going to say keep searching equals true. So I'm setting a default value to it. Declare a variable that can only handle true-false values and initialize it with the value of true. So that then I can set up a do until loop and say to do until keep searching equals false. Do until my keep searching equals false. It currently says true, so it will be moving through this loop. I will need to assign false to the statement as a way of exiting the loop. Next, I'm going to keep them comments kind of in play there, and I'm going to put the word loop. Good practice to put that in so we don't forget. And in between them two statements, I'm going to put the statements that are going to need to be repeated, the actions to repeat. And our first step is to be looking for the search ID. Now, as we look for it, let's pop to inventory at this point, because that's where we would be if this was happening. As we look for it, I want to start from cell A3 and search down each one. Now, as we saw in a previous video, you know, I could use active cell. I could say range A3.select and then say things at active cell and active cell dot offset 1,0. But instead I'm going to use the cells object. I mentioned in the previous video that cells is a far more effective way of looping through and referencing cells. And I'm going to use a row number to reference the row, which I'll just increment each time. So another variable, I'm afraid. This one's going to be dim row num. I do like to call my row numbers row num. As long. This might be a very large inventory sheet. And I'm going to initialize that one, as you do, with the value of 3. Because the first row number to be checking will be 3, the third row. Oops. Okay, now let's get inside this loop and let's start putting in our searching for the ID. Now, to test if it's the ID or not, we are going to tab this in for some good indentation for readability. Let's get rid of that locals window for a moment for a bit more room. And we're going to use an if statement. If cells row num comma 1, column 1, dot value equals, what did I call it? Item ID. Then, if there is a match between the value of the current cell and the item ID, then you've found that product. So what do you want to do? Let's put our ndif in for good practice in case we forget, and tab in between. Well, if we found it, we want to add the delivery amount on top of it, and we want to put today's date in. So I'm going to say that cells row num, comma, and the stock level is always column 3, dot value equals cells row num, comma 3, dot value plus delivery. So delivery is the variable. Can I get a little bit more from this? Is the variable that is storing this figure here, just to make sure we're happy. So I'm adding that delivery amount on top of the current amount. So if it was apples that was found, the third column, add it on top of that. Okay, and then put in today's date. So cells row num, comma 4. The last updated information's in the fourth column. Dot value equals, I don't know if you remember this from one of our earlier videos, date. A function called dates will put in the date from your computer, the current date. Okay, so that is what we're going to do. If there is a match, then add the delivery on top and put in today's date. The last thing we need to do if there is a match is exit the loop, because the job will be done. And we exit the loop by saying keep searching equals false. So our do loop is to do until it equals false. It was initially set with the value of true. So if we have found it, do your actions, change that to false. So as we loop back around, it then will not perform any more actions. So that is us searching for the ID and adding in the delivery and today's date. So now we're on to our next job, which is that if you haven't found it, enter it as a new product. So what I'm going to do is I'm going to put this in as a else if statement. If you've not found it, are there still more inventory items to look for? So I'm going to say else if cells row num, comma 1 dot value equals empty. Then, so else if is the cell empty? Because if it is, we must be at the bottom of the list. So if that's the case, what I'm going to do is I'm going to take a copy of these previous lines, because I will need them, but I'm going to need to add some more to them as well. I'm going to create a bit of room for that. Now first of all, with these, we need to keep search equals false, because we need to exit the loop after adding the product. It's no good it continuing to look even after putting in a new product. There's no more to do. We need to put in today's date, and we also need to put the delivery in. What we don't need to do is add it on top of any existing value. So we don't need these lines here. So we can get rid of those. They're not really doing any harm, because if the row is empty, then the value is 0 to start with, but they're not necessary. So I'll remove them, and what I will do is add in these lines I'm going to add in 1 and 2. We need to add in the information to the first and second columns because it's a brand new item. The first one will be item ID. The second one will be assigning the product name. So in go as a new product. Okay, and exit the loop. That is our new product entered. Now it's not been put as a task here, but if you haven't found it and you're not at the bottom, the plan is to keep looking. So in a else statement, I'm going to put that row num equals row num plus 1. So we're going to add another row number on top so that as it loops round, we'll be looking at the next inventory item. And that is our loop done. So the next jobs are to clear the cells on the other sheet and to display a message to the user. So let's clear the cells first. I'm going to switch back to the update sheet. Activate the update sheet. I'm going to select cell A2 because it's probably a good idea that we position the user in that cell as a kind of logical kind of ending point of our macro. And I'm going to clear the contents of range A2 to C2 dot clear contents. So let's switch back to the update sheet so we can remind ourselves what's going on there. Range A2 to C2 are where the item is going to be appearing, and we're going to clear their contents once we've added it in as a new item or whatever we had to do. So our last remaining job, if I can come back up to these comments, is to display a message to the user to say that the job has been done. So I'm going to put an MSG box to say that the inventory sheet has been updated. So that message is just to put the user at ease, because when they run this macro, they're not going to see this stuff happen. So it puts them at ease that, you know, the inventory sheet has been updated. They don't have to check their work or anything. And that is the last task of this coding done. So we should have a macro that is capable of achieving that objective. So the plan here in this practical was to give you something to have a go at, or if you just wanted to watch the video rather than attempt it yourself initially, to see a more practical example of it. That's trying to combine a lot of the topics we've covered so far. Some of the difficulty of training VBA sometimes is that initially when you start talking about the concept of variables and loops, it's hard to get going with a great example until you've got all these concepts out of the way. So we can really start looking at some more sexy examples now, and some real true sense business examples. So we really begin to start putting these together: variables, if statements, cell references, VBA functions like date and message box. They're all coming to the forefront now in a proper example. Right, let's come out of this editor. I'm going to maximize this window, and I'm going to insert a button, or a shape to be precise, on my sheet here that's going to update inventory. And I'll leave it as that for now. I won't bother formatting it. I'll tell you what I will do. I will make it bigger. I want to see the words. Right. bit of a rubbish looking button, but that'll do. And we're going to right click and assign our inventory update macro so that, fingers crossed, let's double check, oranges has a current value of 78. Back onto update. Let's hit our button. And we get a message saying the inventory sheet was updated and the cells are cleared. Let's click OK and check it out. 78 was it? 128 now. And today's date, which is the 19th of February 2014, has been added for oranges. Okay, well, let's check out another one. Let's go for 1008. That ID is not on the inventory sheet. Let's pick a fruit item that's not there. I'm going to go for mangoes. Let's spell mangoes. You got an E or no E? I'm going to say E. I'm not sure. Delivery. There's been 100 mangoes delivered. Who doesn't like a mango? So let's just prove that 1008 even is not there. Mangoes are not there. Let's click my button. Inventory sheet updated. Let's have a look. A new item for mangoes. So it was able to unsuccessfully find it, but then add it in as a new entry. Now, not a bad idea as you go through this initially, if you're giving this a go yourself, that like all the other codes we've been doing so far on this course, we step through it. So if I did put one in, I can't remember what 1004 is, it's lemons, then it's not a bad idea that we, let's have 10 of them, that we F8 to step through our code. Now it's good to give it a check first of all. I can have my locals window available to track what's going on here and see what's happening. Row number gets 3, selects that sheet, goes into the loop and starts checking. Realises that's not a match, but not at the bottom, so we add one on top. Row number at the bottom is row number 4. Back round we go. Are you a match? This time you are. So in you go. Add it on top. You can see it in the background. Happen to hear that just went to 34. 12th of February is about to say the 19th. Boom. False. I can see keep searching. Move to false down in my locals window. Oh, this is exciting. Back round we go. No more looping because it does equal false. Move to update. Move to A2. Clear the contents. Display a message box. F8 is awesome for figuring out why your macro's not working, or understanding others if you're going to be working with other people's macros. It really is useful for troubleshooting, and we'll look a bit more at troubleshooting later. I hope you find that useful. Please, I say, give it a go yourself. Maybe spend a bit of time looking if you can improve that. Think about adding more stuff to it. This is where our VBA skills really are going to take on kind of more levels. Hello and welcome to this lesson where we are going to start to look at counter loops. And more specifically, we're going to look at a loop called the for next loop. Now this for next loop is used when you have a predetermined number of times to loop, to repeat them set of actions. So we looked at the conditional loops in the last few lessons where, you know, the exit point of the loop is some kind of condition, so you don't know and you're constantly trying to calculate it. In this example, we do know, or we've kind of figured it out, or Excel knows. And for this example, oh, my apologies. For this example, we want to look at deleting the blank rows from this list. So I can't remember how many I've put in. I've put in about 7 or 8 blank rows as an example in this list that we want to remove. So what we're planning on doing is we're going to run a count on column A, account A, as a way of storing how many rows in this list are non-blank, how many have got something in them. We're going to store them in a variable, and then we're going to use a for next loop to loop through that number of times. Now, once I've done the count, I know how many times it needs to run, or the variable does, maybe I don't, and we can get our macro to run that predetermined number of times. So let's switch back to the editor, and I've just written a few comments like in the previous lesson as to what our plan is to kind of track what we're going to do. And the first thing to note here is to use variables to store the row number. So as we move through looking for blanks and removing them, I need to keep track of what row we're in at any given point. I'm planning to use an object called rows, as opposed to the likes of active cell and offset again. And I've got another variable for total rows, which is going to store that count A that I've just been talking about. As I say, we'll use a for next loop to loop through each record. We need to check if the row is blank. What I want to do is make sure the whole row is blank, not just a cell. I need to have a look at the row, so I'm going to use a count A again. I'm going to count the row. So if you come back with 0, if you didn't count anything, it must be blank. Now store the count in a variable, and then check if it's 0 and delete it if it is. My plan is to count how many I'm deleting. So a bit like your find and replace feature, or the remove duplicates feature of Excel. You may have used these before, but they always tell you at the end how many they've deleted. Or when you do a find and replace, it always come back and says, I have made 36 occurrences, or however it phrases it, I can't remember, but it tells you it's replaced some. We'll do a similar thing. I want to display a message to the user, telling them how many we've deleted. So that's the plan. Okay, first thing, variables. Let's put them at the top. 2 variables here, one for the row number, one for total rows. So dim. Now for row number, I thought I'd call it R, and I thought I'd store it as long. I believe there are 92 in this list, I think. In reality, I would not know this. Excel's got over 1 million rows to potentially be used. Better put it as long. Just a reminder, you can call these whatever you want. R, I've obviously just used the first letter of row there, just to indicate for me. Very common for people to call them, row num, counter, or I, short for integer and stuff like that. Okay, next one, I'm going to call total rows. Oop. Certainly need some practice with my typing. Total rows, long again, has to be the same, wouldn't it? And as I look down these comments, I can see I've got another variable here where, when I'm ensuring if it's a blank row or not, I want to use a variable for that. So let's declare a variable for that, which I'll call isBlank as, so I'll go here, let's say integer. I could go for byte there. How many columns wide is it really going to be? But I'll play it safe with an integer. And then last of all, there's one more variable. Where are you? Yes, it's how many we've deleted. Number of rows deleted. That was my other variable I wanted. So we're going to say dim number deleted as, let's say integer. How many blanks could there be? Okay, so we've got 4 variables declared that in my initial planning I have identified. We can always come back and add more if we realise that we've maybe missed one out. And I'm going to take that one off our comments because job done. Achieved that. Okay, so next up, we need to count how many rows we've got. Now, if I want to use a for next loop to loop through to that number, I need to know where that number is. So I'm going to put total rows equals. And then our plan was to use a count A function to count how many rows there are, which I'm going to need to put application.countA. So hopefully you've done a count A function in Excel before. Counts all non-blank cells, really useful function. In VBA, we'll need to access it through the application object. But just like any function, we'll have some opening brackets. I'll need to tell it what to count. And we're in VBA, so I'll probably use the range object, but I could use the columns object. There are other ways. I'm just going to tell it to count the whole of column A. Heavy reliance on column A here. Depending on your list, whether that's good enough. I'm relying on it as that is the name of a person in this pretend list. Let me show up the list briefly. We're going to have without a name. So maybe when entering, somebody's unsure of the city at the point of entry, but she's not going to be unsure of the name. How could you put a new joiner in without a name? Okay, done. We know how many rows. Now let's get our for next loop going, which is what this lesson's all about. So these for next loops, as I say, they run a predetermined number of times. So either us or Excel know how many times to run it, and we want to access that knowledge. We don't need a condition to exit. We have no idea. The structure of them is to put for, and in my case I'm going to say r equals 1. So you might have noticed that I didn't initialize r in the initial near the top of our macro, which we normally do. It gets initialized within the for next loop. For r equals 1, 2, and there may be scenarios where you can just say like for 6. Repeat this action 6 times, or maybe it's 12 months in the year. For r equals 1 to 12, and at the bottom you'd put next, and that's the structure of your for next loop. So you can run it that predetermined number of times. It may just be as simple as telling it how many times to run, and it will repeat them actions that many times. In our case, it kind of is that simple, but instead of typing 12, I need to put total rows. So we've got a variable, so we've actually figured it out first, and then supplied it for a for next loop to run that many times. So in this example, that should be 1 to 92, because total rows would have figured out as 92 rows. In our next lesson, we're going to be looking at a for next loop to loop through collections, which is another really popular use of a for next loop. So I'll leave that for the next video, but just to set a teaser there for other stuff these loops can do. Now the word next at the end, just like for do loops, put the word loop. You might see people put next r. No, it's not necessary for me to do that, but sometimes it can help, especially if you're nesting loops, which is also a topic for a later video. It will help you track what that next is for, what loop is that closing. It may be more descriptive if you put next r. But it's not necessary to do that, and you saw it was happy for me without it. Now it's there, I think I'll leave it in there. Let's get myself a bit of space and some indentation. Maybe scroll down this a bit. Ready? Okay, so within this loop, so let's say we're in row 1 at the moment because r equals 1. What do we need to do? First thing I want to do is I want to check and see, are you empty? So I'm going to put is blank, which is the variable I decided to use to count what's in the row and store that information in. So equals application.countA. But this time what we'll be counting, so I'm going to count rows, and when it asks me for what row to check, I'm going to put r, closing bracket for rows, closing bracket for count A. So what that's going to do is it's going to count everything that's in the row with that index number. Initially row 1, but that will increment each time because of next r. Look at the second row, count what's in it, store it, next row. So it's always going to store how much is in that row. Right, let's remove some of these. For next loop is in. Sure, it's blank. Okay, we haven't deleted it yet. So, count what's in there, store it in is blank. Now we've got the information, plan is to test it. So we're going to say if is blank equals 0, then if is blank equals 0, then there's clearly nothing in that row. Let's put my end if in, good practice. If is blank equals 0, then So then, if that's the case, what we need to do is delete that row. So I'm going to put rows are dot delete. If they equal 0, delete the row. Rows are dot delete. Ensure the row is blank. Store that information in the variable. Delete it. Done. Okay. Another plan is to count how many rows we're deleting. Store it in a variable. We have a variable, number deleted. Now that we've deleted one, I need to put number deleted equals number deleted plus 1. So increment that number. Now we've deleted one, add it on top. And that will be that. It's only going to do it if it's deleted. It will then move to the next row in question. So hopefully this will do our job. The last bit here is to put a message box for number deleted. So underneath all that, I'm going to put MSG box. Our message is going to be number deleted, and I'm going to concatenate a message on the end. Rows were deleted. Okay. The number deleted and rows were deleted. So that would end up saying like 8 rows were deleted, or whatever it may be. I think it's 7 or 8, something like that. So this is just an example of a simple little macro, little project that's going to go through and delete kind of single occurrences of blank rows within our list. We've tried to recap on some topics so far, like concatenation of kind of text within a message box here. But the main topic, of course, here is our for next loop. And if I was now to kind of restore that window, and if I click inside this procedure and look to step through it so we can see it in action, got my locals window at the bottom tracking our variables. As I move through, I can see that will run and count 92 rows. So now, as we see here, it's doing for r equals 1 to 92. That predetermined number of times. It will go inside because it's on 1 at the moment. Check if it's blank. It's not. It's got 4 things in that top header row, that row 1. So it will skip that bit and go to next r. So r goes to 2. Obviously that's not blank either, so it will move through, go into 3, go into 5, go into 6, looping back round to 7, count it, count is 0. Row 7's got nothing in. If it's got nothing, move inside, delete the row, add one on top for number deleted, and move to the next r. So that is a simple little for next loop, looping through a repetitive number of times. I'm going to hit my play button to finish that off. 7 rows were deleted. I know it was 7 or 8, one of them. So that is our for next loop. We're going to see another example one in the next lesson, but a counter loop, as we commonly call it. Hello and welcome to this lesson on using a for next loop to loop through a collection. So what we're looking at doing is we want to apply worksheet protection to every worksheet within this book. And there are 3 sheets within this book, named after pretend stores for our business. And we're imagining that we get this received from a client, or just before we send it to a client, and we want to protect all the sheets. I want to do that quickly. There's 3 in this book. Sometimes, depending on what we're sending them, there might be 5, there might be 12, there might be 2, there might be 20. So we don't know. Good thing is Excel does. It stores this information in what's called a collection. So Excel knows how many cells are in the range you selected, how many pivot tables there are, how many charts there are, how many workbooks you've got open. There are, a number of collections, and it's a really, really useful loop to get to grips with. We're going to use a counter loop, a for next loop to move through that collection until the end, till it runs out of how many sheets there are, that predetermined number of times. So switching to the editor, I've just set it up with a new module and procedure here, protect all sheets. And the first thing we're going to do is declare a variable, which I'm going to call I and store as byte. So we're going to use this variable to store the index number of the sheet. So in this example, going from sheet 1 to sheet 3, but however many there are. Very common to see I used as some kind of increment or like an integer to count through. Byte, no more than 255 sheets. Okay, for next loop we're going for. So I'm going to say for I, my variable, equals 1, start from number 1. There's nothing stopping you in some of these loops saying start from number 2, start from number 3. It doesn't have to be 1, it just so happens in the previous video in here, that's what we've wanted. For I equals 1, 2, now I need to say how many there are. I could do 3, but I want this to work in other scenarios too. So I'm going to say worksheets, the name of the collection. So we could have workbooks and examples like that. Say worksheets, the collection. Dot count. So what it's going to do is count. You see that's a property. It's a property of, I believe, all collections. It's got a plural version. So we've got things like active sheet, then we've got worksheets. So the count property, it knows how many sheets there are. I'm then going to put next. As mentioned in the previous video, I could put next I, but that's not necessary. In the previous video, I put R in there, so I think I'll leave it blank this time, just to demonstrate that it's not necessary. Although it's not a bad practice to use. So as easy as that, I have a loop now for all the sheets within this book. So that's going to do its thing. Now what I need to do are the actions that I want to repeat. And I could write, loads of statements in here. For this demonstration, it's just going to be a quick and easy one. I just want to protect the sheets. I'm not going to worry about a password or anything like that. Just a simple turning it read only. So I'm going to say worksheets, opening bracket. So not our first time using worksheets in this course. That will prompt us for the index number of the sheet. So I'm going to tell it to use index number I. Dot protect. So I'm looking at protecting each worksheet. So we'll start from worksheet 1, protect the first one, next sheet, protect the second one, next sheet, protect the third one, next, oh there's no more sheets, end. So much smaller macro this time to get the feeling of going through collections. And if I was to, I might as well just run that actually. If I demonstrate the behind the scenes that everything's available for me on this London sheet. If I went to Bristol, it's all available for me. Manchester, it's all available. The review tab, it's not protected. Let's give this a go. Let's pop into here and let's go straight ahead and play it, shall we? Done. I can see it all ghost out at the background there. Hit review, that's protected. That's the Manchester sheet. Bristol, protected. London, protected. So all three sheets are protected. I could quickly knock up another procedure to unprotect them. It would just be a case of, copying this code maybe and changing that to unprotect. You've got a nice fast way of protecting all the sheets in a file and also unprotecting all the sheets in the file. An otherwise tedious process. So another for next loop there. In the next video, we're going to be looking at the for each next loop to start looking at using references to objects within our loops. Hello and welcome to a lesson on the last of the three main types of loop in VBA, which is our collection loop. And we'll be using a type of loop known as for each next. So we actually looked at looping through a collection using a counter loop in the previous video, protecting sheets. Now we're going to look at looping through a collection using object variables. So we can create these variables as a way of referencing an object easily, such as within a loop. And for our main a demonstration in this lesson, what I'm looking at doing is I've got 3 cells with some text in, so my favourite TV characters here, and what I'm looking at doing is converting all the text from a user selection to uppercase. So this is going to be a demonstration of looping through a collection. The collection will be the user selection, so whether I select the whole column or a single cell or a range of cells, we can loop and perform an action on every cell within that selection. As you can imagine, one of the most popular, also one of the most common things you're going to have to do in VBA is perform an action to every cell within a user selection. Just think for a moment about all the things you do in Excel, selecting cells and converting them to currency or turning them bold. Very, very common action. So we're going to use this convert set to uppercase, something that Excel doesn't handle very easily by its normal nature. So let's switch to our editor, and let's get into the right module. So I want this book 1. I've just got a new workbook. I won't have a file to download in this example. And I've just started up a quick sub-procedure called convert to upper. And the first thing I want to do is declare a variable, which I'm going to call RNG, as range. So we've got an object variable, which is going to act as a reference to a range, which you'll very commonly see called RNG, or just R. It's quite common things people generally call them. You can call them whatever you want. And then we're going to start up our loop, which I said is called a for each next loop. So we're going to say for each RNG in, and then we're going to give the name of the collection, which in this case is selection. Now, if I remember rightly, we saw selection, and it was on a sheet that you could look at in a previous lesson when we looked at referencing cells, sheets, and books in different ways. Mega thing to know that just the word selection is a collection of all the cells that the user has selected. So at the moment, in the background for me, just D8. But the brilliance of that is it will work on any given user selection. Excel knows. RNG is just a reference I've created to be able to reference a range, because I won't know the name of the individual cell, so I could just say RNG, and that is it. I'll need the word next, as we do in a for each next. As we do as a for next. This one's for each, where the idea is that this might be an easier way of looping through a collection as opposed to the previous counter. So there's nearly always more than one way, and you may not agree. But the benefit here is that we can reference a cell using a simple word like that. We could have even put a selection in the variable and use that as well. I mean, that's quite easy on its own, but we could have created our own name for it. So it makes referencing objects a lot easier than maybe using a counter loop with like the cells object or the range object or something like this, or the name of a sheet. This kind of idea. Now, to convert it to uppercase, I can just say RNG equals. Oops, where's my equals gone? Let's try that again. Here we go. And I'm going to use a function called uCase, which will convert to uppercase. It's one of them VBA functions. Opening bracket. That will prompt me for the string to convert to uppercase. I will say RNG, closing bracket. And as easy as that, we should have a loop that will loop through our selection, converting each range. So, for example, if I select them 3 cells in the background there, just bring my editor back, and if I do F8 to loop through this, now we're not going to see the cells move because I'm not actually selecting them. But if we keep our eye on Mickey Mouse in cell C3, as we move in the loop, you can see the locals window storing information about the RNG object there. It will convert it to uppercase. Bounce to any other cells in there, and we're still in it. It knows there's 3. Bounce back. Last one. Bounce back, and it's out. There was only 3 cells in the selection. RNG resets itself to nothing I can see at the bottom there. So that is it. We can loop through a selection and convert cells to uppercase. So whatever that selection may be, let's quickly tap in hello and goodbye. And I'll just give it one quick other demonstration. Let's get out of that cell. Let's reset that and loop again. Whoops, let's select a cell first. Let's reset that. Select a range. Back into the editor. Go, go, go. Uppercasing it all. A for each next loop. Now before we come out of this lesson, that's our primary example here, but I wanted to just open up the module for protect all sheets that we saw on the previous lesson. I'm just going to switch to that file as well. So here we are, this was the file. And we're going to use a collection loop, one in for each next loops, to protect all the sheets of this book. Something that we did in the previous lesson in a slightly different way. So this time, we'll declare a variable, which I'm going to call SHT, but you can call as you wish. And that is a data type of worksheet. So it's the object variable known as worksheet. And then we can use our for each next loop. And I can say for each SHT, because that's going to act as the worksheet, in worksheets, so worksheets is the name of the collection that I want to loop through. Excel knows there's 3 sheets in that. Next. So in the middle, I can just put SHT dot protect, or whatever it is I want to do. And I may have multiple things, which means this variable makes it easier for me. So another way of looping through all the sheets in the book, you may find it easier because it might read better for each sheet within worksheets. Kind of rolls off the tongue. But yes, it's a kind of alternative to a counter loop when running through collections. Brilliant for looping, doing things for every sheet, every chart, every cell within a range, every workbook, for example. So if I was to play that loop, or play that procedure, and look in my background, I can see that all the sheets, no surprise, are protected. So we've achieved that objective using a different loop. So that is the last of our 3 main types of loop, for each next loop. Next video we're going to look at nesting loops, just to kind of take it up a notch. Hello and welcome to this lesson where we start to look at nested loops. So the concept of putting one loop within another. And for this example, we're going to revisit the inventory sheet where we were looking at our conditional loops or our do loops earlier in this section of the course. And what we're going to do here is we've got our inventory sheet from earlier, but this time on the update sheet, instead of the one update that we've been having earlier, we now have a list of multiple updates. In our example here, 3. So what we want to do is we want to perform the loop for bananas. And just to remind ourselves, the plan is to look for 1009 down this list of inventory. In this example, we will not find bananas, so we'll add it in as a new entry. Then we want it to pop back to here and loop to the next one. Look for 1004, look for that, find lemons, add it on top, today's date, come back here, look for the next one until it runs out. So we're going to have to loop on the inventory sheet whilst we're looking for it, but we also need to loop on this, we need an exterior loop to loop on the updates to happen. So let's pop back to the editor. So this is the code we've got in the file to download, or from previously in that lesson, where at the moment the item ID in that is accepting the range object. And we've got our do until, and a boolean variable loop for looking through the inventory sheet. So what we're going to look at doing is adding an exterior loop for the other update sheet. And I'm going to use the cells object like we have on the current loop. So our first plan is to add a variable name, which I'm going to call I, and store as integer. Working on the idea that I'm not going to have more than 32,000 products to update. So I'm going to use the I, typically short for integer or incrementer. It's a common thing to put as some kind of counter. And then I'm going to store that in my initialization area. I'm going to say that I equals 2. Where am I going? I equals 2. Give an initial assignment. It equals 2 because, just to remind ourselves, if I pop back to the sheet, the first record in the update will be the second row. And then I'm going to start to put a loop together. So I'm going to put a do until loop. I'm going to use the cells object I,1 dot value equals empty. So I know that somebody's going to be on the update sheet when they run this, because that's where the button is. I'm saying do until the cells, so currently A2 there, first column, and I equals 2, so second row, do until you run out of updates. And I'm going to scroll down to the bottom of our loop, and I'm going to put the word loop after that one there for the exterior loop. So I might actually add a comment after that with an apostrophe there and say that this is the exterior loop for the update sheet. So if I'm looking at these loops, I know what one's what, and there's only 2 here, but it could potentially be more. Okay, so now we've got this in play, I'm going to revisit these range objects that we had. What I'm going to do is I'm going to move some of that stuff to inside our loop. So these, and I keep searching equals true, and that, this bunch of stuff is going to go within our exterior loop. Because every time we go to an update, I'm going to have to update the item, product name and delivery with the next one. Keep searching will need to be reset to true before, oops, didn't mean to scroll there, before it re-enters this interior loop, and the row number will need to be set back to 3 so that when it goes back to look in the inventory sheet, for example, the second one will be lemons in this case, after adding bananas, it will be returning to 3 to start again at the top of the inventory sheet. So I'm just going to simply cut and paste these lines so that they occur as the first things within that loop. And I'm going to change the range object, because saying A2 is not good enough anymore, to that I,1 cells object, and for the others the relevant column, I,2, and for this one will be cells I,3. So instead of a range object, as we loop through, and this I will be incremented, and we've still got stuff to look at, it's going to grab the ID, product name, delivery, reset, keep searching, go again from number 3 onto the inventory sheet, let's go, do it until it's false, come back round next one. Talking about next one, this will need to be incremented, start from 2, do your thing. Once we've found it and done what needs to be done, and that loop is ended, before we loop back round, I equals I plus 1. Increment the row number for when we come back round, we can check that that has got something in it, or if it's empty, don't do any more. Notice that there's no reference to the worksheet in this test. So after the incrementer, now we've moved to the inventory sheet there, when we do this test, we'll have to make sure we're back on the other one. So after the incrementer, I'm going to say worksheets, update, dot activate to move ourselves back to the update sheet. Now this is beginning to look like the part. I think the only thing we're missing now is an area at the bottom of this sheet. Oh, we don't need this anymore, this reference to update, because I know it's going to move itself back there. So I don't need that line. Let's delete, whoops, let's keep the A2, but let's delete that line. A2's okay, that will always be the first one. This, all of a sudden, is not. Clear the contents of A2 to C2. Now I can't guarantee how many rows there will be to update. I'm going to need our loop to figure that out itself. So this sounds like the use of another variable. So at the top, I'm going to create a variable, which I'm going to call num new stock. So how many new stock items are there that we're adding? So I'm going to store as an integer. And to initialize this, which I think we'll do after that incrementer, I'm going to say new num stock equals, I'm going to use the count A function here to count the contents of column A. So count how much information there is in column A, including the heading, because the way I'm going to do this is capture the last row number. So I call it new num stock. It's kind of like new num stock plus heading. But we know what we mean by how many stock. Like where does the list end sort of scenario. Count the contents of column A, that will give you your answer. So for example, on the update sheet, count column A, oh there's 4. That will be the last row. Let's pop back to the editor. And now we've got that information in new num stock. No need to reference a sheet because somebody will be clicking the button on that sheet. Down here, I'm going to remove this 2 from the end of that range. And after the speech marks, I'm going to concatenate new num stock onto it. So it's going to be A2 to C blah. In a first instance, it will be C4. But that will figure itself out because of our variable. So this, I believe, is it. I hope you've followed that through okay. We've looked at adding an exterior loop, a second loop. Let's give it a trial run. I'm going to restore my window a bit and bring in the locals window. I'm not sure if that's going to come in handy or not, but I've got a few variables now, so might help reference. And I'm on this update sheet. So typically, I'd click that button. But let's step through it. It's F8. Variable not defined. Oh, I've put my variable names wrong. Look at that. Num new stock. New num stock. Let's click OK and change that round. That's a fantastic little reminder that as to our option explicit line and what that can do for us. I wonder if that means I've got it wrong down here as well. I have. It's num new stock. Let's delete that. Num new stock. It's a click away. Look at it liven up. It likes that. Alright, let's reset that, shall we, and try again. Oh, here we go. Locals window at the bottom, populated with variables. In we go, count it. So we look at the locals window, 4 num new stocks there. In we go. Let's watch these item IDs. Boom, boom, boom. We've got 1009 bananas and 20. Search extrude, number 3, switch to the inventory sheet, off it goes. And in we go looking. Now it's going to have no success looking for this first one. Bananas is not there. So I'm just going to quickly keep looping through. And we can see the row number in the background changing. It's on row 7 at the moment. So it's checking the strawberries one. So 2 more. Off we go. Back round, what we're on now, we're on 9. This is good. So it will go in. It's not a match. It is blank. In you go. And we can see in the background now on this sheet, bananas is going in. Boom, 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 boom. Round we go. End if loop. Foul. I equals I plus 1. So now we're on to row 3 on the other sheet. Move back to the other sheet. Exterior loop. Do until you're blank. That is not blank, so in it goes. And we can see now it's gone to these variables 1004 lemons 50. Reset to true. Reset to number 3. Back to the other sheet. Let's go again. No match. Second time going is a match. And I can see 34 went to 84 there in the background. 19th of Feb is about to get some treatment. There we go. Loop back round to the next one. So we can see our exterior loop seems to be working fine here, as it looping within one loop, coming back and working with the other loop afterwards. Now if I can shoot through this, I should at some point get to the end. I could hit play to be honest, but trying to do it properly. I'm in row 10 now, so it is checking the last one. Here we go, adds blackberries in there. Goes to the second loop, misses out, clears the contents. See, they all go and updated. Our exterior loop, absolutely fantastic. Now, just looking at that, there's absolutely nothing wrong with this. It worked an absolute dream. I'm just thinking that do until loop, although it's absolutely fine to say to look for blank, we do now have num new stock recording information. So what I might do is change that to a do while, and I might say do while I is less than and equal to num new stock, because now I know how many rows there are. It's recorded there. There was 4 a minute ago. This saying do while you in that range. Now, there's nothing wrong with how it is. I'm just trying to incorporate information I have like this, trying to keep some uniform to it. And so I hope you followed that through okay. So we get to our more intense examples here. I want to make sure we don't lose ourselves. You know, this kind of stuff just takes practice. You know, we've got examples here that you can download these files and you can keep testing them out and get used to it. But a lot of the key really is to have a play, try changing it round, try and create your own scenarios and complicate them and see how you can get around them with the skills we're doing on this course. These loops, these variables, these conditional statements like your if then else and your select case. Hello and welcome to this lesson where we look at a few simple lines of code that we can add to our procedures to make them execute faster, but also to prevent some interruption that can happen depending on what your procedures are doing. So I've just got open the a macro that we've been using a bit on this course, this inventory list. Any file will do for this, so I'm not planning on providing this for download. Any file will do, and this file was not really big enough to justify some of the things we're going to chat about anyhow. But I'm going to switch to the code view, and these lines of code I'm mentioning, I'm just going to be near the top of this procedure So I'm using this as a kind of guinea pig for this. Typical place they'd go is probably just after the variable initializations. It depends what they're doing. Depends how you're initializing. There's no hard or fast rule. But the first one is application.screenUpdating. Now this is the most common one, the most popular one of these lines of code we're going to mention. What we can do is we can turn off screen updating by saying equals false. And this will prevent that flickering on screen. So if you've got procedures similar to this one that are moving between sheets and are looking through cells on a sheet, we can turn off the screen updating. That will prevent that flickering. It means that during the procedure, Excel will not have to update the screen, which ensures that your procedure executes much, much faster. It also stops that flickering, which can, at a minimum cause a headache, and at most could potentially be dangerous, that kind of flickering of your screen. So we literally just turn that off, and then probably copy that line. Well, not properly, we should do this. Copy that line, move to the bottom of a procedure, and maybe just before my message box. Just before my message box. But after actions like select, because that's the kind of screen updating we don't need to see. I don't need to see it select a cell, just select it. And I'm going to change it back to true to turn screen updating back on. So this is a typical thing to do, to switch screen updating off at the near the top, and to turn it back on at the bottom. This will drastically improve the speed of your macro. I mean, it improves it a lot. It all depends on the size of your procedure and what it's doing as to whether you're going to notice this different or not, but it does make a difference. And it stops that flickering. Now, because this is on the application object, I don't really even need to type application. You probably find that I do a lot on my code. It's partly habit, but I like nice readable code. Once again, there's no hard or fast rule. You'll talk to one person and say, "Oh, I should put application," like I have there as well. You talk to somebody else and go, "Why are you bothering? You don't need to. Screen updating, it's shorter code." Blah blah blah. So I'm going to add mine back in because I'm a fan, but it's not necessary when on the application layer. So on the Excel layer. Okay, let's look at another one. So another one is application.displayAlerts. Now what this will do is we can switch this one to false, and this will stop the interruptions, some interference. Display alerts will prevent certain alerts that, if not switched off, will interfere with your code. So whilst the procedure is running, the procedure will have to pause to display that alert to you, and will not continue until you answer that alert. Once again, this will typically be copied to the bottom, that line, and pasted below what I've got, and false switch to true. Very important, this one. You want your display alerts back on. Now, a typical example of this happening will be the deletion of a sheet. Now, I've just added this sheet in solely for this purpose. If I go to delete that worksheet, I get that message. That is an alert. So if your procedure was to delete sheets, your procedure would have to pause to display that message and use a click delete before it will continue, unless you have switched display alerts off. And if your procedure's deleting sheets, there's a reason for that. You don't need that message. You know you're doing it. That's why you wrote that code. So you probably is something to switch off. I'm going to cancel that. Not that I really need that sheet. I should mention, because I'm adding more things to the application layer now, I'm trying to scratch my head and think how much we've spoke about this on this course, or if we have. But it's a very basic structure called the with statement that, as I'm a fan of using the word application, I could still abbreviate this by saying with application, and then I could indent these lines, get rid of application there, indent that, oops, end with. So I can put it in a little structure like that for readability. I'm repeating the word application, I don't need that. With application, dot this, dot that, dot this, dot that, end with. You know, it makes your code more readable. And I'll do the same down below on the other example, but I can't bother to do that now. I'll just be repeating myself, really. Okay, let's add one more. Let's stick it into that with structure that I have. The last line to display for you, to mention, that can improve the speed of your execution is dot calculation. Dot calculation. This one is not set to true or false. This one is equal to, and to switch calculations off, we would say calculation manual. So every time your procedure will do something, like change a value or something like that, calculations on your screen will calculate. So if you have a lot on there, if you've got some VLOOKUPs and whatnot, some if functions and all this jazz going on, this will also add calculation time and really slow down your macro. So we can set them to manual so that during the I'm going to copy that now. During the procedure, they will not have to calculate every time something has changed. You can say, right, just calculate when the macro's over. I might not. Might is the word. I can't speak for your procedures. I haven't seen them. I don't know what they do. But they might not be necessary during the procedure unless they're relying on some of their values. I've just copied that while I'm talking, changing them to true, and I'd need to set this to automatic to turn it back on. Which I think is that. Let me backtrack. Let me just put that in. Equals, and it should come up for me. Yeah, it's just that. Yes, you may have covered this before. If I pop into Excel in its normal interface and go to formulas on the ribbon, we have these calculation options over here. So that's what I'm doing. Excel defaults to automatic unless you've dabbled with that in the past, or somebody else on your laptop has, for example. But during our code, we can switch that feature to manual, switch it to automatic before we come out. So you've also got the button there that you could manually change. But we can do that within code to speed up our procedures execution. So we've got two lines there that will make big differences to the speed. Another one to prevent interference. Certain alerts, probably the most popular one being the deleting sheet alert. But there are obviously others that will, when added to your code, improve their speed and their efficiency.
Hello and welcome to this lesson where we start to look at some more debugging tools in Excel VBA. Now, something you are sure to get in your code are bugs. Everybody gets them from making simple typing mistakes or errors in the logic of your code. Now, during this course, you've seen me use the locals window, which personally I'm a big fan of and tend to use a lot. And we've also seen stepping through the code by pressing the F8 key and moving through each bit of our code, looking for mistakes or understand how it works. Plan of this video is to check out a few other debugging tools that we have not yet covered. So in this code we've got on our screen, which is our stock sheet macro still. So it's just following on from the nested loops tutorial. we have two errors. I've got an error here where it should say I equals I plus 1. I've got it plussing 2 on the loop. And on our spreadsheet itself, I have a typing mistake by a user. In the delivery, somebody has managed to press the Y key by mistake, so that data is coming as text. And as the plan is for it to add the delivery on top of Mango, it's not going to add text. So that will be an issue. So let's go back to our code. And the first debugging tool I wanted to mention is setting breakpoints. Now, breakpoints can be set in a few different ways, and the idea of setting breakpoints is really for if you've got quite a large macro, especially if you've got a large macro. And we can set a point that our code breaks when we play it. So rather than stepping through every single line from the beginning using F8, I could, for example, if we wanted to break at this point here, the beginning of the loop, shoot through this initial part where we do some assigning and some calculating. We start the first loop and assign things to variables and select a sheet. Stop here. One way I can do that is click in this left-hand margin, and by clicking there, you get this kind of white font on red background. That is a breakpoint. I can also, I can remove that breakpoint by hitting the red circle. I can also do it by clicking anywhere within that line and pressing the F9 key on the keyboard. So F8 to step through, F9 to toggle on and toggle off breakpoints. And these can be found from the debug menu as well. Toggle breakpoint F9. So let me turn that back on, and you can set multiple breakpoints. So I could maybe set another breakpoint here for the else if. Maybe once you've stopped there, I need to check my code. I might have a look over the variables, see how we're working, then play it again and stop it back here so I can check things out again. So I just gave that a go. If I hit my play button, we'll see it jump to this bit of code, at which point I can do as I wish. I can hover over, keep searching equals true. Row num is 3. I can see what's going on. Hit play again. It shoots the next part. So rather than stepping through every line, so it shoots here, and I'll double check it again. Row num still equals 3, and so on. So they are your breakpoints. I'm just going to reset my code. I'm going to press my stop button to come out of that break mode. And I'm going to remove my breakpoints. So you're setting breakpoints, similar to a stepping through, but you've got maybe a faster way of doing it. If you need to jump to a particular part of your code, they will allow you to do that. Let's start focusing on the actual errors that we do have here. And if I just played my code right now, I receive a runtime error. So we saw earlier in this course there are different types of error you can get. This is a runtime error, error 13, type mismatch. And if I click debug, which is a debugging tool in its own right, it's taking me to what it believes is my first issue. And I'm only saying that that it can't assign cells I1 to item ID. Now this mistake at the moment, if I move back to my sheets, is that I'm on the inventory sheet when I hit play. I'm on the inventory sheet. I should have been on update when I played this. Now in reality that's not going to happen, because the update sheet is where the button is. Now, if people are running it from this button, we do not have a problem. It's just because I'm running it through play and I was on the wrong sheet. And it didn't accept the mismatch of, what was it trying to do? It was the third row, was it? I'm not even sure what I was on. Row num I equals 2. Yeah, he was looking at text. Okay, let's reset that. Let's double check I'm on the right sheet this time. Update. Let's look at playing it again. Must be good now. Another one. Same error message. Runtime error 13. Type mismatch. Let's debug this time. And now we're on a different variable assignment. So now we've got to check out what's wrong with this one. Now if I hover over the delivery variable, let's get on the right one, it says that equals to 40. So delivery equals to 40. If I have a look at my sheet, tell you what, let's restore this window. That might make our life easier. 40 is for blueberries. So the delivery variable still contains the value for blueberries. Okay, no problems there. Let's try and figure out what's going wrong with this. What does product name say? That says mangoes. So the previous variables are storing data for mangoes, but delivery still has 40. So they've still got a previous one. The issue is that it couldn't assign this. I guess looking at this now, it's quite clear that it had trouble with that text. But we can also see that it seems to be missing out oranges, because the previous one for delivery was 40, so it seems to have skipped oranges there. What I was going to use the immediate window to try and help us figure out what's going on here as well. It's a demonstration of what that can do. We can display the immediate window by using the shortcut Control G, or by going to View and choosing the immediate window. An immediate window allows you to type code in there, so you can see what the answer to your code might be before you actually put it within your macro. So you can test out logic and check assignments to variables and all this kind of stuff. So for example, if I wanted to check out what I has, the variable I, which is the one that is tracking our external loop, the one on this sheet. And as you saw, I don't know if you noticed that a second ago, if I hover over I on the code, and we've seen this already in the course, it actually tells me I equals 4. So I don't need the immediate window for this, but it is, it will allow me to do a job. And in the immediate window, I can do this by using $I. So I'll put a question mark before the variable name, pressing enter tells me that contains 4 at the moment. Useful, I guess, if your code is large, you don't want to scroll to the instance set variable to hover over it. Some people swear by use of the immediate window. They love it. If I'm honest, I don't use it as much myself. But hopefully we're seeing the benefits of just some of what it can do at the moment. So that tells me it's 4. It's looking at row 4. This gives a good idea as to the fact it's missed out oranges. Maybe I'm not quite sure why at the moment. Obviously we know why because I mentioned it before, but maybe we're not quite sure why. But it's given us a good idea and putting us in the right direction. Let's say I can't see this sheet in the background and I want to know why there's a type mismatch. What I can also do in the immediate window is use debug.print. It's one of the main reasons people use it in my experience. I can print information to the immediate window, debug.print. And I'm going to print cells I,3 .value. So I'm printing the contents of what I'm trying to assign to delivery there. So that will print Y78, which we can see in the background, and hopefully gives away the issue here, that is a text entry, and that is why we have a mismatch. Delivery variable only stores integer values. Now we spoke about variables earlier in this course, and if you don't specify a data type, not quite as easier to debug. This is what we're talking about. If you don't specify a data type, it will have the data type of variant, which is very useful, but not right now because our variable would have just accepted that. But okay, yeah, I'm happy with that. And then it wouldn't have been able to use the formula because it is text. So this in some way helps us troubleshoot this kind of stuff. Okay, so that's a couple of examples what the immediate window can do for us. and hopefully bringing that error to our attention. I'm going to close this immediate window down now. I should mention, you see I've got it hovering. It would normally appear at the bottom like your locals window does. It's just something that you see people do a lot, and I've done here. It's just to drag it round so that you can type next to your code. I'm going to close that down. I'm going to reset my my macro, and I'm going to change it in the background here. Let's put 78 over the top there. Let's correct that. That is fine. Now we know we've still got the other issue, which is this one here, which we kind of saw there as well, that it had I equals 4, so it seemed to jump. Maybe if you're not quite sure why, let's work on that theory, why it was 4 and it doesn't seem to be doing it for each one. I was going to use the watch window as an example of troubleshooting this one. Now yes, the locals window could do it. Yes, we could hover over I as we're in break mode and running through, and that might help us troubleshoot it. There are other ways, and you're going to find your own way of doing this stuff, your own tools you like to use, and your own way of writing to a degree. There is a universal kind of standard as well. But here we're going to look at the watch window. So once again, no surprise really, the view menu is where we bring in this one called the watch window. And the watch window is where we can choose what variables and expressions we track. So whereas things like the locals window shows all of them, and this code's not that big, but I've got, what is that, 7 variables. You know, there might be a lot to track down there, especially with object variables. So the watch window allows you to choose which ones to track. Now I've got the watch window down the bottom, just like locals and the immediate would do by default. I'm going to right mouse click anywhere in that watch window and look at adding a watch, which we can also do from the debug menu. And one thing I'm going to add watch for is I'm going to add watch for row num. So one of the variables we've got is row num. This keeps track of the row number on the inventory sheet as we move through. So I'm going to watch that expression down there. Just picking and choosing the ones I want to keep track of. So I'm going to click OK. And at the bottom it shows down there row num. It doesn't have any information about it as yet. Now I'm going to go and add a second watch, which is the one I really care about here, which is I. The one that tracks the row number on the exterior loop or the update sheet. And for this one, I'm going to ask it to break when value changes. So what this is going to allow us to do, and it's kind of similar to our breakpoints now in a way, but a little bit more intelligent in this example, is when I play my code, it's going to stop every time I changes. So in this case, it's going to stop every time it has to move through a different product here. It's a little bit more intelligent than breakpoints can do, and you just choose a statement in your code, a line in your code. So a very cool option of the watch window. It's one of the main reasons I come here, I think, if I'm going to use it. Which is a big if, once again. I'm not saying I use this kind of stuff a huge amount myself. It's mainly if I'm writing very large codes I'm finding difficult to track. So I'm going to say break when value changes. I'll click OK. I appears at the bottom. Not much to see down there. Slightly different icon. So what we'll do, let's have a look. I'm going to hit my play button. I'm on my update sheet. Just hit my play button. Right, it's stopped here first of all. And it's because I has changed. We've done the I equals 2. So the initial assignment there, I can see I equals 2 in my watch window. Integer data type. Row num equals 0 and is a long data type. Let's hit play again. Now we're down here because it's the next instance where I changes. So now it's telling me I equals 4. Row num is 11. So it's allowing me to track both of them, anything that I want to watch. But this break when value changes allow me to check each instance of I. So I've only clicked it, well, I've clicked it twice, but let's say I've clicked it once, ignoring the initial assignment. So I know that the next one should be 3. Ready? I want to look at each one in the update sheet here. Should go boom, 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 next row. But it's not. It's gone from 2 to 4. So it's helping me track what's happening. It's also taking me to the exact part of the code. So I can immediately see the issue as well in both areas. So I know that what I'm looking at doing is changing it to 1. For some reason, it's incrementing 1 too many times. Maybe I've got my variables confused, or it's a typo. 2 is next to 1 on the keyboard. It can happen. So I can change that there now. Reset my code. Come out of my break mode. I can always give that another go with the hope that it's doing its job. Bear in mind that when we're running this code though as well, it is changing values. So yeah, I'm sure I've mentioned this on the course already, but you'll be doing this on a sample, you won't be doing it on a real thing. But it did run through the loop once there, so it has added 40 onto the blueberries value. So just wanted to quickly mention that to make sure that we are happy that when I do things like press that stop button to reset, part of my code has already run. Something may have changed as an instance of that. Okay, both errors are fixed. This should now work a dream with my 3 stock items. I'm going to hit my button. What have I got? I've still got my watch window. Right, let's turn off our watches. Let's use my reset. And we can do this among other ways. Got a debug menu for this stuff as well. Not a big menu user. Right click, delete watch. Throwing I'm not really causing an issue there. Eyes, right click, delete watch. Let's get rid of that watch window as well. Let's get out of here. Boom. Done. Macro works fine. Macro has been debugged. Let's click OK. And not that we'd really notice, I guess. My notice blueberries has gone up twice now because of the initial error of the watch window still. And I don't know if you noticed the other ones went up as well, if you saw what values they were. But the fact they're cleared from here in the message box gives away the functionality. So this lesson, was just looking at a few other debugging tools, namely breakpoints, the watch window, and the immediate window. Just other tools at our disposal for helping to fix bugs in their code.
Hello, welcome to this lesson where we start to look at error trapping in Excel VBA. And in our first look at the onError object, we're going to look at the onError resume next statement. And for our example, or one of our examples of error trapping here, the scenario on this inventory list that we've been using is that the inventory sheet name has been renamed. Somebody somehow has removed the O from the word inventory, so the sheet is no longer spelt correctly. So if I was to run our sub procedure from our button on the update sheet, we now receive a runtime error. Subscript out of range, as it cannot recognize the name of the sheet anymore. Runtime error 9. Now if I click the debug button, it takes me into my editor and it reminds us maybe of the line that's causing the problem here, as it's trying to activate a sheet called inventory, of which it cannot find. So this is one of the problems that we're going to look at dealing with, or handling is the name you generally hear over these next few videos. And in this example, we're going to look at the onError resume next, which in this example is not really a good idea, and we're going to see that. But using onError resume next is a bit like the ifError function in Excel. It's a way of basically hiding errors. So you're saying that, look, I'm really comfortable with my procedure. If an error occurs, it's not a real error. It works alright, just to kind of close it down and carry on. That sort of idea. So, yeah, in this example, not a good idea. If you can't select the activate the inventory sheet, then what chance have you got? How could you look for something on it? So not a wise move. But you will see this statement, probably overused to be honest, but you will see this in people's code, and you may find a need to use it yourself. It's not completely redundant, but we're going to look at better ways of handling this. Now this on error resume next statement you will typically see quite early in somebody's code, either just before or after the variable initializations, the initial ones. Let's put it before. I'm just going to write the words on error resume next. So 4 different words, on error resume next. If I press enter, I can see they all go blue, they're all keywords. And rather than play this code, what I want to look at doing is maybe to move through the code so that we can see what is going on. So let's do just that. If I click somewhere in my code, and what is the first one we're looking for? Blueberries. It would be blueberries would be the bottom one, wouldn't it? Okay, let's have a look. That's F8, and I'll start stepping through. So on error, resume next. Now it knows to avoid error messages. I equals 2, how many stock there are, and enter the loop. Assign the variables, this all works fantastic. Select the inventory sheet. It's not going to be able to do this. And pass till it goes. And notice it did not activate the sheet. So on error resume next, I said, look, don't show any errors. Just carry on, go for it. So now, because that wasn't successful, but it's carrying on anyway, this loop is going to happen on the update sheet. So we'll loop inside here. So row num equals 3. So what it's actually doing now is it's looking for blueberries, 1011, but it's looking for it starting from here, A3 on the update sheet. So there will be no success. When it looks at mangoes, there will be no success. And it will end up adding blueberries at the bottom. So let's have a look at this. No success, around you go. No success, around you go. Here we go. Are you a match? No. Are you empty? Yes, you are. And it just starts adding in blueberries to the bottom of this list. So, not a good idea. I should just put a date over here as well. Not a good idea in this example using on error resume next. But it's just to see what it does. It was to show that it prevented an error from showing, which does have its uses. But in this example, not quite good enough, and probably overused out there. I mean, I used a bad example just to demonstrate that you've really got to be careful when using stuff like that. So it just tends to get overused, in my opinion, in kind of VBA kind of environment. But yes, it certainly has its uses. But let's go and have a look at some better examples of how we can handle this error. Hello and welcome to this lesson on error trapping in Excel VBA, where we're going to start to look at actually creating error handlers in our VBA code to actually handle an error and do a different action instead, whether it's to exit a procedure or run a different line of code, but to perform a different action if an error occurs. So we've got the same error as the previous video with this inventory mistake on the sheet's name. But now if we jump into our editor, what we're going to do this time is just before the sheet reference, where we've got worksheets inventory.activate, we're going to say that on an error message, we want to divert them to a different part of our code that will be set up for handling errors, commonly referred to as the error handler. So just before worksheets inventory.activate, I'm going to write on error, and I'm going to use go to, and I'm going to write the
error handler. So that the word error handler there is not important. You can call that whatever you like. You can call it Jim Smith. You could be more specific and say worksheet name problem. You can call it whatever you like. These words obviously have to be specific. On error go to, and it's just a name of the section of our code, which at the moment does not exist, but we're going to create it right now. Just before we do that, I mean, this line doesn't have to go directly before that reference. As long as it's before it, that's okay. This is just turning on the error handler. So as long as we turn it on before we use it, that would make sense. Okay, let's scroll down for our code, and typically at the bottom, so after all this stuff but before our end sub statement, I'm going to write error, spell it correctly, error handler colon. So just that line there has created a part of our code called error handler. So on error, go to the error handler, and it will leap to this part of the code. So now within this section, we just need to write what we'd like to happen. So what I'm going to do is just display a message box to the user to say that the inventory sheet name has been changed. Please correct, and try again. Okay, so the inventory sheet name has been changed. Please correct and try again. So once jump into this code, it's going to display that message to the user, and then I'm not going to take them back to where they were. We'll see doing that in another video. What I want is the next action to end the procedure. You know, as we saw in a previous one, I can't have this macro continuing. You know, inform the user while we're exiting, and then exit. So, let's have a look at this in action. If I click outside of my code and I click my button, I'm told that the inventory sheet has been changed. Please correct and try again. I click OK, and now our code will not run because there is a mistake on the inventory sheet name. Okay, so let's look at changing it. I'm going to rename my inventory sheet. Let's put that O back in there, and it is now named correctly. Back onto the update sheet, back into the code. Now at the moment, the problem we have is that if there is not an error, therefore it does not go to the error handler, it will carry on with the code, which is brilliant. But at the moment, it will still perform this action. So when it's finished, it displays a message box to the user. It will then do the error handler as well. So just to demonstrate that, if I just insert a breakpoint here for a moment, and if I play this code to take us to that part, so I'll play this code, and it updates all the inventory sheet. And if I can F8 from this part, so it then clears the stock, says to the user, oh, I've updated it, yay! And it moves on and tells the user the inventory sheet needs to be changed. So I don't want to display that message box when everything's working fine. That doesn't make any sense. So let me remove that breakpoint. What we're looking for here is directly before your error handling code, you would have the words exit sub, so that your macro would not enter the error handling section. It would only enter there when specified due to an error. Okay, now we're getting somewhere. Right, I'm just going to create some more codes up here. So I believe, let's get back into that. I believe 1008 is mangoes. Let's make up an item, and let's get another one. Let's have 1011, which I believe was blueberries. And let's make a mistake. Y78. Error. That's not good news. Let's go back to our editor. Okay. Let's me typing on there. Let's go back to our editor. Right. So what I wanted to do here is at the moment, if there's an error, it will jump to that part of code. I've now created a second error. So with that error turned on, what we're going to do is if I set a breakpoint to here to try and save stepping through every little bit, and I'll play part of it and then kind of run from that. As we come back round this loop now onto the second item for blueberries, when it goes in and tries to assign that, we should get an error. So now I'm being told the inventory sheet name's been changed, or needs to be changed, yeah. Or it has been changed and it needs to be changed. But that's not the problem. The problem is Y78 in delivery. But I've got the same error handler happening here. So, yeah, first of all, I need another error handler to deal with that. But we're going to deal with that in the next video. All we're going to speak about for now is how we can disable that error handler. So, let's tidy this up. No breakpoint. Let's get rid of that. And just after that sheet reference, we're going to put on error go to 0. So the go to 0 will disable that error handler. So it will turn the error handler on. So if there's a problem with the sheet, it will deal with it. And at some point, in our case directly after, disable the error handler. You know, we may have other error handlers to deal with other issues. Otherwise, any error that might occur for the rest of the code will get this same treatment, which is not true. You know, our message box was very specific as to what the problem was. Okay, so in this lesson we have seen how to create an error handler and using like the go to statements to go to a label and error handler, and also go to 0. In the next video we're going to look at handling that issue I just created. So we're going to look at multiple error handlers, and then we can resume parts of our code. Hello and welcome to this lesson on using multiple error handlers. So to expand on the previous lesson where we have the incorrect or changed sheet name of inventory, we now also have an error in the delivery, the way that it's been typed or entered in column C there. So we need one error handler for possible change in sheet name and another one for possible like non-numeric entry of a delivery. Now what we'd like to do is if there is a mistake in any of the entry of delivery here for either item, we would like to move the item or copy it across to maybe column G here, shall we say, and enter it there. So any problem items will be recorded in an area over here, so that when the procedure is finished, so it will add mangoes in fine, because it's okay, but it will move blueberries over here. And when it's finished, it gives the user the opportunity to consult what they might have done wrong. And then they can always try typing it again and try again. Because there was a mistake, so we're not going to put it in there, and we're going to kind of put it into like a problem list so the user knows. Right, so let's pop into our code and let's have a look at what we've got. So here's our error handler from before, exit sub statement just before it, and here it is where it is within our code. Now because we're using multiple error handlers now, the first thing I'm going to do is I'm going to give it a more appropriate, a more meaningful name. So that current error handler, I'm going to say on error, go to, shall I call it changed
sheet name. And then down the bottom where error handler is, I will rename it to changed sheet name. Okay. Now what I'm going to do is create another error handler for the kind of mismatched item. There was an error in the way the item was typed. So I'm going to put this below change sheet name. It doesn't really matter what order it goes in there. And I'm going to call it mismatched item, colon after the name of that area. And below that we'll have the code for what to do. Now because I've got two error handlers now, in between them I should have the exit sub statement. For the same reason that we had the exit sub statement before that error handler from earlier. You know, if there is a mistake in the sheet name, then earlier on in our code where it moves to that sheet name, where are we? Here we go. Go to changed sheet name. When it shoots to the changed sheet name and displays that message, without the exit substatement, it would continue on and do the mismatched item one. So we need to say, you know, to go to that point, and in this case, exit. Now, you're not always going to put exit sub there. That's not always what you want to do. In this case, it is. The sheet is wrong, get out of the macro. But in another scenario, you're going to want to resume your macro, but at a particular point, a particular statement. So you'll be using a resume statement there, which we're going to be looking at shortly. Either resume next or resume a certain point. Sorry, I keep dragging it over there by mistake on a touchpad here of a laptop. Okay, let's have a look at what else we need to be doing. So I've just created an error handler called mismatched item. I guess the next thing to do would be to put that point within our code, and the point is going to be up here, just before the variable assignments, because this is the moment, and we've seen it in the previous lessons, that debug will alert us and go, ah, there's an error, I can't assign this. You know, delivery contains integer values, but you've typed some text in here, you've typed a string. So we're going to turn on the error handler before that. So on error, go to mismatched item. And directly below that chunk, and you know, I could put it before this if I wanted to be like uber accurate, but I'm going to put it just here. I'm going to put on error, go to 0 to disable that error handler after that and before changed sheet name would come into play. Okay, error handler done. Now we've got to create what it does. So back to the bottom here, you don't necessarily have to write it in this order. This is just what kind of makes sense to me. First thing I'm going to do is display a message to the user so they know what's going on here. They might not have realised that they've typed an error. In fact, they definitely haven't. Why would they click the button if they knew there was an error? So I'm going to display a message box. You know, error handling is all about you know, dealing with the issue in the appropriate way and doing it gracefully. You know, so you've got to be able to communicate with the user, let them know what's going on. You know, don't just say something error 1, 2, 3, 4 and just exit. You know, it's going to have to be making sure your data remains accurate and the users know what's going on at all times. So I'm going to say there was an error with a stock item. Please review and retry. That'll do us. Brilliant. Okay, there was an error. Please review and retry. Okay, after displaying that message, as mentioned, the plan, if I can pop back to our spreadsheet, is to record it here. And if there was another one here, and if there was another one here, and so on. So column G is 7 columns. It's the 7th column of our spreadsheet. Row 1. But I won't know what row to go in. I don't know how many problems there are. In this case, 1. I don't know this. So we're going to need another variable for that. We're going to need to track that as we go through. Right, so back to the top. Variable assignments. Dim. Problem row num. The problem row number. Let's deal with that R there. And I'm going to say that is as, I'm going to say integer. And then in this bit, I'm going to give it a starting value. Row num equals 1. We'll be starting from row 1. Oops. Third time I've done that. Right, let's scroll to the bottom. Let's start assigning it to it. So, cells object. Row number is problem row num. Currently row 1, but that will increment itself. Or we will make an increment. Comma, column 7. It was the first one. Column G was column 7. Dot value equals the value of the ID, which we have a little bit further up here. Where's our assignments? Here we go. Oopsie daisy. Oh, God, I've got to scroll back up again now. Here we go. So it should be this. Because this was assigning. That's what it's kind of looking for at the moment. Let's move that over. Gotta sing and hum while you do this stuff. Alright, that's okay. Let's take a copy of that line. Let's try and save myself as much hassle, and I know what my typing's like. I'm bound to make a typing mistake. Right, let's get that one in there. So, this is going to be column 2 and 3. And this is going to be columns 8 and 9. So copy the values from the stock item that's, being currently looked for or updated, and pull them into this problem area that we've kind of sort of decided to use. We'll start from column G, which is 7, and then H and I for kind of 8 and 9. After that, we will need to increment the problem row num. Row num equals problem row num plus 1. Because if there are any other problems, it will need to move to the next row. And then after all of this, at the moment, the next line is n sub. Now that was great with our change sheet name, because if that's not the name of that sheet, get out of the macro. Now, not good enough. There might be other stock items to look for afterwards. So what we need to do is resume our code at a particular point. So I'm going to use the resume statement. And I've got to decide where I want to resume. And there's 2 options here. You've got resume next. So that would take us back to where we were and resume the next line. So for example, in this case, that would be up here. And it would resume the next line, which would be like over here. So even though there's an issue with it, and it's recorded that there's an issue with it, it will carry on and try and use it. Which clearly doesn't make any sense, because there's an issue with it. So, that's not good enough in this scenario. But resume next is worthwhile knowing. We need to resume at a certain point. So I'm going to make that point. I'm going to say resume. And what shall I call it? I'll call it a next stock item. And then I need to move into my code and position that. And I'm going to position it after the interior loop. So the interior loop, remember, is when it goes to the inventory sheet and it looks for that stock item and does its thing. Now there's no need to do that if there's a problem with it. But I still need to use exterior loop to look at other stock items. So here I'm going to write my next stock item, colon. It's like a bookmark, it's like the name of a point in the code. So the next step would be to go back to the update sheet and that, which is not relevant. I don't think it would have gone anywhere else. And loop back round to the next item. So we've resumed at a certain, particular point of our macro. And I think that is that. Mismatch item, talk to the user, record the problem, increment a no number, resume at the logical place. Change sheet name, tell them what's happened, get out of the macro. So the next point would be to check our handiwork. 2 error handlers. So first of all, let's get back to my sheet. And we've got this issue with the sheet name inventory. So if this works correctly, we should get a message saying inventory sheet's wrong. And it shouldn't do anything. Let's go for it. Boom! Inventory sheet name's been changed. Please correct it. Okay. Boom! Oh yeah, I haven't corrected it yet. Right, let's go correct it. Okay. Corrected. Update sheet. Let's have a note actually. Mangoes 190. Stock level. Blueberries 80. 190, 80. 190, 80. So mangoes has got 20, so it should go to 210. Blueberries shouldn't happen. It should move over here as a recorded item. So, click the button. There was an error with a stock item. Oh no. Please review and retry. Okay, and there it goes. The inventory sheet has been updated. So blueberries has been recorded over here as the issue. And information cleared. So look at inventory. Aussie blueberries was not updated. 210 mangoes was. So our code has been clever enough to look through potentially lots of items, updating all of them apart from when it came across a mismatched data problem. So it's recorded it in this little kind of problem area to be reviewed afterwards. And it's told the user that that was the case. So there is multiple error handlers. You can have as many error handlers as needed within your code, and it's important that in some way we deal with these errors before we kind of ship this out for real-time use. Okay, in the next video we're going to start looking at another way that we could tweak this macro and run it by looking at the object.
Hello and welcome to this lesson where we start to look at using the object, or the ERR object in Excel VBA, so that this can assist us with handling our errors. Now, working on the same errors that we have been during this part of the course with our wrongly named inventory sheet and our non-numeric entry in the delivery cell there. At the moment, we have in our code our 2 on-error go-to statements, which is handling it quite nicely. But we're not actually being specific about what error occurs. This is all because we kind of know what's coming. What we want to do is we want to try and target the specific types of error more precisely. And each runtime error has an associated number with it. So for example, if I comment out the on error go to changed sheet name statements here so they don't occur, and if I switch back to the spreadsheet and press our button to run the macro, I will instead get the actual runtime error. So the runtime error for the example of the changed sheet name here or the subscript out of range runtime error is number 9. So number 9 is the number, subscript out of range is its description. And every runtime error has a number and a description. And you can find these on the web. If you Google runtime error, a list, you can find these. Now, how worthwhile that is another story, because as you can see here, we can find the number as they come up within our code and as we're testing it. But you can find yourself a list of all these numbers if you're interested. What we're interested in right now, though, is during our code, in the error handling section, we want to test to see if the error was number 9, and if it is, take a particular course of action. So rather than just saying if an error occurs here, we're being very targeted again if this particular error occurs. Okay, so let's end that for a moment. I don't need to debug it, I know what's going on. Let's get back into my code. Take them comments out. Okay, and what we're going to do is I'm just going to scroll down to where our error handling section is, and I've got the changed sheet name here and then the mismatched item one here. And I'm just going to rename changed sheet name to error handler. So I'm creating an error handling section, very commonly called the error handler, but you can call it whatever you wish. That's not important. And I'm going to get rid of this mismatched one, because they're all going within one error handler now. But the difference is that within the error handler, we are going to write an if function, an if statement to test what type of error occurred. So the first one here being the one of changed sheet name, or error number 9, subscript out of range. So I'm going to say if err dot, and then we're going to load of properties and methods regarding the object, or the err object. I'm going for number. If the number of the runtime error equals 9, then, so if it was a subscript out of range error, then display this message and exit sub. Else if err.number equals 13, now I didn't display this one, but this mismatched item runtime error is number 13, then say there was an error with a stock item, and do the stuff that we'd mentioned in a previous video. Resume next, and after that I'll have end if. So I've created one error handling section rather than wrote many go-to statements, and we're looking at using the object here to test what type of runtime error it was, so we can take a different course of action. Now scrolling back up to where the go-to statements are, the on error statements, I'm now going to change the first one that appears, which is this mismatched item one. I'm going to say on error go to error handler, as I've now renamed it to the error handler. I won't need these lines anymore. On error go to 0, don't need to disable it. On error go to change sheet name, that doesn't exist. So I've just wrapped it all in one on error statement. So if anything happens within this list, go to the error handler and start testing what type of error occurred, different course of action for each one. Disable it at this point, and on we go. So hopefully this will tackle the errors just like we have been, but in a slightly different approach, giving an example of the ERR object. So if I close this down and have a look at our code, inventory is spelt incorrectly, so I should still get the message box saying that the inventory sheet has been changed and needs to be corrected. So our test of error number 9 seems to be working fine. If I rename inventory, let's put that O back in. Here we go, it's spelt correctly. Go to update and run it. And now we're getting the check on the stock item. So inventory has been accepted It's realised the error is number 13 now, so it moves blueberries into the area and updates it as so for review. So that is just another example of testing for errors that you may decide to use or you may come across as you use other people's code. The advantage there being the ability to test the specific type of runtime error and target them with different actions for each.
Hello and welcome to this lesson on using message boxes to interact with a user. Now, it's not going to be the first time that we have used message boxes on this course, but so far we have just used them to simply display a message, such as to say a macro is complete or how many rows have been deleted, and this kind of information to the user. But now we want to interact with them. We want to ask them a question, and depending on their answer, take a different course of action. So what we're going to do is we have this inventory sheet example again open, and as things stand at the moment, what we do is we hit the button. It looks for all the products on this list, so it will look for 1008 mangoes, find it, add the level on top, update it. But then it will look for plantain. I'm not sure if I spelled that correctly or not. 1012, find it and add it in at the bottom. What we're going to do is change it so that if it cannot find that product, it will ask the user, I can't find this ID, would you like to add it? And then the person can choose yes to add it or no to kind of abort that. Because they may have made a typing mistake on the ID. That's the kind of idea here. They might have entered the wrong product. So it gives them an opportunity to say, no, I realise why you can't find it, or, oh yes, it's new. Okay, so let's get into our code. I'll just press the wrong keyboard shortcut. Would you believe? To open the Visual Basic Editor. Lesson number 30 something I think we're on, and I use Control F11 instead of Alt F11 there. Genius. Okay, let's scroll down to where this is all gonna happen. So what I want is around the bottom here. Where are we? In here. In here we have the statement within our code that says, if the cell you're in is empty, you must be at the bottom, therefore add in all of the details as a new record. This is the bit that we would want to make conditional. And the condition is going to come from the user, like their response is going to come from the user. So all we have to do here is write a message box to ask them a question, but the answer to that question will need to be stored in a variable so that we can then test it with an if statement. So let's go and set that variable up first of all. So back to the top now, a new variable which I'm going to call add new, and I'm going to use a data type of byte, because what we're going to do here is create a message box with some standard buttons that are already provided by the function. And I'm not absolutely sure off the top of my head, I think there's 9 different index numbers, but basically it's quite a small number, and we're going to be asked what buttons we want. OK, cancel, yes, no, abort, retry, stuff like this. And they've all got an index number associated with them. There are not more than 256, so byte is a safe one to go for. Now don't worry, we're not going to have to test using these index numbers. We don't have to say if it equals 4. We can use more appropriate words like VBA, VBS. But technically there is an index number involved, which is why we use byte. And straight off the back of that, I'm going to initialize it with VB no. So I'm going to create one note as byte, and I'm going to immediately store it VB no in there, which I believe is index number 7, but please don't hold me for that, and neither is it really that important. Let's scroll down to the bottom. If you start remembering that, you are doing well. Let's get into this area. We identified earlier and put add new equals MSG box. Now, so far in this course, when we do MSG box, I keep on putting space and then start writing our stuff in the message. This time, because we are to the right of an equal sign, because we are assigning this to something, this information to something, we will need the opening bracket. Technically, we are using the MSG box kind of method here, I believe, rather than a function. But basically, we're going to need the parentheses when otherwise it wasn't necessary for us to. Okay, the first question is a prompt. My prompt is going to be could not find ID. Then I'm going to close that and concatenate onto it item ID, which is the variable that has the ID that we have been searching for. Then I'm going to concatenate off that, continue with their text, could not find ID, that, full stop. Then what I'm going to do is I want to start a new line. Now I can't just press enter, it's even going to moan at me because I haven't put my closing bracket in there. What we're going to do to start a new line within a message box is after my speech marks there to finish off the full stop, I'm going to concatenate again, then I'm going to put a line VBCRLF. Now there are a few different ways we can start a new line within MSG boxes, which I'm not going to go into all of them now. You can look that up if you're interested. But you know, we can specify the number of bytes in width, and we can just put things like VBCR and so on and so forth. That little bit of text standing for Visual Basic Carriage Return Line Feed, if you were interested. But this is just something that's going to start a new line. It's kind of a line break, if you will. I want to concatenate onto the end of that. I could not find ID blah would. Actually, I need a space in. Oh no, I don't want a new line, aren't I? Would you like to add? Okay. I'm running out a little bit of room here. Let's put space underscore to start a new line. And we'll continue with our message box. Comma. This next question is, what buttons would you like in your message box? I'm going for VB, yes, no. Yes, I do want to add it. No, I don't. VB, yes, no. Comma. Would I like a title for my message box? Yes. That will say I don't know. Add new stock item. That's my my super title, and I'll leave it as that. So I'll put this closing bracket to finish that off. So what we've got here is a message box asking a question, seeing something we haven't done there, concatenating in this kind of line break, and then displaying some buttons. The most important thing of this to interact with the user. And I've also got a title, which I don't believe we've done as yet in this course. So add new at this point knows what the user has said. So what we're going to do now is test it. If add new equals VB yes, then the user has said they do want to add that stock item. So then add that, and if. So if anything apart from yes, it will just skip this part and do the keep searching equals false, which would mean they're exiting the loop, their interior loop. So I'm happy with that. It's only now going to add these if the user has said yes. So this block is conditional. Okay, I think we're alright. Shall we give this a try? So back into our window here. So plantain is new, mangoes, let's check what we've got. Mangoes is 50, so that should go to 70. Plantain at the bottom. If I say yes. Could not find ID 1012, would you like to add? So you can see the line break there. There's us concatenating on that number. Quite fancy a space in there, to be honest, looking at that now. There's our title. add new stock item, and our yes no buttons. So if I say yes, then the inventory sheet has been updated. Okay. And I can see that mango's on 70 and plantain is in. Let's put in some mangoes at 20 again, and let's put in something new. And I really am running out of fruit here. I don't know what to go for. I don't think raspberries is in the list. Battling through the berries here. And I'll have 30. Let's give that a try. Okay, I can see mangoes is in. I can see raspberries is not there. Would like to add. No, I don't want to add. The sheet has been updated. This is all clear. Raspberries is not in. Mangoes is still in. Okay, so that is adding message boxes to our existing inventory sheet macro to add interaction with the user. We're able to ask them questions and have a macro take a different course depending on that. Just bear in mind there are other buttons as well as yes, no. You've got all your classic OK, cancels, etc. As well. Later on in this course, we're going to start looking at user forms, where if you're not quite happy with a standard message box, which you've got to be honest, most of the time, most people are more than happy with that, we can look at user forms where we can provide a lot more customization to them than what a standard message box will allow. As for us right now though, next up are input boxes. Hello and welcome to this lesson on using input boxes for interacting with a user. So we looked at message boxes in the previous lesson, and we saw how we can use message boxes to provide buttons of our choice, and we can use it to capture the user's decision. So they can say yes, for example, we can capture that and take a different course of action on it. If they click no, we can do something else, and so on. Now, input boxes are typically used to capture text entries. They can be used to capture like Boolean and numeric and date entries, and even cell references entered by user. But typically they're used to capture string or kind of text entries. And we're going to see a couple of examples of what input boxes can be used for here. Starting off with just capturing a name entered by the user and displaying it in cell B3. Quite a simple example. That's just to demonstrate the syntax of input boxes. So let me get into the code window and we'll get going straight off with it. And I'm going to immediately put range b3.value, something we've done a lot in this course, maybe not b3, but you know, assigning to cells. So equals, we're assigning to a cell, and we're going for the input box. I have to be very careful when I type that. I normally type in out box. Not sure what's going on with me there. That's my issue, not yours. But let's put an opening bracket. And notice it's very similar to the message box in the questions it asks us. The only mandatory one is prompt. And that is exactly the same as the message box. It's the text displayed within the box. So I'm going to put please enter a name as a string. Then I'm going to put a comma. So it asks for the title. So I'm going to put name please. So the title, you know, what displays along the top of the input box, like we saw with a message box in a previous video. Comma. Now default, we haven't done that as yet. Now default is the default text that's going to be displayed in this input box. So I'm going to, in a string, put enter name here. So I can demonstrate what this does. And we've been asked more questions like linking to help files and positioning it on the window and stuff like this. But that's all we're happy with. I'm going to put a closing parentheses, and we have ourselves an input box that's going to assign whatever we type to B3. So let's run this procedure.
there is the input box. Title along the top, prompts in the middle there, and that is our default text. It's highlighted so I can type over the top. Personally, I don't think I'd bother with that right there. Bit unnecessary maybe, but it's great for maybe when a user has to put a date in and you want to display like today's date as default, so it maybe aids the user and speeds up what they do. There's probably better ways of capturing date entries. We'll look at user forms later in this course and stuff. There's bound to be better ways, but it works. For now, let's just type in here Mickey Mouse, click OK, and no surprise, if I look at the sheet, Mickey Mouse's name is in B3. Okay, let's delete that. Then pop back to the code window. I just want to quickly demonstrate it without default there, because I personally would not have bothered with that if I was doing this for real. But I wanted to show an example of what it does, and I'll play that. And I'm sure you could expect this coming, but I just wanted to show that it would show blank and your cursor would be flashing there as the alternative. I can now type in Minnie Mouse. Gives me an opportunity not to leave her out. She'll not be happy with me. And no surprise, but I've got to check it. Minnie Mouse is in there. Brilliant. Back to the code. Okay, so this is great. Now you might have noticed though that there were OK cancel buttons within that input box. And hopefully you did, because I was clicking OK. But what if the user clicked cancel? We should, include some code to cater for that really. And we spoke about error handling on this course, so we can put in error handling as a scenario, as a way around that. But what I wanted to demonstrate is the way the input box is at the moment. If somebody hits cancel, it should bring back an empty string. And rather than assign it immediately to the range, we should maybe assign to a variable first so that we can test it. So what I'm going to do is I'm going to change, well, first of all I should create a variable. So dim name entered as string. And then I'm going to change this range b3.value to name entered. So I've got a variable called name entered that captures string entries, and name entered is assigned it by the input box. Okay, so now let's test it. If name entered equals, and I'm going to ask if it equals empty. Because if the user clicks cancel, then the string will be empty. If name entered equals nothing, then display a message box to the user saying you did not enter a name. And then I'm going to put a title, no name. So just reminding ourselves different ways that we can write these message boxes and input boxes, different ways we write the code. Else we want to assign to b3 dot value equals name entered, and if. Okay, let's give this a go. So what I want to do is use my F8 key to step through this. I want to demonstrate what happens here. So when I press F8, in it goes. I can see name entered immediately at the bottom is an empty string. So it comes in, it displays the message to us, the input box. I cancel the box, and the string remains empty. So then it performs the test, displays a message to me, and just continues on its way doing nothing. So that's just an example of how we could test. As we've seen in previous lessons on error handling, there are multiple ways I could perform tests and deal with these examples, and they will differ depending on how I'm going about it. But that's a typical example there where we use input boxes to capture text. If the user hits cancel, there is no text. Therefore, it provides a simple way of us testing what is in there. Right, I'm going to comment out some of this code, and what I want to do is show another example of the use of input boxes. So I'll just comment this because I'll leave this at the end for download, this code. What we're going to look at next is on this sheet we have this example of a kind of currency conversion where I want to convert pounds into US dollars. So we're going to have a formula in cell C6. Now what this is an example of is using the input box method as opposed to the input box function. They look slightly different. They're extremely similar because they're both input boxes, but slightly different. And what the input box method will allow us to do is validate the type of data, which a general input box function we've been using so far, which is far more common, I should say, does not give us a potential to do that. If I just quickly put an input box back in for a moment, this, right at the end of the questions, they say as string. So everything gets captured as a string. What we're going to do instead here is I want to put range, I can't remember what it is. I'm going to put C7 in there, and I'm just going to check that. What have we got? C6. I've not got the greatest memory in the world. C6, range C6.value equals range must be B6.value. So B6 is where the pounds is at the moment. There's 10 pounds written in there. Great British pound. Got some sterling in there. C6 is where we want the US dollar conversion to be. So what I'm going to do is multiply that by whatever the user types in. So because exchange rates change quite frequently, it's just a simple little example. I want a user to type in the rate. Yeah, it might not even be US dollars, whatever it is, and it will perform this formula for them. Right, so we need a input box, but I'm going to put application.inputBox. So instead of using the input box function, I've used the input box method of the application object. And notice the slight differences. Prompt has string. Didn't say that before, just said prompt. It said has string on the end, which it doesn't anymore. And I've got this extra argument called type. So what I'm going to do here is I'm going to answer this prompt. So in speech marks I'm going to say please enter the exchange rate. And then let me follow that onto another line. Space underscore, a line continuation character. There it is. And then I'm going to put a comma to move out of that. And I'm going to write type. So I'm kind of mixing up the ways that I write this. But rather than putting a load of commas, I want to use the type argument. And there are, I think, 8 or 9 different types of data we can capture in the input box. Now I'm going to provide a little table of these within the lesson. So you can see this. What I want to do is capture number, which is number 1. So I'm going to ensure that it equals number 1. So this is going to validate the type of data. So I'm going to put a closing bracket. It seems quite happy with that. And I'm going to run this code. So when it runs, this is the input box method. So it looks slightly different to how it was. You know, the OK cancel buttons are up here, now they're down here. Looks a little bit different. But we've still got our title. And we've got this prompt. And now I can type in like 1.6 for example, which I believe is the exchange rate for US dollars from pounds. So that should display about £16. I'll click OK. And if I check this out, I've got $16 there. I said £16, no, $16, obviously. $16. So it even brings it in this accounting format, which I did in Excel beforehand. Really, that wasn't the input box that did that. That was me formatting cells. But if I delete that for a moment and go back here, if I play this again, the brilliance of this is that if I typed in Alan, if I typed in my name, this exchange rate my name, it will say no, that number is not valid. So that is that type argument. We cannot do that with our input box function. You could do it by creating other if statements and testing it, but this with the input box method is built in. And some of the other options, which I won't worry about demonstrating now, are to capture cell references and Boolean values as well. So it can be very useful. And string values, you can probably guess. So it can be very, very useful. Here we're using it to capture numbers, and it is providing a degree of validation for me. Say, look, that is not a number. But if I type in 1.6, it should now be happy to go ahead again for me and perform the formula. Which, because I've got a formula there, is obviously ultra important that it is numeric data as well. So really, really useful type argument that you get with the input box method. So we saw a couple of examples of the input box there, allowing us to capture kind of typed data from a user, whereas message boxes in the previous lesson are there to provide buttons and capture user selection in that way. Two ways of interacting with a user. Next up, we're going to look at something you'll be very familiar with from using Excel, or computers in general really, which is using dialog boxes, existing Excel dialog boxes in our user interaction. Hello and welcome to the last lesson on interacting with a user, where we look at using some of the built-in dialog boxes of Excel. So you're going to be very familiar with these dialog boxes. You know, you use them to open files, select folders, save spreadsheets. And the one we want to use in this example is that last one, that save as dialog box. And we want to bring it up using our VBA code. Now, as a simple example, I've got a spreadsheet here with 3 sheets. Imagine that these are expenses for 3 different stores. And I want to be able to click a button and see that, like, export the active sheets data, so in this case Plymouth's expenses, into a new file. So essentially I'm just going to copy and paste the data on whatever sheet is selected into a brand new workbook and trigger the save as dialog box so that it gets saved for the user. Now if I pop into the VBA code, some of this is already done for us. I don't want to go completely from scratch. So I've got a variable for a new workbook, a variable to store the name of the file that the user would like to call the new file that's generated, a name for the sheet in that file, and an object, a range object as well. So the first thing we do is the range object, RNG, is assigned the current region. So whatever the current sheet is, which is Plymouth, the current region, the address of that is assigned to the RNG variable. And the sheet name variable is given the name of the current sheet, i.e. Plymouth. The new book is then created and is assigned the variable new book, so we can reference it as new book from now on. And just either side is a useful little nugget of code. I wanted the new workbook to only have 1 sheet. You know, the default for new Excel spreadsheets up to 2013 is to have 3 sheets. So I've changed the application property there to have 1 sheet, create a new book, and switched it back to 3. So our new book will only have 1 sheet. That sheet's name is then given the name Plymouth, and a copy and paste operation is done rng.copy, and in the destination is that first sheet, which before I called it Plymouth, I've managed to reference as sheet 1. I know it will be called sheet 1 because it's a new book, and A1. Now after this, now the copy and paste operation is done, we want to trigger the Save As dialog box so that a user can choose a file name, choose a saving location, and then the macro can take it from there to save and close. So I'm going to use this in a with construct. I think it's been a while since we used a with construct, so let's get one going here. And we're going to say with application.fileDialog. Really good thing to know, this application.fileDialog. And as soon as I put an opening bracket, it will list the different file dialogues I can have. File picker, folder picker, open, and save as. 4 dialog boxes you will be more than familiar with, from opening and saving files to adding attachments to emails. Now the various things we do day to day and come across these. We are going for the Save As dialog box. MSO file dialog save as. Closing bracket. Enter, enter, end with. So we've got this with construct so that I don't have to keep on saying application.fileDialog MSO file dialog save as. You know, I can now reel off the things I want to do with this dialog box. So we can do, with a full stop, up come the properties and methods. I could have title, like we've just been doing with the message boxes and input boxes. Equals, let's give it a title. I'll call it please save the export. Trying to think what to call it. Done. What else do we want to do? We want to display the dialog box, which is actually .show. So show is a method of that. Okay, what else do we need to do? It's shown, it has a title. We need to capture what the user selects. So I'm going to put and whatever the user selects as well, wherever the user uses, we need to assign to the file name variable. So where are we? Is that file name variable? It's a string variable. It's going to have the name of the file, which will include the path with the save as dialog box. So I'm going to say file name equals, then we're going to have dot selected items. Dot selected items, and I'm going to put 1. So it asks for its index. What item? 1. Seems a bit of a silly question maybe in this example, but you know, when you're kind of selecting files, like adding attachments to emails, you can sort of select more than one at a given time, and that's what that kind of property is there for. Okay, so file name equals whatever the user selected. So the file name they typed and the location they chose. Now what we should cater for is the eventuality that the user didn't select anything. Maybe they left the file name blank. Maybe they clicked the close button, or the, you know, to close down that dialog box. So let's wrap that inside an if statement. Let's have a condition. Let's have a bit of space as well. If dot selected items, just tab that and finish it off. No, I don't want that. I want to say dot count. If the number of items they selected, well, maybe twice in this course so far, we have relied on the count property. It's such a useful property. Nearly anything in VBA you can put a dot count to. How many did they select? How many files are open? So useful. If dot selected items dot count equals 0, then you haven't done anything. So then let's have some then clauses. MSG box. A file name was not entered. And then we should have, well, we want to close down the file. We've just created this new book. I don't want to just exit at that point. We need to close down that file, don't save anything, and then exit the macro. So almost pretend this never happened. I'm going to say, what is it called? It's called new book. New book dot close. Close the book. Save changes. Save changes. Changes. False. Do not save the changes. And after that, we're going to have exit sub. Come out of the macro. Else, so if they did select something, get that file name assigned. End if. I nearly put end with there, but we've already done that. So with the file dialog box, assign a title, display it. The user will be doing what they do at this point. If they didn't select anything, tell them what's going on, shut it all down without saving and exit the macro. If they have selected something, capture that file name. And then outside of that, we can say new book dot save as, and the file name is going to be file name. Can you believe that? The file name is going to be file name. How weird does that look? Maybe I should have chose a different variable. New book dot close. Okay, so this looks the part. Hopefully you agree. The main thing in this macro is to see this file dialog box. That's really what we're interested in here. I'm trying to cover as much code, some new code, and recap an existing code, like current region, as much as we can in this course. So we saw this little nugget, which is useful, and we're creating a new book and that here. But seeing a dialog box and knowing that there are others, like opening files and that we can use here, really, really useful. I mean, how commonly do you use file dialogues anyway? Right, let's check this out. So let's restore this a little bit. Here we go. So I've got the Plymouth sheet in the background. And let's start F8ing through our code. So when it comes, variables assigned. The range is there. Sheet name, I can see Plymouth down the bottom here in the locals window. And on it trots. Create the book. I can see the book is created. We can see it in the Project Explorer, book 4. And that's assigned, ranges, copy and pasted. We can see it in the background, the range is pasted. Oh, looking at that, maybe I should have done an auto fit on them columns. Never mind, the job is done now. I'll leave that to you guys. Not new in this course, that. Right, let's assign the sheet name. Now I can see Plymouth at the bottom here on the sheet name. Here we go, into the dialog box. Title assigned, show the dialog box. Oh yes, look at all this joy. Look at all this stuff. Let's put it on this wreck of a desktop I have and save the file name as export. Really can't think of a decent name at the moment. And let's save that. Oh, there's my please save the export title at the top there. Let's save that. That comes back into here. F8. I have done something, so the file name is assigned. See the file name at the bottom there? C:\users trainee1 desktop export.xlsx. So in it goes, performs the save. So now, if I can drag that down a little bit, we can see export.xlsx at the top there. Performs the close of that book. It's closed. I'm back into dialogboxes.xlsm and sub. Looked like it worked well. So that is us looking at dialog boxes. The save as dialog box used there to show interacting with the user so they can choose the specifics like the location and the name, but the rest of the code all automated, taking care of it to perform the save, perform the close, perform the copy and paste. So that is the last video of this section on interacting with a user, but I say that, you know, in our next couple of sections we're going to be looking at working with files and folders. So we're not done with dialog boxes yet really, as we loop through all the files in a directory and that. And we've also got a section on user forms to come, which is absolutely awesome with interacting with a user, because you're effectively creating your own forms and your own dialog boxes, customized tailored forms, which can then allow interacting with a user, getting them to choose options in a form of your own and running code from it. So in a way we are not even close to done, but we are finished in this section if we're going to talk about built-in ways of interacting with our users. Hello and welcome to this lesson on looping through all the files of a folder. So we want to start looking at working with files and folders in VBA, and probably the most common thing you're going to need to do is perform an action on every file within a folder or directory. So that's what we're going to do here. And as an example, I want to copy and paste the data from each file within a folder into one workbook. So I'll end up with one sheet with a big list consolidated from the data from multiple different files. In this case I have 3 files stored in a folder on my desktop. Now I will provide a workbook with all this information that's on screen in there for download, for kind of following through, but in this video I'm actually storing this code in my personal macro workbook. So we haven't spoke about that for a long while on this course, and I thought I'd bring it back as an example. So in my Excel at the moment, I do not have a workbook open. Let me switch to it. No workbook open at the moment. But I'm still able to access the code as in the personal macro workbook. Now if you go to your editor and you do not see your personal macro workbook on the left hand side like I do, then it's not been kind of initiated yet. And for the personal macro workbook to exist, you have to use it at first time. It's a hidden workbook, but it doesn't even exist until it's used for the first time. So popping back to my Excel again, what you would initially do is just have maybe a blank new workbook, or any workbook would do, and start to record a macro. This macro can do whatever you want. You can just click somewhere that will do and stop the recording. And it doesn't matter what its name is or anything like this. The sole purpose we are using this is to store it in the personal macro workbook so that it gets created that first time. So you'd do that, you'd click OK, you'd do something like just click somewhere, and then you'd stop the recording. And that would be enough to trigger that personal macro workbook. So that I can see I now have a module 2, because I've already got this module working with my brilliant cell selection there. So this is all irrelevant. You can get rid of all this junk and get rid of that module, but it will create your personal macro workbook for that first time you use it. No, I don't want to export it. Okay, back to our macro. I've taken a few steps here to save us time and stop repetition and all this nonsense, and I've created 4 variables. Also gone to the extent of putting some comments in. so that I've got a string variable to store the name of each file that we loop through within the folder. I've also got a string variable to store the directory, like where that folder is. I've got another string variable which I've called first file, which is used for a test further down, which maybe we'll get to when we get there. But it's all about the header inclusion. So I'm putting it on one sheet. For the first file, I'm copying and pasting everything, including headers. And then for any more apart from that first one, no header inclusion. So this is used for a test. Are you the first one? Yes, you are. Bring the headers in. No, you're not. Don't bother then. And now I've got WBK, our workbook, which is the workbook that the data is added to. I don't want to have to be referencing it by its name each time, although I have a variable to use that. So I've got a variable for nice, easy reference to that workbook. Okay, so the first thing in our list is a recap, really, on the previous lesson. Because what we want to do is the user to specify the file directory. And I thought the best way a user could specify it is using a folder picker dialog box. So, we put it underneath these comments, and in a with construct, like I did in the previous video when we looked at the save as dialog box, we're going to use the file dialog of the application object, and I'm going to use the MSO file dialog folder picker one, so the user can select a folder that they want to loop within. Let's put my end with in, and we'll start to do similar stuff, say, to the previous lesson. We'll display a title for it. So the title will be, please select a folder. Now, something new that we're going to do this time is I'm going to use the allow multi-select, the first property in that IntelliSense list there. And I'm going to use this to say false. No, they cannot select multiple items. They can only select one folder in this example. But how awesome a macro is it if you're looping through multiple folders as well? The repetition there is extreme, and what an example of a macro and what they can do to save you time. Okay, we've got to show that dialog box, don't we? So .show, and then we'll have that test where I want to make sure that the user didn't just cancel this box, they have done something with it. So if I've just completely forgot what it's called. Is it selected items? There we go. Oh, just nearly skipped my memory here. Dot count. How many items have they selected? Multi-select is off, so it's going to have to be 1 or 0. I want to ask, does it equal 0? If it did, tell them that they did not select a folder, and then exit the subroutine. Else, capture the name of the folder they selected in our variable called file directory. Select, you've got to spell all these correctly. Selected items, the first one. Yes, that's all I need. And I'm going to concatenate. I think we've concatenated for a while. Or have we? Maybe it was quite recent. File directory equals the directory they have selected. And I'm going to concatenate a string onto that. I'm going to concatenate the backslash. When selecting directories, you know, and later in this macro, we're going to concatenate the file name onto the end of that to get a full path. But you know, when I select a folder through this folder picker dialog box, it does not bring that backslash, which should be situated in between the folder name and file name. So we're going to concatenate on ourselves, and I better make sure I put in my end if there. And maybe a bit of space for clarity. So, folder picker dialog box. the user will select the folder they want, and that will be captured in the file directory folder along with the /folder path. So I've outlined these comments here to make life easier for both you and me, really, with tracking what we're doing at each point. And after that, a new workbook has been created and assigned to a variable for WBK. So this is the one we'll be dumping the file information into. I need to retrieve the name of the first file in that directory. And the way we're going to use this is going to use a VBA function called dir, which I believe stands for directory. Now this brilliant function will go in and retrieve the name of the files from a directory. If you use the dir function and you specified our directory to look within, and we're going to specify file directory, the variable, it will grab the first file name from that list. From then on, if you call the directory function, the dir function, and you do not specify any directory, its job is to get the next file in that folder, which is going to be fantastic for us for our loop. So first of all, I do want the first file name. I'm going to store that in a variable called file name. So I'm going to say file name equals dir opening bracket. Now notice this dir function asks me, can you give me the path name? And it's optional, because next time we use this, we are not going to use it, because as I say, if you do not specify it, it gets the next file name. Then it asks for attributes, so you can specify, kind of read-only files and kind of system files and stuff like this. Also optional, and in this example, we don't care for. File directory, though, is where it needs to look. And what I'm going to do next up is then assign that file name to my first file. So because this is the name of the first file, I'm also going to assign a name to a variable called first file. So within the loop I can do that check and go, are they equal to each other? If it's the first time you're running, yes they will be, and include headings. If not, don't. So let's scroll down where I have this kind of stuff. Need to create a loop for the files of the folder. We're going for a do loop. We need a way of exiting this, and we can get away with a few different scenarios really. We could use a for loop and use a count for how many files there are and run it for that. I was going to use a do loop, so I was going to say do until, and I was going to say file name, because that's going to be the name of the files that dir will retrieve and pass to as we look through. I'm going to ask if it's equal to an empty string, because when the dir function runs out of file names, it will return an empty string. So if I say do until this, I know when they have run out of file names. Okay, I'm going to move down this list, where I then have to put my end of my loop, which I'm going to put here. So I'm going to put loop. So I've got this message box for the end. All store totals have been added, because in this example, each spreadsheet has some fictional store totals. Each spreadsheet actually has the exact same data in, as it's just an example here. We're not too concerned with it all being different. But that's the scenario. 3 different stores, add all the totals in one list. Okay, got the loop there. Looking back to the comment at the top here, after looping, first thing, open the first file. Okay. So before we do some copy and pasting, it's got to be open. So we're going to say workbooks, because this file is a workbook, dot open. I guess a fairly obvious method there that we were going to use. And then I'm going to need to specify information to it. Loads of information you could potentially specify. Delimiter characters in there and passwords and stuff. All I want is the name of the file, which is the mandatory one, as you can imagine. And I'm going to ask for it to be... no, I don't need that. What am I doing? File directory concatenated with file name. So the full file path will be the directory, the name of the folder, C:\/ blah 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 desktop / I think I called it Excel files / the one we put in, name of the file, comment what it is. Might be Chester. Let's find out. Right, that's open. Now we do the test. Are you the first file in the list? If so, copy and paste it from cell A1, using the cells object there. So it includes the headings and everything else. Yeah, using special cells there to get the end of the list. We saw a few different techniques quite early in this course for copying and pasting and how we can do it. I've gone for a 2-line technique there. Otherwise, go from row 2 so that you exclude the headings. And I'll also need to do things like offset 1 cell down, because you'll be adding it to the bottom of an existing list. Whereas at this point, you're the first one, so go from A1. Lots of cool stuff there. Right, before we end the loop, got to save and close the file. Got to get the next file name. Let's throw in that next file name first. While it's relatively fresh, we're going to say file name, the name of a variable that will use it, equals dir. And that is it. No specifying directories this time, because when you just write dir, you'll get the next file name. Pass it to file name, loop back round. Are you empty? No. Okay, in that case, open it up, do a copy paste operation. This one, second time round, get the next file name. Round we go. Are you empty? No, you're not. In we go. And so on until it is. Okay, before that, let's save and close the file. Workbooks dot... Actually, specify workbook. Open in bracket. What workbook? We're gonna... The workbook called file name. Closing bracket. Dot close. Do I want to save changes? Yeah, that sounds like a cracking idea. Save changes. True. Yes, could you please save the changes to it? Actually, I'll say that. I'm just copy and pasting out of it. I don't really need the changes, do I? Let's go for that anyway. Let's have a bit of saving. It's a good thing to demonstrate, even if not necessary. Right, I think we are done. So, as a quick recap here, we've got the folder picker dialog box. A good recap on the previous lesson there. For a user to select a file directory, it's then captured in this variable. A workbook was added. The dir function is used with a path name to get the first file name. That file is opened within this do until loop. Run out of directories, and then some things happen. Then things can be whatever you need. Here, we're copy and pasting code. That is then saved and closed, that file, and the next file name is retrieved. And around we go to loop through every file within that folder or directory. So, if I was to give this a go, let's F8 through this code. So in we go. Dialog box, folder picker dialog box, dot show. So I'm going to jump to my desktop where I have stored this folder. I will send these files to you, but it will work with any... I call it store sales, that's what I call it. It will work with any files. So I don't know how relevant that will be for me to do. And even if I do so, make sure that you put it in a folder and you put that folder somewhere. Apologies on I'm saying something silly here, but that's what this macro does. If you want to test it out, get that done. Do it with any file. It doesn't have to be the ones I provide. Make them up. Mix it up. Make sure it works. There's my title at the top there. Right, directory specified. Let's turn on this locals window. Locals. Love the locals window. Okay. Through we go. I have chose something. So it will concatenate. There we go. C:\users trainee1 desktop store totals \. Creates a workbook. See the workbook variable liven up. I can also see the workbook appear in my Project Explorer there, book 3. File name captured. The first file name is Cambridge.xlsx. There's the dir function grabbing the name of the first file. Now it does not open that file or anything, it just gets its name. You will then do things to it. Immediately moves it into this other variable, so they are the same for the first time we go through and enter the loop. Open it up. Done. I can see it appear on the left. The Cambridge file is open. Are they the same? Yes, they are. So it goes and does that first copy and paste operation. Saves and closes the file. Cambridge disappears. Grabs the next file name. Chester. You can see it's different to first file now. Loops back round. Goes inside. Opens it up. Chester is open. Are you the same? No. So it jumps to the next bit. Awesome. Saves and close. Next file name. It's Hungerford. Next up. In we go. Through we go. Grab the next file name once it's closed. Next file name is an empty string. I only have 3 files in this folder. Empty string. We're going to be exiting this time. Do until file name is empty. Out we come. Message box. Brilliant. All store totals have been added. Let's get back to our spreadsheet. And here it is. 6,000 and something rows it will be, because each file has the same, I think, 2155 rows of data. And there it is, a big concatenated list in a file called book 3. Following on our previous lesson, I could have gone and kind of saved this file, but I've got an example of saving later in this course, 2 videos time, 2 lessons time, but the user can always take that step now. You know, at some point we'll draw the line in this level of automation. So here we've got our first lesson of working with files and folders. I'm planning on doing a few different examples as we get through these more complex ones maybe, but this is performing a loop on every file within a folder.
Hello and welcome to this lesson, and in this lesson we're going to look at how we can create folders or create directories on the fly during the running of a procedure. We're also going to cover how we can export worksheets or files as a PDF. And the ultimate goal here is that we want to save each one of these 6 worksheets, so every sheet within a book, as a separate PDF into its own folder. A folder that does not currently exist, so we're going to have to create it during the procedure. And we're going to get the user to specify the name of that folder for us. So let's dive into our VBA without further ado. And just as the previous lessons, we have a little bit written out for us already. I have 3 variables, one for the name of the folder that the user will specify, one for the path of the folder. Now for that one, we're just going to put that in as a constant. We're going to type that into our code. So that will be the same every time in this example. And I'm just going to use the desktop for this example, but you know, back at your workplace, you're more likely going to use a shared drive or some kind for this sort of stuff. Just bear in mind that in the previous 2 lessons, we did look at how we can use the folder picker dialog box to get a user to specify a folder. So there would be nothing too difficult about including that in here as well. I'm just opting against it because we've kind of done that a couple of times already. I is going to be our loop through a sheet. Integer, so for I equals 1 to the rest of the worksheets, do this. So we're going to have our export to PDF in the middle here, so we can do it for every sheet in the book. A little message box at the end so the user knows, because they won't see this kind of stuff happening. Okay, so first off, we need to get the name of the folder. A folder that doesn't exist, but we want the user to specify. What I thought we'd do is use that input box. So I'm going to put folder name, the name of our variable, our string variable, equals input box, and I'll put a prompt. Please enter a name for the folder. And I'll put a comma and I'll put a title as well. Enter folder name. So the input box, something we've covered on a previous lesson, good for capturing kind of entered data from a user. We're going to use it to capture the name of a folder. A classic example of an input box use. Now also, as we saw earlier, if somebody just cancels that input box and doesn't actually put a name in there, then we're going to get an empty string returned. So what I want to do is I want to test that the user did not do that. So I'm going to ask, if folder name equals an empty string, then they haven't done anything about this. So what we're going to do is display a message box to the user. Say you did not enter a name for the folder, and then exit the subroutine. So if they haven't put a name, that's the end of that really. We need to abort the macro. Okay, so we've captured the name of the folder at this point. Now we need this folder path, which I said we're going to use a constant file. We're just going to type that in right now, the path to, or what will be to my desktop, but if you're shared drive or whatnot. And you can copy that from Windows Explorer, or use the folder picker we used earlier. I'm just going to assign a string for mine. It's going to be C:\users \trainee1, which is my username, \desktop, and I'm going to concatenate onto the end of that folder name, the name of the folder that we literally just captured. I believe that to be correct. Let's hope I don't have a typo in there. So now I've got that, the next step is to make that directory. So the directory doesn't exist yet, so we're going to use a brilliant function called mkdir, make directory. That will just ask us for the folder path as a string, which we have a variable called folder path, which I can use. So create the directory that I have kind of specified up here. That doesn't exist. Well, that bit does, but this bit doesn't exist. So create that for me. So now it does exist. And the next part of our project here is within our worksheet loop. We need to export each sheet as a PDF. So I need to specify each sheet to start with. So I'm going to put worksheets I closing bracket. So something we did earlier when we were kind of looping through these for each next loops, and these for next loops. So I'm using I as an integer, a kind of counter loop, if you will, a collection loop through this. I'm going to say worksheet I. What am I going to put? I'm going to put dot export as fixed format. A tool to export each sheet individually and as a specified format. So when I press spacebar, we're going to have to start putting in some information now. Export as fixed format. And the first format is going to be type. Now the type we want is going to be an Excel type PDF. Now you can always kind of find this stuff out, but different types of data we can export, different formats. We're going for a PDF. Type is Excel type PDF. Comma. Okay, another bit of information I want to provide is going to be the file name. Now I need to provide the full path here. So the full path is going to be folder path, and concatenated to that will be a backslash. And concatenated to that, I was going to use the name of the worksheet. So each worksheet's got a name of the kind of office or store in this example that we're exporting as a report. I want to access that information. First of all, I'm going to put in a line continuation character. because it looks like I'm about to run out of space there. And I'm going to put worksheets. I've got to type that right. I.name. So use the name of each worksheet. So the full folder path, as specified up here. Don't put a backslash because that's not mentioned. And then the name of the sheet. That is the full path to save it as, including the name of the file. Okay, I'm going to put a comma. There's one more argument I want to complete here, which is going to be open after publish. So if you ever saved as PDF before, you get asked that question about whether you want to open it after publish, and I think most people normally say yes. In this case, we're going to say false. I don't want all of these 6 sheets open by the end of it. Once you've created the file, can you close it down for me? Okay, it seems to be happy with that. So I pressed enter, which is good. So start to type out these extras, so do get a little bit concerned. Especially things that you don't do so often. You know, these kind of loops for each next loops and these if statements you're going to do regularly. Stuff like this, well, depending on what you're using your procedures for, but probably not so much. So you may need to consult a book or consult this video each time. There's no shame in that. Exactly the same as owning a dictionary at home. There's no shame in that. Nobody could possibly know everything and remember everything, most importantly. But that has now exported these as a PDF. So I think the next logical step is to give this a try. So, just having a quick once over on it. I'm going to go for my play button at the top. I always call it the play button. Run sub-user form. And that will ask me, what would you like to call the folder? I'm going to call it Office Sales. I'll put a space in there, I haven't, have I? Let's put a space in there. Office Sales. Let's click OK. Oh, ask me where the heck my printer is. I'm not connected. Let's choose a fax machine. Obviously choose a correct printer at that point, please. And I can see it kind of running through some bits now. All PDFs have been saved. That is good news, seeing that. But we should check this out, really, shouldn't we? Let's open up Windows Explorer. Let's go to my desktop. Office Sales, was it called? Look at the state of this. Office Sales. I've got a folder called Office Sales. Oh, yes. 6 individual PDFs. Let's pop one of them open. Portsmouth.pdf. The name of the sheet. Oh, that looks awesome. So we have our 6 PDFs open. That seems to have worked a dream. But let's try and run it again. Let's try and run sub-user form. And I'm going to specify Office Sales again. And just want to check that is one space there. Okay, yeah, it is. And now I've got an error, a runtime error. Can't access it. That folder already exists. So working on the idea that you may do this export on a kind of monthly basis or weekly basis, somebody may have already done it before you. So we want to put in an error handler to check that the folder doesn't already exist before we run it. Now, as you might have guessed, I'm trying to use this folder as well to recap on quite a few things that we've done throughout this course. Now, we're coming to the closing sections now, just a few more to go. And we're seeing the input box, we're seeing error handlers, and hopefully getting quite proficient at it. We've got a runtime error 75. I have that runtime error number. So, don't know why I'm hitting debug there. The plan is that we know the issue is creating this directory. And in fact, when I did hit debug, it highlighted that. I don't know if you took note. So, just before that, I'm going to put on error handler, go to the error handler. Getting ahead of myself. So I'm going to call this, hopefully you've looked at the error handling part of this course. I'm going to go to the error handler section on error. And straight after make directory, I'm going to say on error, go to 0 to disable that error handler. And I'm going to shoot to the bottom of my file, stick in an exit sub before I create the error handler, because I wouldn't want this error handler to always run after message box. That would kind of come out of that. And afterwards we're going to create it. So error handler colon, spell these things correctly. And then we'll create the error handler. I was going to say, if dot number equals 75, then, so that was runtime error 75. If the error you receive is number 75, then that folder already exists. So MSG box, that folder already exists. Exists. Please try a different folder name. Let's go for that kind of description. And then we're going to exit sub. You know, I could re-divert them back to the input box to type one in, but let's exit the sub because I don't want this continuous loop that they get kind of like stuck in. You know, they might not want to run it again. They might have to consult something first. So let's abort the macro. They can come back to it easily enough. Right, let's give this a run. F5 could do that too. Office sales, nearly forgot what I called it then. Office sales, let's OK that. That folder already exists. Brilliant. So here we have a procedure that will create a folder on the fly during a procedure. We've also put in an error handler there as a way of checking that that folder must already exist and kind of taking the course of action about it, in this case exiting the procedure. But I've also looked at exporting worksheets in this example as another format, and I've opted for a PDF format for its brilliance in kind of distribution and publishing online, that anybody can open it and it's read only. But you know, I can't create a folder for every single instance, that would be crazy. But adapt these, that this could be the whole workbook, it could be a selected range that you're exporting. You know, and the type could be a text file. You know, once you've got the nuts and bolts of this, we can adapt them to our needs. Hello and welcome to this lesson where we have a look at creating a two-dimensional fixed array. So arrays can handle more than one dimension. I believe I'm right in saying they can handle as many as 60 dimensions. So they can handle an awful lot. We're just going to go for the 2 here, but it's a good expansion on our previous video. And you can see on my spreadsheet at the moment that I have the list of month names like the previous video, but I've also got these, what I'm pretending to be expenses, but I've got these values, these currency values. And I want to store all of that information in an array. So I have more than one column here, or kind of more than one dimension. Each dimension having multiple elements, to use their terms. Now if I switch to the Visual Basic Editor with our Alt and F11 there, I've created this sub-procedure already called monthly expenses, and I've just copied and pasted across the for loop from the previous lesson. It's exactly as it was in the previous lesson, where it creates worksheets and uses like the name of the array index number, which doesn't exist in this procedure at the moment, but I've just pasted it along for us to have a look at afterwards. But before we get to that, let's move that down a bit. We're going to look at how to create a two-dimensional array. And this array is going to handle string values, because the first column is names and months, they're string. But in the second dimension, or the second column, we have currency values. So we've got a little bit of a difference here. This array is handling both. So what I'm going to do is I'm going to say dim, and I'm going to call it monthly expenses, and then I'm going to put an opening bracket, and I'm going to say 1 to 12. So this is the first dimension, that's the months. There are 12 of them, it's fixed, 1 to 12, comma, and in the next dimension.
which is 1 to 2. There's 12 there. It's 2 columns wide. There's 1 for the months, 1 for the currencies. It's 12 high, 2 wide. That's what I'm saying there. Closing bracket, and I'm going to put as variant. So here I've declared a fixed 2-dimensional array. 12 rows high, 2 columns wide. I keep saying rows, columns. That's not really what it means. But it is 12 in height and 2 wide in this 2-dimensional idea. Okay, I'm going to declare 2 other variables at this point. I'm going to declare a variable which I'm going to call row num, and I'm going to make a byte, and I'm going to declare another one called col num, which I'm also going to make a byte. And what I'm going to use these for is for when we populate this array. I'm going to use these for the loops for this and for this. So that's what I'm going to use them for. And I've referred to them as row and column because when I start accessing them from the sheet, in my head it makes it easier for me to keep track of what I'm doing when working with larger arrays. You can obviously use whatever variable names you want, as we know from what we've been doing throughout this course, really. And what we need to look at doing now is populating this 2-dimensional array. And it's not a great deal different to what we've done in that previous lesson. The major difference is that we're going to have this interior-exterior loop. Because we've got to loop through every single month, but we're going to have to loop through that row, if you will, because we've got 2 different elements for each month. We've got its name and its currency, its expense. So I'm going to say for row num equals 1 to 12. Next row num. So just like I did in the previous video with I, we can actually see down below with I there. And inside that I'm going to say for col num equals 1 to 2. Next col num. And in the middle there, so we've got this interior-exterior loop. It's going to loop 12 times, and for each 12, it's going to loop 2 times to populate this full array. In the middle there, we've got to do the population. So I'm going to see monthly expenses, the name of this array, row num, comma col num, so the first element of its height and the kind of first element of its width, closing bracket, so 1, 1 in this first example, 1, 2 in the second example, and then 2, 1, 2, 2, 3, 1, 3, 2, and so on as it moves across and also down. It equals cells, row num, col num. Now obviously bear in mind that you can access data from any cell in a spreadsheet, or it may be from a form control or a message box or an input box. I know an easy solution may be using the cells object because our index is exactly the same, but it helps us get to grips with what these arrays are doing. That's my why I'm doing this. Now what I want to do really is I'm going to actually just comment this stuff out temporarily. I'm going to come back on that, and I want to just demonstrate this, building this array first. I want to put in the locals window so we can track it, make that a bit bigger, and then we're going to use the F8 key, maybe not that big, the F8 key to move through this. So here we can see the row num, col num entries. And if I expand this array, here we go. Got 12 elements down, 2 elements across. If I press my plus sign here, and maybe let's do this one as well. Here we go. 1, 1, 1, 2, 2, 1, 2, 2. And as I F8 through, we can see it building this up. In goes January, loops around this interior loop. In goes its expense. Back round. Now we're into 2.1. And we can see it as it moves through populating this array. You can also see over here that we've got string currency data types. Or they're being stored as a variant because of what I told it to do. And that is us building a two-dimensional array. You can have more, they can be larger, but that is our two-dimensional array. Now I'm going to close that locals window, reset that, and get rid of these comments. And the idea here is we're going to use that two-dimensional array and populate data on the spreadsheet. So I've got this loop from earlier with our simple one-dimensional array. Then I do need to change this to row num. So for row num 1 to 12, next row num, can you create 12 sheets essentially? So that I will have to be row num. And I don't actually have a sheets number at the moment or an SHT. So I should look at bringing them in here. Dim SHT as worksheet. Dim sheets number. Did I say sheets number or sheet? Sheets. As integer. And let's count how many sheets. Sheets number equals worksheets, or sheets I should say, dot count. Okay. Now the major difference here is obviously I've had to refer to row num, but I've also got information in the second element as well. So here I'm going to say that it's going to be row num, and I'm going to put comma 1, and that's called monthly expenses. Hope we're keeping track of this. I realise that I'm making quite a few changes here now. Here you go, monthly expenses. So we've got row num, comma 1. First one, first column. And then maybe, while we're in there, we're going to, in cell A1, populate it for a simple example with the contents of monthly expenses, row num, comma 2. That second element of it. Look at this lovely message box they give you. This local monthly expenses, 1 to 12, 1 to 2, as they let us know variant data types. Brilliant. We can have that, put in the value that you find within there. So the 1 and the 2 are static, but the row number will loop. That should put the relevant value within each cell. So, if I was to play this procedure, and then go and have a look at what we've got on our sheet. Let's try that again. I pressed the wrong one. Here we go. Just the one sheet in this book there was. As I look through, January's got the value in cell A1 and it's called January. February has that value in cell A1 and it's called February. And so on and so forth. It's not a mind-blowing example of why you would use an array there. But we've seen how we can declare a two-dimensional array, populate it, but then also reference it, also use it in some meaningful way, pick out the data that we need at that time, and write it to a cell, or write it to a sheet name, or whatever it is we need to do, test it in an if statement, and so on. In our next video, the last one of this array section, we're going to look at dynamic arrays. Hello and welcome to this lesson where we have a look at using dynamic arrays in Excel VBA. So we've had a look at using some fixed arrays. We've seen a one and multi-dimensional array so far. We're now going to look at a dynamic array. So the idea is that we do not know the size of the array at the moment of declaration. So it will need to be redimensioned during the course of the macro or the procedure. And this could happen multiple times, potentially, which makes it dynamic. So I'm just going to
begin by creating a procedure here. So I'm going to say sub dynamic arrays, no spaces in names, and declare a dynamic array, which I'm going to call sheet names, because our purpose is to store the number of sheets in a workbook. And this sheet at the moment, you can see in the Project Explorer here, has 4 sheets. But the idea being that I would not know that. I don't know at the moment this procedure is run how many sheets there are. Okay, so we're going to say dim sheet names, and then I'm just going to put the 2 parentheses after it, followed by the data type it is storing, which being sheet names is going to be a string. So the difference now against what we were doing earlier is that I have not specified the size of the array within these parentheses. However, by putting them parentheses, I have created an array variable. So dim sheet names and just the 2 brackets there, the 2 parentheses with no fixed dimension. And then what I'm going to do is declare another variable called I. Dim I as bytes. So like we've been doing in the previous tutorials, this I will be a counter through a loop when we look at populating this dynamic an array. So let's look at doing that. So we now want to specify the size of the array. So I didn't know how many at the moment of declaration, but I can find out how many now. And we're going to do that by counting how many sheets. So I'm going to put the words redim, short for redimension. This means that we can resize our array, and we can do it more than once throughout the course of a procedure. So I can say redim sheet names, opening parentheses, and I can say 1, 2 sheets.count. So by using something we've done a lot during this course, sheets.count there, we can count how many sheets, and we can use that as the size of our array. 1, 2, however many sheets there are, in this case 4. And then we can look at populating that array. So one way I could do this right now is I could write for I equals 1 to sheets.count. I know that will work. I know that I want to go from 1 to however many sheets there are. I can use sheets, sorry, another mistype there, sheets.count to figure that out. And I can use next I, or just next, and in the middle there populate this for loop, fill in the action area here to populate that array. So for example, we could have sheet names, opening bracket I, so the first index for the sheet names array, equals sheets I dot name. So equals the name of the sheet. So let's have a look at what we've got so far. I've got this locals window open at the bottom, ready to go here, which I might actually make a little bit larger, because it might get a bit short on space down there. And we're going to step through this procedure and watch what happens. So as we step through, the declaration of sheet names is made, a string, and then it gets redimensioned. And we can see here it's got 1 to 4 in the locals window for the size of that string array. And if I expand it, we've got 4 empty strings ready. Then it can enter this for loop and build up the string. So it populates it with the 4 sheet names, and we are done. So I've created a dynamic array. I don't know the size at the point of declaration, but we then resized it or redimensioned it using the names of the sheets. Now as we can see in the locals window, this is working fantastic. But I should mention, although there's nothing wrong with this for loop, that it's definitely worth a mention of 2 functions called L-bound and U-bound when working with arrays, and especially when working with dynamic arrays. So L bound is the lower limit. It's the lower limit of your array, and U bound is the upper limit of your array. So without knowing its size, we can specify the bottom as L bound and the top as U bound. As opposed to me saying 1, because I may not necessarily know that, and sheets.count, because that may not be as accessible, depending what you're using the array for. So, just to change my for loop here, I could say for I equals, and then say L bound sheet names. So the lower limit of sheet names to U bound sheet names. So it's just a simple change, which as mentioned is not necessary in this case, because I've already demonstrated it working. But this will work on the lower and upper limits of our array, and it's great because we don't necessarily need to know or access in difficult ways what the size of that may be. We're accessing Excel or the object model's knowledge of that already. Then it will go ahead and do its job. So if I loop through this again, the declaration, here we go, we've got 1 to 4, and if I expand that, the loop will continue to work. But using the L bound and U bound functions, which are really, really useful when working with dynamic arrays. Okay, so this looks like it's working fantastic, and that is a dynamic array. But let's look at the idea that we may need to resize it again. Maybe the size of the array is going to change, so we're going to need to redimension again. So after this, I'm going to put sheets.add. I'm going to imagine that as part of this procedure, there has become a need to change the number of sheets. And I'm adding a new sheet. So I'm also going to go as far as specifying will be at the end. And say after sheets. What am I doing? Sheets.count. So I want to put this at the end. So I'm going to specify that it gets put after however many sheets there currently are. So that line there will add a new sheet. And now we need to resize or redimension our array, because there's one more than what there was a moment ago. Now one approach to that is that we could say redim, and I now can just say sheet names 1 to sheets.count. Now I could do that. There's nothing wrong with that. That'll work absolutely fine. It's exactly the same as I have above. I'm going to completely resize it, and this bit will notice that there will be a 5th sheet by that point. Now let's have a look at that first of all. Let's step through this code. I want to see each bit of this before we enhance on it. So we're populating that again, and then there is the addition of the new sheet, and then it gets, and you can see the new sheet in the top left here in the Project Explorer, and then it gets redimensioned, and it now knows it's 1 to 5. Now notice when that gets redimensioned, that if I expand my array, it gets cleared. Now that in a lot of cases is a good thing. You may want that, but it's worth stressing that is what happens when you redimension an array. The existing values are cleared, so you have to repopulate it all over again, and we can do that using its exact for structure that we have earlier in this procedure. That will work an absolute dream. However, we're going to look at doing something different. What we're going to do is I'm going to take this stuff out, and I know that the line that adds a new sheet only adds 1 sheet. So I know that the size of it is only increased by 1. And I want to imagine that I also want to preserve the values that are already there. And the name has just kind of rolled off the tongue there. We're going to use the word preserve. Using the word preserve after our redim will preserve the existing values. So I'll keep the current 5 sheet names as it is now. And when the 6th sheet is added, that's the only one that I'll need to repopulate. So I'm going to say redim preserve, and then I'll say sheet names, opening bracket, and I'm going to say it's 1 to U-bound sheet names +1. Now hopefully that has made some sense, but what I've done is I've resized the array using the preserve keyword here to ensure that I do not lose its existing values, the current 5 sheet names. And for the size, I put from 1 to, what I've done is I've figured out what the current size of the sheet names array is, and I've added 1 on top because I know that only 1 sheet is added for this line of code. So that then, when I want to populate that, I can say sheet names U-bound sheet names do I have that right? I think I do. Equals, then I'm going to put sheets.count.name. Okay, I think I have that. So we've got the array sheet names, the uppermost of it. So rather than me keep track of however many there are at this point, and there will be 6 when this runs, but however many there are, the uppermost limit. So that's a bit like earlier on the index of I, but this time it's not so easy, so I'm finding it out. And I'm assigning the name of the last sheet. Because I know the new sheet's been put at the end, I'm assigning that to it. So sheets, whatever last sheet is, .name. So let's start stepping through this again. So the first bit we know, it will redimension, and there are 5 sheets now. Which if I expand, we'll then go into this loop to populate each of the 5 sheets' names. It then goes to add a new sheet, and we've got 6 sheets now. It will resize or redimension the array, and we can see in the locals window it changed from 1 to 6. So now 1 to 6 in our array. And if I expand that, we can see that it's preserved the existing values. So we've got sheet 1 down to 5 there, and then an empty string at the bottom. So that's the only one that hasn't been populated, which hopefully our next line will do. So then that next line populates at last 1. So we've resized the array, this dynamic array, preserving existing values, and then just like populated the, at this point, unpopulated ones, if that makes sense. So that has been us looking at dynamic arrays. I hope that all made complete sense. That's our last video on arrays on this course. You can have multiple dimensional dynamic arrays, but this is for us to experiment yourself really as you kind of go out there, or we'll be going on for forever at this stuff. But some very important concepts come out of this video: the L-bound and U-bound functions, redimensioning arrays, and preserve. Hello and welcome to this section of the course where we start to look at working with user forms. Now, user forms are a superb interactive element of using Excel VBA. We can create our own tailor-made kind of dialog boxes or message boxes, any kind of interactive form element like this. So we can easily interact with the user, ask them questions, display data in a very like meaningful and visual way. Now in this first video we're going to look at how we can create one, look at working with form controls such as combo boxes and check boxes and buttons, look at naming conventions for them, and then also some of the properties associated with them. And in the later videos we're going to look at some of the coding elements of actually working with them controls, validating the data and processing the data that was captured. Now our example here is that we've got a list of expenses,
we want a form to be used to capture this data. A nice, meaningful way that people can enter it. That is our plan. So, we've got some standard data at the moment. This is what we want to capture. We're going to switch straight to our user form, our VBA environment. So, Alt and F11. So, we're in that VBA environment. And we will go to our Insert menu. Make sure that you're in the project that you need on the left there. And a user form. So we're going to insert a user form. Here it is. I'm just going to resize the user form, make it a little bit larger than what it is, maybe about that. We can always work with that again at a later date. We see we get this toolbox on the left as well. So this is where we're going to be getting our form controls from. I'm going to drag it over to the right hand side. I always prefer it over there so it's not obscure in the Project Explorer and the Properties window on the left. Well, it wasn't really obscure in the Properties window, to be fair, was it? But I like it on the right anyhow. But we can shimmy that wherever you want. Find a bit of space on your machine and how large your screen is. Now, something we haven't really done much with on this course so far is this Properties window on the bottom left. Now, if you do not see a Properties window there, let me close mine down. If you do not see it, we can go to our View menu and our Properties window. Something that I know we did mention really early in the course, one of our first videos, but worth a little refresher there. View Properties window, and apparently F4. Here it is. Now we're going to start working with that a lot more, mainly to name the controls as we bring them in, but also explore some of the other properties involved. The first thing we're going to do with this user form is we're going to deal with a couple of the naming conventions here, which we're going to do for every single form. And the first thing is to name it. So this new user form is currently called user form 1. Bear in mind that we are going to have to refer to the name of this form in this example, but that control, throughout our coding. So we need a nice meaningful name that we can easily call off the top of our head and so on. So I'm going to call it FRM, and then I'm going to proceed with the name of the form without spaces. What is this doing? It's doing expenses. I'm going to call it expenses. FRM expenses. Bring the capital E in to change the name there. Now the FRM in front stands for form. You probably guessed that, and it's something that we do not need to do. You don't need that in there. You can name it however you wish, similar to how we name macros and name variables. However, this is known as Hungarian notation, would you believe? And it's a fairly universal language that we can use when naming controls. Now, some people go through this when they name variables and stuff as well. As you've seen, for me personally, I don't use it in the variable when assigning names to variables, but I do with form controls. So that when we need to reference a form control within our VBA code, we know it will be like FRM and a form name, or we'll come to them, but CMD for a button, or TXD for a text control. It's easy for us to remember once you get going with this stuff. We recognise it in other people's coding, but it also helps differentiate different controls that may have the same name. You know, I may have more than one control called first name, or something like this. So it's easier for us to differentiate between them. Okay, so very, very common thing to do, which you don't have to do, but you're probably going to see a lot out there in people's VBA procedures, and I'm going to use right now. Now, caption, a little bit further down, we've got caption. And this is what the user will see. This is that name that appears along the title bar of the form. So I'm going to call it expenses form. Sorry, my apologies. Expenses form. So we have provided a name, the name that we will have to reference when writing our VBA code, but also the caption, which is just what the user sees. Right, let's get stuck in with putting some controls on then. So the first bit of information we are capturing is the name of the person. So I'm going to bring in a text box control, the lowercase ab on the toolbox there. I'm going to give it a click, and I'm going to click, or maybe click and drag, to roughly draw a kind of text box on there, which I'm then going to immediately proceed to naming. No caption on this one, but I will name it. So I'm going to name this one TXT, says that Hungarian notation, and then I'm going to call it first name, because that's what it's going to capture. I'll click away to confirm that. I'll grab a label this time, the large A, so I can draw this roughly to the left. I may have to think about resizing these. I'm going to immediately name again. Good practice to immediately go and name them so that you don't omit that and forget. Very easy to do, and in mid-coding you'll try and reference it, TXT first name, and you realise it's still called, you know, text box 3 or whatever. Very easy to do. So LBL first name, immediately there I've given two controls the same name, but because of that prefix, LBL for label, TXT for text box, I can easily differentiate them. Now I should mention, you can find a list of these naming conventions. If you just Google this stuff, you can find a list easily enough. Typically it's just the first three letters minus the vowels in most cases. There are some exceptions to that rule, but in most cases, it's LBL, classic example of that, TXT, you know, first three letters minus the vowels. Okay, caption. Definitely the caption on this one. This is why we are even bringing in the label. It's not going to solve any other purpose apart from this. It's just going to say first name, so that anybody completing this form knows what they've got to do. Right, let's bring in another one, another text box. You don't have to do it in this order, but for some reason I am. Let's name that TXT last name, and go and get a label. Let's quickly shoot past this because we've got more stuff to get through on this video. Name it LBL last name. Caption it last name. Right, flying now. Okay, next up, next form control. We're going to be bringing in the combo box. So what we want is we need a drop down list or a combo box, and the user's going to use this to select what department they are from. So I'm going to bring in this combo box to start with, which is this one on the end of the first row. If your toolbox looks the same as mine, I'm going to give that a click, and I'm going to draw in this combo box. I'm going to try and make it the same size, but we'll look at that in a little bit. And I'm going to go and name it. So this one's going to be CBO. So I said there are some exceptions to that first three letters minus vowels. That's quite an easy way of referencing what they typically are. So this one's not that. It's a CBO, and then its name, which is going to be department. And I'm going to go and get a label control for that, so that people know what that combo box means. Which, you guessed it, LBL department, and will be the caption of department. Now for this combo box, we're going to need to provide it with the items to appear in the list. Now there are different ways of doing that. You may see some people do it on when the form is initialized, creating it kind of on the fly and stuff. But the easiest way, and what we're going to do here, is on our spreadsheet. I have a sheet called lists, and within there I have a very small list, and I've associated a name departments with that. So I've got a range name, a defined name for departments, to reference them free on a different sheet. And I want to reference that within my VBA code to tell it to show them as the items in this list. So if I select my combo box, notice that in the properties window they display the control or part of the form that is currently selected. So I can also select items from this list, if you prefer, as opposed to selecting them in the list. And what am I going to go for here? I'm going to go for row source. There's a property called row source, and in there I'm going to type equals department. Months, I think. Was it equals departments? Let's click away from that. Let's have a quick check, shall we? I can't remember if I put it in a plural form or not. It's in a plural form. It's departments. And I think that's in there. Equals departments. That should be working fine. Now, at any point while we're creating our form, you can check this out. So if you wanted to test that, I could make sure I've got my form selected and go for your standard kind of run sub user form button at the top. So I can ask it to run this code or run that form, and it will pop up. So at the moment, that's what it looks like. Notice the first name box is already selected, my cursor flashing. I can click in any box, and indeed I've got a combo box with the 3 items from that range name in there. So this is what it looks like at the moment. I can just close that down and return back to the code. So just use briefly there to check that it is functioning, the way that we wish. Okay, next control, we need to specify the date that this expense was captured, and we are going for the date picker for this. Now if I scroll down my toolbox, I have this date picker. Now this is something sorry, that has changed a little bit over the versions of Excel. So you might have to be a little bit careful with this on your version. But it's available to me to create a lovely little calendar picker, so somebody can choose the date easily as opposed to write it in. A lot easier than what you may have to do on an Excel spreadsheet. Now one of the reasons that is displayed on mine is because we can, or indeed I could right mouse click anywhere on this toolbox and go for additional controls. That opens up this dialog box where you can choose additional controls to display, all depending on the version of Excel that you have and whatever's been installed. And on mine I have it chosen to show the dates picker, which I'm trying to remember where that is in this list. I must have gone past it. There it is. The Microsoft Date and Time Picker Control number 6. Notice all these are in Forms 2 checkbox. So we can choose what items are displayed here. I saw Ref Edit mentioned there, which is another good one. The Ref Edit one is the one that allows you, there it is, Ref Edit, the one that allows you to select a range in a spreadsheet. So when you're in, trying to think of a dialog box that uses it quickly, the advanced filter. You've used the advanced filter maybe, and you're in there. We might as well just think about creating a chart, really, or creating a pivot table. You get the Ref Edit control in there, so you can select the range quickly on the fly if you haven't selected it prior to the wizard or the dialog box, depending on what version you're using. Okay, so that's a great control. We've got the Microsoft Date Time Picker Control number 6 enabled by checking that. So you may need to do the same to get it enabled on yours. You may have a slightly different version, and that is worth mentioning as well. This is a bit more volatile, this control. You may need to get to it first, or not be able to have it at all. But it is an example of another control that I have at my disposal. I'm going to click it, and then click it onto my form as well. And we can always look at resizing this and stuff afterwards, like we do the other controls. And most importantly, look at giving it a name, which is going to be DTP date. And then we'll need a label for it. Let's scroll back up. Let's get a label in there. Brilliant, which is going to be a name of LBL, date, and a caption of and date. Okay, I'm just going to select that date time picker for a moment. Now, for all these controls so far, as well as doing the name and the caption, and for the combo box we saw the row source, there are a lot of other options in there. Date time picker will have some unique ones, namely these max and min dates. Now, I wasn't planning on changing them for now in this example, but they do exactly what they say they're going to do. A huge range of dates there. You could be more specific to cut down exactly what date can be selected. That is not a bad idea. There's also a values box at the bottom here, which shows the default value when somebody first opens this form. So that's got what is currently today's date in there at the moment, but that will stay fixed. So whenever I open this form from now on, it's going to display the 31st of March 2014, which is not what I'm going to want, but I'm going to come back to that. We're going to look at changing that in our code rather than for now. But there's lots of other properties in there that I'm not going to bore ourselves with going through loads of these for now. But you know, lots of stuff for fonts and background colours and all kinds of stuff. Width and height and position, and there are some good bits in there. Okay, I'm going to come out of that. Actually deciding that I'm going to make my form a little bit wider. I'm going to put the other controls to the right, I think. Let's make it a bit smaller. I'm going for a checkbox next. I'm going to have a checkbox control. I'm going to put about there. And this checkbox control will be named CHK. Now, what is the first expense on our form? Right, it's car, train, taxi, overnight stay. I want to capture this information. So I'm going to give this first one CHK car. Checkbox car. Caption car. And what I want to do is we've got our checkbox, and we've just been talking about different properties. Probably worth mentioning that a popular one for checkboxes is value again. So currently set to false. So when people first open this dialog box, that will be not checked, basically, which is the way I want it. But we can choose whether we want it checked by default or not. In some cases you may do, in some cases you won't. In this case I'm not. And what I'm going to do is I'm then going to go and insert a text box control, which I'm going to name TXT car. So now we really are seeing some duplication on control names. I've got CHK car and TXT car. But I know that one is the checkbox associated with it, and the other one is the text box, sorry. Now I've got this text box still selected. What I wanted to see as another property here is I was going to scroll down and demonstrate the use of the visible property. So the visibility is currently set to true. What I want to do is I want to display the 4 checkboxes, and only when somebody checks that box, if they do, the text box will appear. And this text box is going to be for them to type the value in. So they can say, yes, I did travel by train, and the expense was £55. You know, yes, I did need an overnight stay, and so on. But a text box will not display if they haven't checked it. So I just want to use this as a demonstration of another property down there. So we can't go through a huge amount, but maybe a lot of them will kind of read quite nicely anyway, and you've got an idea of what they do from your experience of using forms on the web or in Excel and that. Yes, but a good example, very useful property, shows something a little bit extra that we can look at working with in our code as well. So I'm going to set that visibility to false. Do not display. So if I played my form now, if I select my form and I run it, this is what it looks like. So I've got a checkbox for car, but I do not see the text box.
Now we're going to have to add this into our code, but when we check the box, that will appear. There's today's date, by the way, in the date picker. And if I gave that a click, that's your date picker. So really coming to the fore now. Let's begin to look the business. I've now got to quickly add in the other 3, so I'm going to do that in a relative speed, so that we can shoot through to anything else that's next. I forgot what's next. Train, I think. Train. Shoot through the amount of repetition on this video. Let's reduce that. I need a text box. I'm gonna rename that TXT train. Then another checkbox, which is going to be CHK taxi. The caption will be taxi. Text box. I need a text box. In it goes. Oh, TXT taxi. This is fun. Right, I just realised I forgot the visibility property or attribute on the other one. Visibility false. Let's get to that train. Visibility false. One more to go. Checkbox. CHK overnight. Caption will be overnight. And then let's reduce that a little bit. Text box. Whoops. Okay, it's in there. Didn't mean to drag them, but TXT overnight. Oh, visibility false. Okay. So getting through some of it there. Did that by double clicking, by the way, if you're wondering. Now, as you can see me doing here, I mean, once them controls are in, they've all been named. We've dealt with some of the properties associated with them. Something we're going to need to tidy this up on these at the moment is we're going to need to arrange them. So clearly this is not the same size and I may want it to be. And also these need to be in alignment and stuff. So I'm not going to spend the whole video doing this perfectly. I'll perfect it outside the video ready for the next video. Although you should have your own by then anyway. But just to demonstrate some techniques, you know, when it comes to the width situation, by selecting a box you do have the information in here as to its kind of height and width, so we can work with the actual measurements. There's the height there, 18, so we can deal with these. There's width 66. So if I've got the width of one of the other boxes, then I could mix and match. The width is 84, come to this one, specify the width of 84. Now that's one way I can do it. I now know that that is the exact same width as the taxi one. Now I could have copied and pasted the taxi text box and then just renamed it overnight. There are other approaches. Some of these you might be thinking right now, oh well, I would do it like this. That's great, go for that. But we need to make sure it's the same height and width. Something else, which I might drag that a little bit to the left for, is I could click and drag to select the controls. Now notice when doing the area select that as long as it touches a box, it will select it. Now that's a little bit different to if you've used things like Visio, where you have to incorporate them all for them to be included. But here, as long as it touches it, that's enough. So I'm going to have to be a bit more precise with my selection there. So you don't get them text boxes, only the check boxes. Format menu, and we have our align options. So I can ask it to align the lefts, and they all meet up quite nicely. I might drag them a little bit to the right. Yeah, perfect. And they are now in line with each other. I could select these text boxes only. Say, oh, let's align these. Let's align their lefts. Ones I made sure they're exact same width. And here it's beginning to come together. You know, I might want to align these all up together. Let's align you guys. Let's get you, trying to get that selection a bit better. There we go. And can we align the tops of you, so I know that you're all the same? and so on and so forth. Now we can also do things like select controls, and another thing you may have done in, probably more likely in the likes of PowerPoint or Visio, these kind of techniques, but you could do them anywhere. Things like vertical spacing. So make sure each of the controls is the exact same width between each one. So I'm going to say, can you make the spacing equal? I don't think they moved there, so it must have been pretty equal already. So there's a lot of techniques that we can use from the format menu there, or by measurements or other ways, of making sure that these controls are perfectly in line with each other, distributed equally, and your form is going to look the business. Okay, now we need 2 more controls on here. I need 2 buttons, which we're going to add most of the code into in the next few videos. I will need a command button, this 3rd row 2nd button, which I'm going to draw in to be about that size. And its name will be CMD OK. This will be the OK button. Its caption will be OK. And then on what we just spoke about, I'm going to copy and paste that button. Gives me another button the exact same size. Drag it next door. It's quite it's quite easy to align controls with each other, because they're magnetised to the grid in the background here. So you may find you can align them by hand and not so much from that format menu if you can get away with it. Caption cancel. So it's your cancel button. Its name is CMD cancel. I've got 2 buttons. I'm going to select them both and move them a little bit further to the right to align them with them boxes above, using the grid to align them there. I think it's okay. If you weren't too sure, we can select all of these. I have to select that and also select all of these to get this done, and look at aligning their rights. And I don't think that moved. Something was okay, but you know, we'd spend some time doing that properly before it got done. Okay, I think the last thing to mention on our design, or our creation of this form, which we probably don't need to change because of the way it was set up. Now where is it? I think it's the view menu. We're going for the tab order. Now if you've ever filled in a form before, and what am I asking, of course you did, you would have filled one in to purchase this course. But the tab order is when you press in your tab key, it's the order that each control gets its focus. You know, selecting each control. Now because of the order that this was created, it's probably okay already. But this is where we can go to change this. So when somebody's tabbing through the form, it goes from first name to last name to department to date to car, train, taxi, overnight. OK, cancel. Which is the exact order I want. But we can select controls in here and change this tab order. So if it wasn't quite right, especially when you change this in the future, if it goes from first name to last name to train, back to department, to date, back to car, and this kind of stuff, and jumps to overnight, then we need to deal with that so that somebody can, you know, nice and user friendly when somebody's completing it. They can just tab through the fields, nice and easy, very fast. Yeah, it's a data entry job, but nobody likes data entry here. To quickly plough through and get these expenses done, rather than to click with your mouse or anything like this. So that's our tab order. Very, very useful. We want to make sure that's set up correctly, which at the moment it is. So I click on my form one last time and run it with F5 or that button. When I press my tab key, it's moving through the forms in the order that we want. So that is that. We have ourselves a form. In the next videos, we're going to have to start adding some VBA code to this now. We need the text box to appear when we check that box. We need the date field to pop up its date. We need a way of opening the form. I mean, at the moment, we can't even get it open without going through the VBA environment. And one of the most important thing of all, when we hit that OK button, we're going to need it to put information in this list. And we need to validate for invalid, or
wrong information. So that's all coming in the coming videos. This was just to create one. I'm aware it's not the most riveting of videos and jobs, although some people enjoy it. But it's important that obviously we get this looking good, and we assign some properties to make it function correctly, and maybe even format it correctly to keep it in line with our company's brand and colour scheme. Hello and welcome to this lesson where we are going to start to look at how we can open and close our user form that we have created. So I have this spreadsheet where I need to record the expenses, and we've got this user form that is going to achieve that for us. But before we can fill in the form, we need a way of opening it, and then equally a way of closing it down. Now let's kick off with a kind of opening procedure. So let's get into our VBA environment. Let's get to the Visual Basic Editor, and I'm going to insert a module because we're going to have to write this as a normal sub procedure, and we're going to assign this to a button on the worksheet. So I'll insert a module. We're going to create a sub procedure which I'll call add expenses, and it's simply going to have one line to open up the user form. Now if I refer to the user form, FRM expenses, I can see it mentioned on the left there, FRM expenses dot, and here are a load of properties and methods associated with that user form. Now we're going to go for the one called show. So we have a method called show that does exactly what it says it's going to do. It's going to display your user form. So it will load the form, initialize it, and display the form. As you can see, there are a lot of other different properties and methods in here to achieve various jobs that may come in handy at other times for you. We're going to go straight for this show. Where'd it go? Here it is. And that is that. We need to create that button on the worksheet, but that is just a little sub procedure that's job is to display our user form. So let's, while the iron is hot, get back to our spreadsheet, and I'm going to insert a button, which I'm shooting through relatively quickly here because we have done this kind of stuff before. In goes a button. I'm going to assign it to the add expenses sub procedure, and I'll label my button add expense. Let's make that bold, that text. Who likes a nice bold text? And that will do us for now. So this button, when clicked, will open the user form. Now here is the date that we mentioned in our previous video. This date is actually yesterday's date. I'm recording this video on a different date. And I mentioned this in the previous video that that's not always going to display today's date. That's just kind of displaying the date that it was created on. Now we need that to always show today's date. That's what I want. Somebody can choose a date, any date, but I like that to show today by default, with the assumption that maybe 50% of the time people putting this expense in, it normally has happened today. So let's close that form down for now, and let's go back into our Visual Basic Editor. And we can put this kind of information in using the properties window, like we had a look at some of the properties in that previous video for this DTP picker, this date picker. But what we're going to do is we're going to code it in, because it gives us an opportunity to look at some of the user form events. So I'm going to double click anywhere on this user form to take me into a relevant code window. As we know that we can double click on any sheet or workbook or module to see their code window.
I can also double click on the form. And that will give me the event, user form click. What do you want to do if somebody clicks on the user form? That is its default event. But over to our right here, we have a drop down list of other events that we can use. So this gets us going with events, working with user forms, and all of the different controls on a form and the form itself will have a list of events associated with them. So here are some of the events for a user form. And the one I was going for, let's have a little scroll through the list actually first. Here's some of the stuff. But the one I was going for is I'm going for initialize. So as a form opens, one of the processes it goes through is its initialization. And it's a good place where you can add code that kind of needs to run at startup, if you will, when the form opens. So some people use this to clear fields, set default values, build combo box lists on the fly, whereas we've referenced the range name on our sheet, and that kind of stuff. We're going to use it to set the default value of our date picker as the example of this use. So I'm going to say DTP date, because that is the name of the date picker. If you forget this name by any point, just pop back to our form by double clicking on it, select the control, and have a look in the properties window there, DTP date. Just double click on there. Or I guess you could click this drop down list up here, which will drop down a list of objects. We can see DTP date up there as well. Okay, DTP date dot value. The value of that control equals, and I'm going to write date. Now, if memory serves me, earlier on in this course we used that inbuilt function to write today's date onto a worksheet. So it's not the first time we've used it. But that inbuilt function for date will assign whatever today's date is from your computer's clock to that form control, the date picker. And it will do this at the user form's initialization. Now this sub procedure here I can just delete. It's not doing any harm. Quite happily leave it there. But it's an erroneous event. I don't need that. That was a default event for the form and I've opted for something else. So I'm going to skip past that. And the last thing we're going to look at in this video is closing down the form. Now you've already seen me do that using the X in the top right hand corner of the form. But I'm now going to look at popping to that form and assigning this to the cancel button as well. That's what the cancel button is there for. So I'm going to double click on the cancel button. So I then take into the default event for that form control. So CMD cancel, click is the default event. Once again, a list of different events appearing on the right there. What if they double click it? What if they mouse over it? And so on and so forth. As you can imagine, clicking it is kind of the event for a button, and that's what we're going for here as well. And we're going to write two simple words to close down this user form. We're going to write unload and then me, which is quite cute, don't you think? But because this button, because we're closing down the form that the button resides on, we can reference it with the simple word of me. We don't have to say unload FRM expenses or anything like that. FRM expenses dot this. We can simply refer to it as me because it is the kind of parent control, if you will. The button belongs on that form. It is closing down its form, not a different control of some sort. So unload me, that would ensure that when this form is opened, let's give that a run for a spreadsheet for a more real-time environment. Somebody clicks a button, the form opens, and the today's date is displayed in the form control. Somebody can then click this cancel button if they don't need it anymore, and it unloads the form. So there we've got opening and closing the form, and also a brief look at the user form's initialization or initialize event, which is a popular event for loading up default values and building controls and this kind of stuff as the form kind of opens on the fly, if you will. Okay, in the next video we're gonna have to have a look. I'm sure what you're dying to get going is the actual functionality of the form. We need to program this OK button to do its job, and we need to be able to get these text boxes to appear when we check the relevant box. Hello and welcome to this lesson where we're going to start to add the functionality to our user form. So most of this functionality being driven by the OK button to actually add the expense. But before we get to the OK button, we want to program these text boxes to appear when somebody checks this box. So as a quick refresher, so I don't know if you're watching these videos days apart or if you saw it 2 minutes ago, but if I hit my run button to display this form, these text boxes are not displayed. We want to be able to check a box and a box appears. Uncheck it, because we made a mistake when we ticked it, it disappears. We need this functionality. So I'm going to double click somewhere in my user form to get into this kind of module, this code module, and along the top, where in the first drop down list we have a list of objects, I'm going to search for the CHK controls, checkboxes. I'm going to start off with car because it's logical, it's the first one in that list on the form. I'm going to select it. So it'll bring up the default event, which is to click on CHK car. Now I was going to move to the events on the right, because I was actually going for a change event. I believe the click event is activated by mouse click. I'm not 100% whether that functions when people use the space bar or stuff to click it. So I'm opting for change, if that changes its value as opposed to when it is clicked. But essentially, once again, there are lots of different events available in that list which are a trigger for our code. I'm opting for the change event. I can now delete this click event, not that it's doing any harm, but it is redundant. And I'm going to put in some code to display the text box. So naturally there's a decision to be made here. If it is checked, then make it visible. If it is not, then don't. So we're going to put in an if then else statement. If CHK car equals true, so if it is checked, then let's put that end if in. Good practice in case we forget. TXT car, so the text box associated with that control, dot visible, there's a property called visible, and it's good that it came up in that list because I've made a typo. Dot visible equals true, then please make it visible. If the checkbox is checked, make the text box visible. Else, make it invisible. TXT car dot visible equals false. So now we're going to need to repeat these for the other controls, but a simple little if statement. So when the checkbox is changed, check its value. If it's true, then make it visible. If it's not, then don't. So I'm just going to try and do this as quick as I can. I'm going to take a copy of that little chunk, that if statement. Got to pop up to the objects and choose the next one. Should we CHK train? Doesn't really matter what order these go in, but try to put them in the order that they are in the form, because to me that's quite logical for a user reading this code that it appears in that order. Let's paste that in. I shouldn't really worry too much about these spaces, but CHK train and TXT train and TXT train. Okay, next up, apologies for this boring bit, we'll shoot through these, get them all in there so that we can move on to the OK buttons. Let's get rid of that tick. Let's paste in our code. And we've got car to taxi, and car to taxi. I must have a caps lock on there. Taxi. And one more. Then we've just got the overnight to do. So I'm just going to pop in here and choose overnight. Overnight. Change that to a change event. Paste in the stuff. Here we go. And change it to overnight. 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 Whoop. And then overnight. Okay, let's get rid of that. So, they are them done. Let's have a look. Let's pop back to our form. I'm going to run that, and we'll see what it does. So I'm going to check a box for train, for example. Text box appears. Check it again. Disappears. Overnight. Oh, important stuff. I've changed the wrong thing. Okay, let's close that down. Always test your work. Mistakes happen, especially moments like that where you find yourself just repeating the same thing and your mind is drifting because it's so blatantly obvious that you're not even concentrating so much. You have to love the VBA debugging tools. Right, visible, love it. Reset that, let's give that a go. Play it. Overnight. Oh, hello. Taxi and car. Don't know why I tested in that order, but they seem to be functioning lovely. So that leaves us with this OK button. I'm going to give that a double click to immediately go into the events for the OK button, similar to what we did cancel. So I can see down here now we've got a private sub OK click. Once again, events from this list, but we're going for the click event, so I'm happy. The order these appear, by the way, is not important. They're in like ascending order by their name, and that's why they appear in this order. But it's irrelevant. You know, the user form initialize happens before any of that stuff, despite it being at the bottom, because it begins with a U, essentially. Right, so this OK. We need to get to our sheets. We need to find the bottom of this list and capture what row the next vacant kind of row is. We're then going to use that to populate this information into these cells. So in our code, I'm going to declare a variable called row num. There are different ways of doing this kind of stuff, like finding the next empty row, and we've used a few different techniques throughout this course just to get a feel, really, the pros and cons of each one, how you like to establish yourself, or how a colleague may have done it as well. And then we need to find out where it is. So I'm going to say row num equals range a1 dot end. I'll have Excel down dot offset 1,0 dot row. I think that's it. So from range A1, go to the bottom of that list, or not go there, but look at the bottom of the list, one cell below the bottom, and capture what row number it is. Beautiful bit of code, incorporating some of the bits we've done throughout the day. So that's assigned to row num. So that sorry, I'm going to use the cells object to assign the information from our form to the cells of that row, the columns of that row. So I'm going to put cells, row index is row num, that variable, comma 1, which is the first column, i.e. column A in this case, dot value equals, and this will be first name, so txt first name. Now I'm going to copy that line and I'm going to paste it onto each one. How many controls have we got? I've got 8. We could put this in a funky little loop and stuff this to try and shorten this code, but it's such a simple little procedure, I don't really think that's necessary. But you may notice some people do that and have their reasons for it, to be honest. But if it works, it works. And it's however people are using it are happy. So I'm changing the column numbers. I don't need to change the controls. So this one is last name. This one is a combo box. It's CBO department. I can't remember if it's department or departments. Quick check, CBO department, yes. This one is a DTP control. Now as a reminder, we can do things like control space, stuff to drop down these IntelliSense lists, which are, never a bad idea in these situations if you're trying to remember the name of like a property, a method, a control, and this kind of stuff to draw on. And I can see DTP date appear in this list as something that's available to me. So I'm going to double click that from there. Quick little reminder, control space for the IntelliSense list. These are text boxes. The first one, if I get the order right, is car, then train, then taxi, whoop, and then finally overnight. Let's just double check the spreadsheet. Car, train, taxi, overnight. Okay, I've got the order. Happy with that. So, let's have yes, I think I'll head for that. Let's have a look at what we've got so far. What I'm going to do is I'm just going to pop back to here and click my add expense form. My button. So it appears, and I'll start to put in maybe a fictional information. I have Mickey Mouse. Department as marketing. Date, I'll leave us today. Car, yeah, there was like £24 on the car. And that would be that. Not to really stay overnight if it's only £24. I'm going to click OK. Now I can see in the background that information has appeared. Mickey Mouse marketing. Now, we can also see some problems though. I mean, first of all, you may have noticed that the user form did not close. So I clicked OK. It performed the relevant actions. It's found the last row. It's input the data as necessary. But it didn't close the form. And I'd like it to close when it finishes as well. So we're going to have to program that in. Just like when you're in format cells, for example, and you do what it is that you do, and you click OK, and it will do that and close the form. We want that behaviour. You can also notice that it's not really happy at the moment, this spreadsheet. It's input the correct information, but it's come in a general format and not as a date. And that should be a date. Even worse is that this has come in as text. Because it was captured by a text box, it's been input to the form as text. So despite the cells being formatted in accounting format ready, it's coming as text. Excel's immediately warning us about that to convert to number, which we could do, but it is just not happy, is it? So for now I could choose to change these myself. So you are a date and you are a number. Thank you for letting me know this. It seems to have lost its accounting format because of that though. But we're going to need to program this stuff in. There's some glaring errors with our functionality as it stands. So, back to the editor we go, back to the code for the OK button. First of all, let's close that form when it's done. So I can still see what we wrote up above for the cancel button, and we're going to replicate that at the bottom of this process. So we're going to unload me. The data's in there. We can now unload the form, which we reference as me because the OK button is also on that form. And then we're going to start to think about the data type conversion. A really important concept of using user forms is to convert the data ready for the spreadsheet, as has been demonstrated. First of all, let's get this DTP date one done. And what we're going to use is a brilliant function called cdate. Now you can Google these and look them up, but you get the likes of cint, I think it is. I think it's cstring and cdouble, cboolean or cboo. We can look these up. We can Google these, bring them up within our editor. There's a whole bunch of them that work on converting data. Really, really useful, especially user forms. No surprise that cdate converts to a date. And they're asking here, bring the information in as a date. Tell me what the expression is. I'll convert it to a date. So we say, okay, capture the contents of DTP date and do your thing. Convert it to a date for me, please. Okay, so that will do that one. But for these text boxes, and we're going to need to do all of them, although the example demonstrated car going wrong, there are functions like cdouble, as mentioned, but we're opting for something different here. We're going for another brilliant function called val, short for value there, that will convert any numbers it can see within a string. So it doesn't have to be a number on its own. It could say 10 High Street, and it would capture the 10 and bring it out for you. It would, accept a string, look for any values within it, and extract them and have them converted as a value. And as you can see, it tells us here as well that it's going to convert it to a double, which is brilliant for us because these are currency, so they are in decimal form. They are in double form. So this is exactly what we're after. And it's a simple function again. We just need to wrap this val function around each of these objects so that it can convert them for us. So two brilliant functions for converting data types, which is an essential skill of using VBA to be able to do that. Detecting data types, converting data types. So there's not more to investigate in that area, but these two especially should be able to get these jobs done for us. Only one thing left to do. Let's give that a test. Let's click our button, put in Donald Duck. Oops, I can't fill in my own form correctly. Donald Duck. Let's say Donald Duck is from training, and he took a train for £53 and a taxi for £10, and he also stayed overnight for £102. Let's click OK, and there we go. So we have Donald Duck inserted. The date is coming correctly. The values are coming as currency. I can see these are blank here. I can fill them in with zeros. That would not happen anymore, as you can see replicated with car there, because it's been that empty string has been converted to a value that's bringing across the value of 0. So from now on, this will be consistent. And yes, we have a functioning form. The last video of this section is going to look at some validation techniques. As I nearly did there and entered data incorrectly, we want to try and make sure, as best we can, that data is valid before we add it in there. Hello and welcome to this lesson where we're going to look at some validation techniques for our user form. Now I don't want to drone on too much on validation. It's a very important concept, but in a way it's something that's been happening throughout this course, both in the section where we spoke about error handling in more detail, but also in the different areas that we have kind of tested the input to like input boxes or message boxes or onto spreadsheets. And we've done quite a bit of this as we've gone. So a very important concept that we're going to have a quick look at, a couple of other examples that will differ a little bit to what we've done already on this course, but also want to hold back a bit, or this kind of topic could go on forever, and to a degree a user's got to make sure they're doing the right thing, to be honest, themselves. So the two things I do want to look at though is I want to perform a check when somebody clicks OK. And this example of a check is going to be to make sure that both the first name and the surname are not empty. I'm going to say, look, you can't input information without the person's first name and surname. They have to be populated or I will not allow entry. So I'm going to double click the OK button to take me straight into that part of the code. I'm going to put this after this information. You could quite happily go before, but I do like the variable assignment, declaration and assignment at the top there. And we're going to put an if statement in to test if txt first name equals an empty string. So when they click OK, have a look at that form control. Is it empty? Does txt first name equal nothing? Let's put my end if in. Now, if it does equal nothing, what do you want to do? Well, the first thing I'm going to do is I'm going to put the user back into that control, which when dealing with controls like text boxes, we call setting focus. So there's a method called set focus that positions the cursor, like the insertion point, back into that control, so that when a user is taken back to the form, they are there. Just like you might have experienced when you fill in forms online that typically take you back to the control that you omitted or you mistyped, it was your email address or something. So txt first name dot set focus. Also similar to what you might come across on the web is that at times they will change the colour of the control. So it's a lot clearer as to where the mistake occurred. So I'm going to do that as well. I'm going to say txt first name dot, and once again this list of properties and methods, there is one for back colour. So the background colour of that form control. And I'm going to assign a colour to that. And I'll tell you what, if I do control space, does that bring up an IntelliList? It does. Here we go, this is better for us. Control space for the IntelliList. As I type RGB, a list of colours appear. So we can take our pick from these beautiful colours available to us. I was going to opt for red, but if you want a salmon colour or an orchid colour, go for it. I'm having red, classic colour for errors, danger, problems, this kind of stuff. And I'm going to exit the sub. So, yes, exit subroutine. Don't accept that. Put them back to the form control, change its colour, abort the macro. And I'm going to put as a, I guess I should put like an else if for it really. Could put separate if, but let's have an else if txt last name equals empty then, and I'll copy that into it. So we want a second test. There are different ways we could write this second test. I'm opting for the else if approach here. But in these latter parts of the course here, I'm just kind of thinking, you might be thinking your own way. And that may be better, may be worse. To be honest, if it works, you can't really say anything's right or wrong. Things can be improved, but It's all about functionality. So, are they empty? If they are, then take the appropriate action. Only one at a time, don't change both of them. So test that one, do it and exit. So it's not going to change them both red. I can't set the focus of both of them either. Okay, so that is that. Let's jump across and get another validation technique done, and then we'll test them all out together. So I just wanted to do one more, and the other example I wanted to do is we have the 4 text boxes that are capturing values for the car, train, taxi and overnight expenditure. When the text boxes are changed, I want to do a check at that point, so not at the OK click. At the point of changing that control, I want to check it and make sure that there is a numeric value within there. It has to be numeric. So, let's have a look at that. Let's go to our drop down list at the top and choose the relevant control, which in this example, let's pick on car to start with. It's going to be TXT car. So I want the text box, because that's where the value is. And it's immediately gone to this change event, which is the one that I wanted. But once again, recap, list of events that you can have a look at there that may match what you want. So I'm going to say TXT car change. I want to know if, and I'm going to choose is numeric. I'm trying to remember if we have done that on this course as yet. I can't remember, but probably. I do like this. And Excel primarily deals with values, so it's very important. Check the expression as a boolean and see if it is true or false. Is it a number or is it not? I want to know if txt car dot value, yes, is numeric. If that equals false, so it is not numeric, then okay. And what we're going to do is we're going to display a message to the user. MSG box. Haven't done one in a little while. You have not entered a value. That's not a very good way of phrasing that, but my brain went dead. I didn't know what to type. But you get the idea. You have not entered a value. What else do I want to do? I want to set its focus. TXT car dot set focus. Put the user into that control. Now, not going to change its colour. We're just going to put the cursor there. This is not happening on the OK button. This is happening immediately after changing it. So it's a bit more logical. The user's going to know what's happened, especially as we display a message box. Okay. And then we're gonna exit sub. And that is that. Might just leave it at that. I won't worry about the other 3. It all takes up chunks on these videos. You get the idea. But we can copy that and tweak it for the train, taxi, overnight. I'll do that for the file that I'll supply on this lesson. That will be ready to go. But the purposes of this testing, that will do us. The car text box. Let's go back to our spreadsheet. Click our button for a new expense and see what happens. Let's not put a first name in. So this is Minnie Mouse, but I haven't mentioned her name. Sales. Let's ignore the car for a moment and put a train of £20. And let's click OK. Oh no! Somebody's missed out a first name. The cursor is immediately put into that control. That is it set in focus. And it changes colour to red. And clearly it has not gone ahead with its task, which is our exit sub. If I put Minnie in, we are now quite happy. So Minnie Mouse is entered into there, and so is relevant information. I mentioned before that'll be okay now. Right, let's press it again to trigger it. And this time I'm going to enter this stuff correctly. I'm running out of things to say. Let's put bill branding in. I have a little kind of repertoire of silly names that I sometimes fall back to. Marketing, let's try it car. But I'm going to make a typo. Y73. Oh, immediately it tells me, comes like you have not entered a value. I tell you what is a good idea is after typing that we clear the cell as well. Notice when we click OK, I've got a backspace to get rid of my mistake, and it warns me straight away. So this is stuff that you can see when you get going with a form, and as you test it out, you think, oh, I don't like that. The fact it's testing it every time it's changed. You know, so we could run it on maybe the exit event, so only when somebody leaves the control will it perform the test. That might be better. And I quite like the idea of clearing the form as well, so that somebody doesn't have to remove the text themselves. You know, they made a mistake, clear it, so you do it again, sort of thing. So this is good. I'm going to put a 34 in there to run that through, and it's done. So back into our code, you know, and back into the the coding stuff here. We can add this stuff in at our leisure, and please experiment with this. This is what learning VBA is all about. If you've got your own ideas, get stuck in, try it out, read up on it, look at what other events might be better for you and how you want it to behave. You know, in this example, to clear that, we could quite happily just put txt car equals, and I can just put an empty string in there to kind of clear that as one way of clearing it. And bear in mind that on these list of events, there are things like exit, which will happen when somebody leaves that control. So there are different ways that you may decide to approach that. Okay, I'm going to remove that from this, and I'm going to set the other controls ready for this lesson. But that was just looking at a few examples of validating user form entry to try and ensure it is accurate before we start adding it to the spreadsheet, which is essential. Otherwise, anything else you've got going on, such as charts, pivot tables, conditional formatting rules, they may not function because of it. Hello and welcome to the first of our lessons on looking at using event procedures as a trigger for your macro or your procedure. So we started looking at this really on our previous section on user forms, where for the first time in this course we started looking at more natural ways of triggering your procedures as opposed to somebody clicking a button on the toolbar or on the ribbon. So we started to look at things like forms being initialized and kind of form controls losing focus and these kind of things, more natural stuff that's happening, and behind the scenes procedures will begin running. So we're going to look at I believe 4 or 5 different examples in this section, and for the first one we're going to look at the opening of a workbook, a classic event procedure. And in this example, when somebody opens this workbook, what we want to do is we want to make sure that the user is taken to the update worksheet and that the cell selected is cell A2. So a nice easy thing, it's just going to ensure that it always opens on that sheet and that cell, because that's the most logical place somebody wants to be, really. Just like when you start up an email, you know, your cursor will be flashing in the to field. That's probably where you want to be first. It's quite logical that you're going to put the recipient address first. But when we do something like forward an email, they put the cursor in the body of the message, because that's probably where you want to be. It might not be. You might want to add another recipient address. Who knows? But that's probably a fair shout, and it's trying to save you time. So that's our example here anyhow. So what we're going to do is pop to our Visual Basic editor, and what I should do really, I guess, is back on my spreadsheet before we get going, I should pop back to the inventory sheet and click somewhere on there. So that's kind of forced area that I was in. And back to our editor. So here's a procedure that we created earlier. It's one of our previous projects, this.
at one of its stages. What I'm going to look at though is I'm not concerned by that right now. I'm going to the This Workbook object over in our Project Explorer here. And I'm going to double click on this workbook. Now, it's been a long time since we did stuff like that. We were talking about this really early in the course where we mentioned the Project Explorer. And I hopefully mentioned at that point that you'd only really go into a worksheet or workbook object when you want to associate a procedure with one of its events. So when I double click on this workbook, I can see on my title bar at the top that it's in the code for this workbook. I've got a module that looks like any other module, with option explicit along the top. But along the top we have these two drop-down lists. And for the first drop-down list, I'm going to choose Workbook. Not that I've got much option there. And in the second drop-down list, I've now got a list of procedures. And the default procedure for a workbook is the workbook open procedure. But this drop-down list gives me a lot more scope for choice here. And we're going to look at a couple more of these before we finish with workbook events. But the workbook open is actually the one I'm after right now, the workbook open event. And on opening, I want to say sheets, and I can't remember what it was called. I think it was called update. Better check that before I do it. Dot select. And I'm going to say ranger A2 dot select. It's nice and easy. No award-winning code in there. But we're asking it to select that sheet and select that cell based on the workbook open event procedure. So if I close down that editor, and before I look at saving and closing, I'll double check that is update. I'm confident it's A2. So I'm going to save this file and close it down. And I'm going to look at reopening it. It'll be in my recent list, workbook open. And I'll enable content. It's always a bit of a pain with event procedures. Let's just take me to that other sheet, but it's looking for me to enable content. If I click enable content, it then takes me to the update sheet and to that cell. Now we also spoke about macro security on kind of that note earlier in the course as well. And it's not a position for me to say, you know, we can enable macros automatically and we wouldn't have got that message. But obviously that's a security issue, and especially if you're working in a business, that's certainly not for me to say. That'll be IT's call really, and the policies within your company, as macros could potentially contain malicious code. But as soon as we enable that content anyhow, our workbook open event is kind of triggered and it does the job we want. Which I say, nothing amazing here, just takes us to that cell on that sheet, but it's an example of running one of your sub-procedures off of an event, one of the workbook events in this example. Hello and welcome to this lesson where we start to look at the workbook before save event procedure. And in this example, what we want to do is, I've got this really basic spreadsheet on screen that's got an ID in cell B1. And just an example, we can relate to this however we wish, but I want to make sure that before somebody saves a file, they must have changed this ID. I want to make sure that this is changed from the moment somebody opened the file to the moment they save that file. They can't save it without changing that. So into the Visual Basic editor, once again I'm going to double click on the This Workbook object, and I'm going to start up the event procedures for that workbook. So following on the previous video there, but this time I'm going to choose the before save. I said, didn't I? Before save event procedure. So I'm going to choose before save. And now I have it. So the before save event procedure appears, and it appears above workbook open.
mentioned in the previous lesson that workbook open is the default event procedure for the workbook. Now, if we didn't want that, I could just select that and press delete. There's no harm in it being there, apart from it, makes it look a bit untidy and is kind of cluttering things up, and we could just remove it. However, we need it. We are going to need the workbook open event as well, because what we want is we want to make sure that the moment the workbook is opened, we need to capture the contents of cell B1, the ID, in a variable, so that the moment somebody saves the workbook, we can test it and see, has this changed since they opened the workbook? So we're going to need that in there. But first of all, we need a variable. And this variable needs to be available to both procedures. So I'm going to put it outside of the procedures and at the top of the module. So another thing, it's been a while since we spoke about this in our working with variables section of the course. We spoke about variable scope. This variable needs to be available to both procedures, so it's going at the top, and I'm going to put dim, and I'm going to call it version number, as, and I guess I should put long in case it gets quite large. And in any workbook open event, I'm going to say version number equals, and I'll put range, B1 dot value. To keep things easy here, we're going to assign the contents of B1 to the variable version number, which will be available to it because that is available across this module. Okay, now in the before save event procedure, I'm going to declare another variable, which I'm going to call a new version number. New version number. I have that as long. And I'm going to assign the current contents B1 to it. And this is maybe a bit unnecessary, but I wanted to throw this in as we put one variable module wide. I wanted to have another one that's just local. This is procedural level. I'm going to say new version number equals, and it's probably going to moan when I click away, it does, but I'm going to nick that little line there. Super. So now we can test and say if version number, don't know why I wrote NO for one and number for the other one, just to make this awkward. If version number equals new version number, then, now if they're the same, that means that somebody didn't change it. Since the moment they opened it and the moment they saved it, they have not changed that version number. So I need to take some action on that. What I'm going to do is cancel the save. Don't save it then. Tell the user they haven't changed it and abort the save. Force them to do it. Now we notice one of the reasons I'm going for this before save event procedure here is to show that we've got some arguments to deal with. We've got one that is save as UI as Boolean, and we've got another one that's cancel as Boolean. I wasn't going to worry about the save as UI for now, but I was going to use the cancel. So it's providing us with this parameter. They're saying, look, if you want to cancel the save event, it's a Boolean value. So it cannot be either true or false. So I'm going to put MSG box, you have not, dear me, changed the version number. And I should correct my U there. And then we're going to put cancel equals true. So I'm manipulating the parameter that they have supplied. I'm going to say set cancel to true, so do cancel this. Now I don't have to put an else statement because otherwise it will just continue with the save. Now it'll perform this action anyhow, it will continue with the save. So this is an example of using the before save event procedure. but also manipulating some of these parameters, which is relatively new to us here. So right, let's close down this editor and give this a go. So yes, I'm going to look at saving this file. Let's save that. And it's quite happy for me to do so, because I typed that in, that 112, since I opened this workbook. So if I close it down, it's okay. And if I reopen it, the moment I open this workbook and enable content, it will trigger the workbook open event. So now it's made a note of the contents of B1. So if I don't change this and I go to save the file, I now get this message saying you have not changed the version number. And if I click OK, it refuses to save my file. I can see that by if I save again, it continues to moan. So if I change it to 113 and then look at saving, it's happy for me to do so. I can now go to close. So it's an example of running events there on the procedures on the before save event. We could have added more to say, make sure it's kind of incremented by 1, and obviously there's a lot of scope for what procedures they can be. We can't be all day showing every single possible example. Okay, next up we're going to look at our last workbook event procedure, which is going to be inserting a new sheet to a book. Hello and welcome to this lesson where we look at the new sheet event procedure for the workbook object. So just rattling through some different examples of event procedures here so we get a good look and feel of them. And in this example, it's the event of somebody inserting a new sheet. However they go about it, whether they click this button at the bottom or whether they go through like the insert drop down and choose insert sheet, however they get it to happen, this event will run. So into the editor, and it's this workbook object again. So we'll double click on the workbook object to pop up in the module window. We'll choose workbook from the first list. That will open up the workbook open default event, which I don't want, so I'm going to delete it. But it's completely harmless. I could leave it there. Oops, let's delete it after the next one goes in. But I also get this big drop down list of procedures. And the last one at this workbook level is going to be this new sheet. So just, as I say, make a note that there are a lot more events in there. We've got before close, before print, the activating of the workbook. Some good stuff here. Mentioning the opening. Got loads of pivot table stuff here, which is pretty handy. Lots of good stuff. Sheet change when somebody moves from one sheet to another. Lots of good stuff. Okay, we're going for new sheet. And then I'm going to delete this workbook open event. Right, and all we want to do is when somebody inserts a new sheet, we want to prompt them to put a name for the sheet. So we're almost kind of forcing them to name sheets. Now once again, like the previous lesson, they have provided an object for us called SH. So they're saying this event will run on the insert of a new sheet, and that new sheet is known as SH. So if you want to do something to the sheet, refer to it as SH. Sounds brilliant. What I'm going to do is say SH then, and it's as an object, so it will act as that worksheet. It will have all the properties and methods of a worksheet, or of a sheet really, not just a worksheet. I'm going to put sh.name. I want to name the sheet, sh.name equals, and I'm going to go for the input box to prompt the user to type something in. So sh.name equals input box, and I'm going to say please enter a name for the new sheet, and I'll provide a title which I'll call sheet's name, and that is that. once again, you know, we can stick in some error handling issues and that. What if they cancel the input box and this kind of stuff that we spoke about throughout the course. And I'm not planning on continually regurgitating that stuff as we go through. I want to cut out some of the, it's not nonsense, but cut out some of the kind of extras here, because we've kind of been there and done that. And I'll leave that to yourself to add if you want to try and deal with any potential user errors or behavior at this point. For us right now, I'm just going to close down this editor and test it out by inserting a new sheet. And it immediately pops up an input box prompting me for the name, so I can put that I want to call it Fred and click OK, and I've got a new sheet called Fred. And if I maybe do it this way just to demonstrate other ways, the event will run. I'll call this one Sally, and I've got a new sheet called Sally. So yeah, a third example of an event procedure there, this one running on the inserting of a new sheet.
Hello and welcome to this lesson where we look at our first worksheet event procedure. So we've just seen some events that we can run off a workbook, such as opening of the book or the saving of the book. Now we're going to look at a couple of different worksheet events to get a feel for what's out there. And this first lesson we're going to look at the selection change event. So when a user clicks or selects a different cell on a sheet, for that to be the trigger of our macro. And in this example, what I wanted to do is to apply some formatting to the entire row of the cell that the user selects. It's working on the idea that you might have a large spreadsheet of data. When you click a cell, especially far out here, by highlighting the whole row, it makes it easier for you to see the other values on that row, which otherwise might not be very clear to you. So that's our goal. So let's go to our code, as we do. As we come in here, you can see that I'm in module 1 at the moment. We're in this module, and we already have some code. Now what happened is this was recorded. What I did is I started up the macro recorder, I selected a row, and I applied some formatting to it so that I could capture the code I wanted for that, you know, style of colour and border, because I don't know that VBA off the top of my head. So this is where the macro recorder really comes in handy. You know, we had a section right at the start of the course for using the macro recorder, and I said it's always there for you. You're not going to know every little bit of code, but you can record yourself doing stuff and capture it and then adapt it to your needs. And that's what we want to do. I've added these comments in myself, and I might have tweaked 1 or 2 bits to tidy it up, but it's pretty much as it was after recording in this sub procedure. So we've got the applying of the colour, applying of the borders, top and bottom border, and then I've also got myself removing it, so applying a no fill colour and removing the border as well. Now what I'm going to need to do is cut and paste that into our event procedure. So I'm going to select all of this code. I'll have all of that. Thank you, macro recorder. I'm going to cut it. I'm going to move into sheet 1. The plan is to apply this to sheet 1 and start up an event procedure like we did in the previous lessons. So I'm going to choose the worksheet object, and then we get this list of events from the drop down list to the right. The default event is selection change, which is the one that I'm after. So I'm going to leave it as that. We're going to see one more of these events before the end of this course. That's our plan. But just make a note of some of the other beautiful events that are in there and that you might need. Okay, let's paste them nuggets of code in here. So we're going to be running it off our sheet event instead. I'll go back to that module and delete that sub procedure. Thank you, but don't need you anymore. Okay, so within our recording, it is applying this colouring and stuff to the selection. And that's not going to be quite good enough. You know, that's because I selected a cell and then I did it. So when I said I tidied stuff up, one of the things was rows 6.select. That was kind of there before. And then with selection, we want to say with the row the user has currently clicked on. Now, a good thing for us is in the selection change event procedure, like one or two of the previous procedures, they have supplied a parameter for us. This is right, the cell that the user has selected, it is known as target, and the data is stored as range. And if you want to use this, which you probably do if you're doing this event procedure, refer to it as target. Okay, sounds like a fantastic plan. I'm going to create a variable. So I'm going to do within this procedure, I'm going to call it dim rownum as long, and then I'm going to assign that to it. I'm going to say rownum equals target.row. Capture the row that of the cell that the user selected, or whether they selected, they might have selected a row for all I know. So that's known as target.row, the row of the target. Assign it to a variable called rownum, so that then instead of selection in each of these little with constructs, I can put rows, the plural, open bracket, rows, or row index, rownum. So I'm going to copy and paste it in now. So I'm saying with that row, do the formatting. Let's have it in there, and have it in there. So with that row, do the formatting. So they supplied a parameter. I've captured it in a variable. I could have used it straight in there, really. Don't need the variable, but you'll see that I'm planning on using it for one or two other things. So for ease of use, I've decided to use a variable and then refer to it. Okay, so that should be doing a job. What we've got to think though is when a user selects a cell, they will be leaving a previous selection. And the reason I recorded myself using no fill is that when a user clicks a cell, we've got to apply the formatting to the cell they've selected, but we also have to remove the formatting from the previous selected cell. Otherwise, it's going to get loads of coloured rows. It's not going to be the currently active cell, is it? Active row. So, I'm going to go and declare another variable. Now, for this variable, I'm going to need it to be available within this sheet procedure, but also elsewhere. So I'm going to need this module. If I want to create a public variable that's available to any sub-procedure, user form, event procedure, it needs to be declared in a standard module. I can't declare it within these sheet objects or book objects or user form objects. So I'm going to, at the top of this, put public to make it available throughout this project. I'm going to call it previous row as long, so that we have this variable called previous row that's going to be publicly available. So back into our sheet procedure, what I want to do is when a user very first opens up the book, they're going to think kind of like the cell that they've got selected is going to be applied, and then when they click a different cell, it's going to apply it. So it needs to run at least once first of all. They open the book and it applies the formatting. But then once they've applied that formatting, I need to capture what the previous row is. I need to capture what it is at the moment. So when they select again, I then have the previous row. Now I'm going to put this after the fill colour and that. I'm going to have that previous row equals target.row. Or to be honest, equals rownum. So the currently active one. And then where we've got this colour, what I need to do is I need to say, if before we get to that point, previous row and rownum are the same thing, then this must be the first instance when a user opens up the sheet, because I haven't had the opportunity to select a different cell as yet. I only want to apply the fill colour if they're different. So it means they've moved. So hopefully this is making sense. It's not making a great deal of sense in my head right now. But to get a code on the screen, it'll be clearer. If previous row is not equal to row num, then remove the fill colour and remove the border. End if, and then capture the current row number in previous row. So the next time they select, we can apply it to the row num, and it will have the correct one here because of the assignment at the top. If they're not the same, remove the colour and assign the next active row number to it. Okay, so I'm pretty confident that's going to be doing a job for us. Oh, scrolling up and down, noticed it. Selection object. Hopefully you guys noticed that before me. We're referencing this as previous row now. The one I want to remove is going to be rows previous row. Remove the formatting from the previous selection. Rows previous row. Previous row. Okay. One last thing. When a user opens up this book, we need to capture the previous row then as well. So the very first different selection they make. Because at the moment we're only capturing the previous row after that first selection. So we're going to be one step behind. If you ran this through, if you demonstrate this stuff, you would see it. So let's have a look actually. Let's do that. Let's save this, what we've got. And let's have a look at how it's working. Let's close our editor down. Oh, mistype. Hopefully you guys notice that too. I need an S on the end of my rows there. Let's give that another go. Let's save and close. See what we got. Oh, didn't expect that one. I can see the selection, which is good. What doesn't it like? This road on interior. Okay, yes, that is our problem. We haven't assigned a previous row as yet because it happens afterwards. So that's what I'm after. I can see the selection taking place, and it's a beautiful selection, isn't it? I can see it working, and if I clicked again, it would moan again. But if I pop back to the sheet, it's doing it, but it's not removing the previous selection because it hasn't had an opportunity to capture that information yet. So I'm going to reset this project. I'm going to save that, and we're going to go for a workbook object. I'm going to go this workbook. Let's double click and start up the workbook open event. So we've already spoke about this one, and in here I'm going to say that what am I going to say? I'm going to say previous row, which is why we made it a public variable, equals active cell.row. I can't use target because that parameter is not available to me here. So I need another way of capturing the row that the user is currently in. And fortunately, we've got this beaut called active cell that we know we can use. So where's the row of the active cell? Assign it to previous row. Right, let's have a look now. Save this. And I'm going to close it all down and reopen it. So the workbook open event is triggered and it captures that information. Should have removed these colorings actually. Let's do that. Let's select that, remove all that stuff, and let's save and close again. Let's have a proper example of this. Close it, open it up. Okay, here we go. So I click on a cell, assigns the color. Click a different cell, and now it's moving. Look at that. Only highlighting the currently selected row. So we open the workbook, captures the row that I'm currently in as a previous row, but also assigns the colouring. As soon as I click on a different cell, target is used to capture that row. I have the check in the code, don't we? We have that check to see, like, are you the same as previous row? If it's the very first time you run it, has been used by the workbook open event. If they're not the same, it will remove it. And then is assigned whether the row number is then. So it all becomes a bit of a mismatch. It can be a bit foggy till you kind of run this through. But it's an example of a selection change event. The main thing we're covering at this part of the course, because we've done a lot of coding already by this point, so hopefully this is getting clearer to us. But it's triggering procedures and macros off of these natural events, and you'll have needs to do that. As a byproduct of this, I'm trying to recap on different codings we've done. Active cell coming up again here. The declaration of variables at both procedure level and project level. The importance of recording code and writing comments. Again and again, we're hopefully getting very familiar with this code. We're coming to the end of this course now, so just making sure that we're getting very familiar with this. Hello and welcome to this lesson where we are going to look at the change event procedure. So it's another worksheet object event procedure, and what it's used for is that we can trigger a procedure or a macro off the changing of a particular, like a value in a particular cell. So our example here is somebody's going to type in some marks, like some kind of grade or something, and if the mark entered is 3 or less, then we're going to prompt the user to input a comment. So they have to kind of explain why the evaluation was so low, if it's kind of 3 or under. So just a pretend example of kind of triggering code when somebody changes the contents of a cell. Essentially, when somebody changes the contents of a cell, we're going to check to see what they put and essentially run that event. So, into our code, one thing that's done already is we've created a user form. User form called reason, which we want to use that to capture the comments, the explanation as to why the mark was so low. So it's got a simple little user form here, with an OK button and a big text box. Text box named txt reason, the Hungarian notation there, txt reason. Okay, so let's pop to our sheet 1 object and go into our worksheet object where the default event of selection change appears, and we're going to change that to a procedure simply called change. So rather than changing the selection, it's a change to the cell's content. So I'm going to choose change and then remove selection change. Okay, not that it was doing any harm. Okay, so now we've got the worksheet change. Once again, it's supplying us with target as a range. So a parameter for target where we can see what cell did the user just change. We need to make sure that the cell that was changed is column A. We're just focusing on column A. Was it column A? And was it less than or equal to 3? In that case, show that user form so that they can input that comment, input that code. And then we're going to put the details in the cell to the right. So the first thing I'm actually going to do is we need to create a public variable again. I want to create a public variable which is going to be a range variable that's going to grab the target range, so that when we go to the user form and run code from the user form, I know what the range was. Otherwise, when we come outside of this procedure, we won't be able to use target anymore. So I'm going to need to capture that in memory so that I can use it outside of this event procedure. And like we saw in the previous lesson, I will need to create a standard module because I want this variable to be public, so I can declare it in here. I need to put it in a standard module so it's available to both the event procedure and the event procedure for the OK button in that user form. So public RNG is range in that standard procedure. So then back into our sheet 1, the first thing I'm going to do when that was changed is say set RNG equals target. So assign the range of target to RNG so that then I can use it. And I can say something like, if RNG dot column is equal to 1, so if it was in column A, and RNG dot value is less than or equal to 3, then. So only run this code if the column was column 1, if it's in column A, and the value is 3 or less. And what I want to do is open up that user form. It's called frm reason dot show. So a recap on our user form section there. Display the user form. Okay, so let's go back to our user form. Into our user form, go into the OK button to trigger the event procedure for the OK button. And now we need to put whatever information they've typed into that comments box into the cell to the right of the target, which we now know as RNG. So I'm going to say RNG dot offset 0 rows but 1 column dot value equals txt reason, I think it was. Struggling there. Let me quickly double check that. txt reason. That's okay. Where am I? OK button. Okay. So one cell off of the target, which we assign to RNG. Display the contents of txt reason. And then unload me. So close the form down. Unload me. Right then. So if I was to close down this code window, at the moment if I clicked on a different cell, nothing happens. That's a selection change. If I input something, if I put 6 in, nothing happens. If I put 2 in, triggers the user form, because that was in column A, in column 1, but it was also less than or equal to 3. So I have to explain itself. Why would I pick something I can't type? Punctuality. Punctuality. I know that's wrong. Was poor. I should put spelling is poor. Right, there we go. That's why we give it a low mark. We click OK, and it is displayed in the cell to the right. Okay, now what happens if another type of change is to select them cells and delete them? And now we've got a type mismatch. So any change to the cell contents of column A will trigger this event. That includes things like deleting the contents. Now you know your spreadsheet's better than me, and I don't know how likely that is to happen. I guess it's fairly likely. There's always a chance somebody's going to delete values. Come on. But I'll get a runtime error. So we can do our error handling stuff, all that jazz is brilliant. I'm going to go into debug, and what I'm going to do to handle that in the sheet event procedure, below that assignment, is just put another if statement. I'm going to say if RNG dot value equals nothing. If it equals nothing, then they must have deleted stuff. Now there may be more errors that we have to cater for than just this, but this is I guess a fairly simple one to handle. I'm just going to exit the sub procedure if that's the case. So just quickly with statements go, if the cell's empty, they must have deleted stuff. No need to go any further. And exit sub and end if. Yeah. Maybe we could put an else statement in here, because if it was anything else than that, then do this instead. There are many ways of handling this stuff. I wanted to target the use of somebody deleting there. If I close this down and we check that out again, so let's just delete that. That's column B anyway, so there's no harm there. 7, 1, event procedure. Something was not good. Click OK. Jobs are good, and delete stuff. Quite happy with me to do that now. So there we go. They change event procedure. In my experience, probably a little bit more popular than this selection change event procedure, despite that being the default. Running code off the user changing the contents of a cell. Very good, possibly the most popular worksheet event procedure on my experience. But an event procedure like any other, and we've used it to check what was changed. This thing, very popular. You may come across things like the intersect method and other ways of checking that the cells a user changed. The target is what you're monitoring first of all. Then check exactly what they did to it and then do something about it. In this case, display a form and enter some comments. Okay, I hope that concludes the end of our section on event procedures. I hope you find that useful. Triggering code off natural events, really good stuff to know.
Hello and welcome to this lesson where we start to have a look at creating function procedures. So throughout this course we've been covering sub-procedures or a subroutine, otherwise known as a macro. This last bit now we're going to look at a function procedure, which is a procedure that returns a value. It gives us the ability of creating our own function either for use on a spreadsheet, just like Excel provide the 450 plus functions like VLOOKUP, match, sum, if, and so on. Or also we can call them within our current sub-procedures as well to make our code easier to read and to break it down into smaller chunks. So, in this example, I have this slightly awkward if function put into column C here to calculate commission, which should probably be formatted as a currency. But let's not worry about that too much right now. It's saying, if the sales figure was over 7,000 or equal to 7,000, then they get 15% of that amount as commission. If it was between 5,500 and 7,000, sorry, less than 7,000, they get 10%. Or if it's between 4 and 5.5, they get 7%. Or it's between 2.5 and 4, they get 5%. Otherwise, they get nothing if it was less than 2.5. So, achievable here, but working the idea that that is not the easiest thing to read, and you may have colleagues that are going to struggle with that kind of stuff, and it may even scare them. It's a bit of an intense formulae, not the easiest thing to write, and a bit horrible to read. But also, work on the idea that there is not a function for everything. And time again, it's not unusual that you want to achieve something that there's just not a function for. So you may have to create it yourself. You have this ability, that's what we're going to look at now. So I'm going to dive into our VBA code. We'll ignore this subroutine that is there at the moment for now. I'm going to come back to that. And at the bottom, not it really matters where it goes. Actually, let's put it at the top so it's easier to see. Above that, I'm going to write function. So a function procedure begins with the word function as opposed to the word sub. There's your main difference there. And then we'll follow it with its name. And I'm going to call it commission. And the only reason I'm writing that in capitals is because the functions Excel provide is in capitals. And I'm trying to keep it uniform. There's absolutely no reason apart from that for why you would do that. Okay, and I'm going to put an opening bracket. Now we haven't really put anything in these parentheses throughout this course. Now what we need to do is provide an argument or a kind of parameter for the user. So if this is going to calculate commission, that is based on the sales figure, which was the cell to the left. It was cell B2 to begin with on our sheet, if I remind ourselves. It was this figure here. We need the user to provide that figure for this commission to work. So we're going to ask for that, and I'm going to call it sales. So we can call it whatever we want. Your chance to give it a meaningful name now. I don't know what you thought when you were learning the functions of Excel. VLOOKUP notoriously has some rather poorly worded arguments that people struggle to understand what it's trying to ask them. Now you can call this whatever you want, nice and meaningful, easy to read and use. in our case on our worksheet, that is cell B2, but refer to it as sales. You know, just like the sum function asks for number 1. Okay, moving this down, notice they write end function for us, just like it does end sub, and they section it off because I'm putting another macro here. And now what we're going to do is calculate the commission similar to what I'd already written on that spreadsheet. But rather than use an if then else statement, well, there's nothing wrong with that, but I'm going to go for select case. Been a while since we saw select case in this course, another conditional construct that is arguably better when handling multiple conditions. And I've kind of got 4/5 lines here. You know, there were 4 if functions on that spreadsheet. So it's kind of 5 possible actions, if that makes sense. So select case, the case is sales. The user will provide a figure by something called sales. I'm going to test that. End select. Okay, line 1. Case is greater than or equals, trying to remember what I did, 7,000 I believe, colon. What do you want to do if the case is greater than or equals 7,000? I'm going to say commission equals, so return into commission, just like we assign to variables and assign to cells. I'm assigning it to this function, so the function take the value with it. Sales, aka B2, multiplied by 0.15. Said 15%, if I remember. Right, let's take a copy of that. I'm going to need 4 more lines, so I'm going to power them in. Boom, 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 and boom. Let's close that white space up. Right, next up, case. I'm going to say greater than or equals, it was 5,500 to trying to remember what I did, less than 7,000. Sounds good to me. Commission equals 10%. Should have written this stuff down. What have I done? Oops, I don't need this greater than or equals. Getting myself in a muddle there. Too busy trying to remember. Let's change that to 6,999 now, as I'm opting for that. So sorry, case 5,500 to 6,999. Case, right, we've now got 4,000 to 5,499. How's my maths? And I think I did 7% for that one. It doesn't really matter if I get it wrong with what the calculation was. We get the idea. Right, this one was 2,500 though to 3,999. This was going to be 5%, and in the fact that the case is less than 2,500, or not that number, is going to be that commission equals 0. They get nothing. So, hopefully you'd agree, easier to read. That's what the select case statement does, so that is easier to read than a big nested if. But that is exactly the same as we have on that spreadsheet. Now what I've done is create this function procedure though. So, if I was to close down this editor and come back to the code, and if I was to, actually let's put it side by side so I can see it. Commission 2. In this example, I'm going to say equals and start writing commission. Notice commission comes up as a function within that library. How awesome is that? Now you notice that the only thing that kind of lets this down, and I'm going to talk a little bit more about this in a later video, is that I do not get the description like they get. Now we're going to look at how we can add descriptions and stuff to a function. Unfortunately though, you're not going to get it in this environment. I'll say a bit more on that later, but that can't be done, I'm afraid. But I do see commission here, and when I complete it, I can provide the sales figure, cell B2, closing bracket, and I've got the same figure. And if I copy that down, it achieves the same job. So I've written our own function that hopefully we can agree is far easier to read equals commission B2, it will calculate the commission as opposed to that rubbish. The same job, but we've done all the hard work behind the scenes in our editor and provided for our users a nice simple to use function. That is the idea. Okay, let me just get rid of some of this stuff because that is going to cause an issue in my example here. Let's clear that. Just before I do another example, I want to show going into the function library. So I'm going to click this FX button, and I'm going to go into the list of these kind of categories of functions. And one of the categories in there is user defined. So I'll mention that these function procedures, these custom functions, they can also be known as user defined functions, or UDFs. And here they are, and I can see commission in here. Commission sales. So a bit more descriptive than what we had in our worksheet. In the later video, this is where I'm going to demonstrate to you how we can get our descriptions in here and it's to look like a proper function. You know, descriptions and all the kind of arguments and that, which at the moment you're not getting, you know, as much. Self-contained to sales value, you're not going to get as much there. So I'm going to show you how we can provide this kind of stuff for it. But at the moment there is not that information. Okay, shooting back to our editor. So that is using the function within the worksheet. What this other sub-procedure here is for is to show that we can provide that function now to other sub-procedures as well. So what I've done is I've written out a loop that's going to loop through every salesperson within that list, and I want to calculate their commission as part of this. So this could be, let's imagine this is a massive procedure, and rather than having this chunk in the procedure where you've got this loop going on, or you've got this quite intense conditional construct, we can write this as a function procedure in like a separate little procedure, and then just call it from the other major procedure, therefore making the code easier to read. That is the plan. So in this example, hopefully I can put sales row num, which is storing the row number I'm currently in, comma, and then I'm going to put 3 because I'm in column C in this example, closing bracket dot value equals commission. So I'm calling the function that I've created, opening bracket. Notice how it pops up and asks for sales. So here I'm calling the function procedure that I've created. So throughout this course we've used things like is numeric, I think we used write, we've used message box, input box, all these inbuilt functions. Here we've created our own ones to do a certain job. That's prompted me for information. Give me the sales figure. Okay, the sales figure is sales row num, comma 2. It's in column B dot value. Have I written that rightly? I have. I need one more closing bracket there, I think. No, I don't. I'm going crazy. And I better put in that row num equals row num plus 1. I literally just realised that I'd missed that out. So if I return back to my sub procedure, hang on, don't need to be in a particular cell, no. Yep, just going to test that's okay. Let's go and run our macros this way. So there's my sub procedure as a macro. Notice the function procedure does not appear in this list because it's not a macro. It's not a sub procedure, it's a function procedure. And I'm going to run calculate commissions. I've got one too small there by the looks of it. I'm not sure what I've done there. I'll have to investigate that. Never mind. Let's have a quick look at that before I end. But the job is done. I've provided that function procedure as part of this inbuilt sub procedure. Let's quickly return back to our code. What have I done? Counting column A, 2, do until it equals, oh sorry, my loop is wrong, do while row num is less than or equal. That would do the job. Let's just give that one more try. I don't like this unfinished business. But maybe I should have left that as a job for you guys to do. There's a problem. Find out what's wrong with it. And now we're up and running. Okay, happy with that now. So that is our function procedure. Run as part of a normal function within a worksheet, or also calling it from a sub-procedure. Really useful tool for providing extra functionality for users, but also to tidy up existing procedures.
Hello and welcome to this lesson where we are going to take our function procedure a step further by adding a second argument to it. We're going to look at adding an optional argument to our existing commission function procedure. And we're also going to look at specifying data types within it as well, which we haven't done in our custom function as yet. So, looking at our function up above, let's add to the existing argument at the moment. At the moment we mentioned sales, and it works a dream. We demonstrated that in the previous lesson. What I'm going to put is sales as double. So I'm going to take it a step further by specifying a data type. So just like we have done with variables and that in previous kind of lessons and projects, we should really specify a data type for our parameters or our arguments as well. And I'm going to put that as a double for the type of data it can handle. Then I'm going to put a comma after that argument, and we're going to look at adding a second one. Now the example here, the kind of pretend idea, was that we have two different kind of sales figures that a salesperson can have, online and offline. And if the sales online, we're trying to imagine that maybe this lead is kind of a lot of stuff's done for them, so the sale is typically a bit easier to make. So we're going to say that if this is the online value, then the commission will be slightly less than it is offline. So what I'm going to do, I'm going to write optional, because I'm going to mention this is an optional argument. I'm going to call it online. I'm going to put the data type as Boolean. So remember, Boolean data types only handle either true or false, 1 or 0. So I'm going to say that this is an optional argument. It's called online and it's Boolean. So if it says true, then it was an online sale and the commission should be slightly less than it is at the moment. If not, then it's kind of false. But it is optional. If somebody doesn't specify it, then it's going to have to take a certain action as well. Okay, so within our function, and now I've got this information. Well, actually, one last thing I could do. At the end of the function procedure, remember function procedures, their job is to return a value. I should specify the data type of that value as well, so I can put as double at the end of my function procedure as well. So these two data types for each argument, but then the function procedure itself will return double. Okay, so a bit on data types there. Right, we're going to say if online then. So online is a Boolean value. So it's either true or false. Now there's nothing stopping me saying like if online equals false and stuff like that. Because I'm testing if it's true, I can just use the word online. I don't have to put online equals true. That's not wrong, it's just not necessary. So I'm going to put if online, then, and I'm going to copy this select case statement to save myself some hassle, but I'm going to make these percentages slightly less. So maybe it's 10% there, and then this would be 7%, 0.7, and that would be 5%. Instead of 5, it will be 3, and then 0. And I'm going to put my else, and at the end of this, I'm going to put end if. So we've added some data types to our existing arguments. I have this second argument, which also happens to be optional. And then we test it. If they said it's online, do this stuff. If it's not online, then do this stuff. Let's have a look at it in action. Let's close down my editor.
And let's start writing commission inside here. Or I'll tell you what, sorry, not inside there. For a bit more, let's go through our function library. And here we go. I can see now at the bottom it says sales and online. If I click OK, it wants these 2 bits of information. So if I provide a sales figure for it, immediately it's giving me information. It's saying that the answer is 350. Now I'm trying to remember what values we set. Let's see what we put for online. If I type true, then it's 250. And if I type false, then it's 350. So by default, if somebody leaves the optional argument empty, if they leave it alone, it's choosing the offline option. So it must be set to false by default, because it's a slightly higher figure. But if they type true, then they're getting the online figure. Yes, it was online. I can see it dropped to 250. So 5,000, yeah, I can't remember what that was. And I'm going to try, but we could have a look. But we can see that it is optional, it's running without it, and the difference it makes, and it is a Boolean variable as well. So I can click OK to that. I could copy it down, and these are online sales figures now. Okay, so from what we just looked at there, and next video, the plan is to have a look at how we can add more documentation to this. Because what we just saw there with the default being false, we need to provide that information to a user now, so they don't have to work it out like we just did, and they know what's going on. Hello and welcome to this lesson where we start to look at documenting our function procedures. So as mentioned in an earlier lesson, unfortunately we're not going to be able to provide documentation for when users approach the function in this way and they're writing it on the worksheet. To the best of my knowledge, that is not possible in this current stage of Excel. Hopefully for the future, but it's not something we're going to be able to do. However, we can provide the documentation for when users approach via this way. And they go through the function library, use defined, and at the moment there's no help available on this function. And when they click OK, there's no information about the arguments as to what they do. We can document it in that way. And that's what we're going to do. So I'm going to pop to the VBA environment. And here's our function procedure that we've been using so far. And also down below our little loop. And I should mention that we also get this documentation when we go through the VBA environment. So if I was to rewrite that commission, for example, and put an opening bracket, there is some of the information from our previous lesson. That we've got the data types available now for when somebody's calling that function procedure. And also you can see the square brackets around online as Boolean to indicate that is an optional argument. Okay, I'm going to pull out of that because I don't really want to do that, but look for a demonstration of that. And we're going for the this workbook object on the left hand side. We're going to open up this workbook and I'm going to pop open the workbook open event procedure. So if you haven't seen the section in this course on using the event procedures, this might be a good opportunity for you to pop and have a look at that first. However, don't worry, it's not necessary. We have kind of just triggered that for now. So whenever somebody opens this workbook, it's going to run this documentation code. So we're sure that it's there. And what I'm going to do is I'm going to use application.macrooptions. If I spell application correctly, that would have popped up. Let's give that another go. Here we go, macro options. So we can see it's a method of the application object, and it asks us for lots of information. So what I want to do is provide a description for both the function and the arguments for it by doing this. And the first question is what macro? Because I may have multiple macros. In this case, it's just the one in here, this function procedure. But I'm going to have to answer that macro, and the name of the macro is commission. So with the commission macro, and I'm going to put a space underscore here to continue in a new line, because I fear I'm going to run out of room there. Let's try and align these a little bit better. And I'm going to have description. And now for a description, let's write some waffle about what this function does. I'm going to say that it calculates salesperson commission dependent upon sales total and whether sales are online or offline. So a bit of a mouthful there. Let me scroll back to the left a bit. Can I squeeze that in if I move it a little bit further along? That's a bit much, isn't it? I might have to line continuation in the middle there as well. Can I do that? Yeah, it's quite happy with that. No, it's not quite happy with it. Might have to concatenate the two bits of text if I want it on one line. Okay, let's not worry. I can put it all on one long line. It's just a shame I can't see it all. No biggie. Let me just check. I do have my empty. Here's my closing string bracket. Right, so the next up, if I just actually put a line continuation on the end of that. Here we go. So a new line. I'm going to ignore these others. The next one I want is argument descriptions. Actually, before we do argument descriptions, although I'm not going to do it, let's give a short little shout out to category here, because that's normally quite a common reason for people to come here, that they want to assign their function to one of the existing categories within Excel, or to create their own category for it. So make sure we're happy. By category, I mean the categories already existing for these functions, like logical, lookup and reference, text, maths and trigonometry. These different categories that you find these functions in, like VLOOKUP and if. So I'm not going to worry about that for now. I'm going to leave it within the user-defined category, but it's quite a common reason for people to come here. And I'm going to use the argument descriptions. Now, before I do this, I have two arguments on this function. One called sales, one called online. So because I've got more than one information to display, I'm going to take this opportunity to declare a variable. And I'm going to create an array variable, which I'm going to call arg descriptions. And I'm going to put one in closing brackets. Remember, array variables are 0 based. So by putting 1, I'm actually saying there's 2 items in this array, 0 and 1. And I'm going to mention that that is as string. They're both data types of string. And then I'm going to assign the descriptions for the arguments to them. So arg descriptions 0 equals, so this is for the sales argument, the first one, the cell containing the sales total, and I'm going to copy that to save myself just a very small bit of time. Arg descriptions 1, so the second argument, which is the one about online. I'm going to say whether the sales total is for online or offline sales. Enter, what was it by default? I'm trying to remember now. I think it was false by default, wasn't it? Enter false or leave omitted for offline sales. Enter true for online. So that will do as a description. You get the idea, especially as this is a optional argument. I need to mention what would happen if they did omit it. And hopefully I've remembered correctly from the previous lesson. Did I put my closing speech marks at the end? I did. Okay, now back to our application.macro options. I need to put a comma and say that argument descriptions is equal to arg descriptions. So referencing my array variable there Wonderful. Here we go. So that should do the job. Happy with that, I think. So the step is to check out that this works. So let's close down this VBA environment. The workbook needs to be open for this documentation to be triggered. So I'm going to have to save this and close it all down. Let's close down documenting function procedures. And I'm going to reopen documenting function procedures to initialize that workbook open event. So that now if I have a look at my user-defined function, I get the description at the bottom. So now I've got the commission function, sales online, calculates the salesperson commission dependent upon sales total and whether sales are online or offline. And if I click OK, I've got a description for the sales one there, cell contain the sales total, and for online, what that means and what I need to do in each case. So a very useful skill to provide documentation for your procedures so that people understand what they are using from within this worksheet or VBA interface. Hello and welcome to this lesson where we look at creating an add-in in Excel VBA. So we've seen a few different ways that we could distribute our sub-procedures and our function procedures during this course. We've looked at how we can save them mainly to a specific file or workbook. So that workbook can be distributed in any means, via email or via a shared drive. As long as that file is open, a procedure will be available to its user, whether that's us or somebody else. We've seen the personal macro workbook, which would only make it available to us, but it would be available in any file that we use, a hidden workbook called the personal macro workbook. And now we're going to look at an add-in, which is possibly the best way of distributing procedures for others. We can save this thing called an add-in that can be distributed in some means, and then it can be enabled in other people's Excel, making all the procedures available to them, from whether it's accessing it through the VBA interface or through Excel normally, then macros and then functions are available. Now at the moment I've got a file called book2 open, so it's just an Excel file. It's got absolutely nothing inside it because I'm not interested in importing anything there. But in the VBA environment we do have some stuff. We have the function procedure from the previous lessons. So the exact same function procedure from previous is in here, in a module 1. And I've also got the documentation in here as well for it. Both within a module, and this documentation is actually stored within a sub-procedure called function documentation. So I've put it in a sub-procedure this time, as opposed to the workbook open event, which it was in the previous lesson. Because this time I don't want it to open with this workbook. Well, I will do when it's an add-in, but I'm going to take a different follow a different process for it. What I'm going to do, so it's called function documentation, this procedure. I'm going to double click on this workbook object as before, and kick up the workbook open event procedure. And I'm going to call that macro. So I'm going to call documentation. I remember what it's called. Call function documentation. And one of the reasons I'm going this way is because when we use an add-in, when that's enabled on somebody's machine, when they open Excel, not a specific file, when they open Excel, it tries to deal with the add-in slightly before it's opened any files, in the kind of order they're doing a job. So you will typically get an error message saying that it cannot edit a workbook whilst there are no workbooks open. Because when you're going to change the documentation of a macro or a procedure, you need that workbook open. So you can't do it before it's open. It's just a bit of a nuance about the order that it runs. It's one of them things that you just kind of find and you think, oh, gee, I didn't know that, how could I? And maybe you're speaking to people, you're Googling, and you find this issue. Someone will bring it to light and you can deal with it. What we're going to do is put workbooks.add a statement before that. So we're going to force the fact that a workbook is open before it tries to run that procedure and documents it. So we're going to ensure that we don't get that error because we're going to make sure one is open first. So that's the way we're going about it. So now I'm going to close down this editor, and the next logical step would be to create that add-in. So I'm going through the normal save as process, but instead of saving it as an Excel workbook, we're going to save it as an Excel add-in. So this should take you to the add-ins folder. Takes you straight to that path. Now yours might differ from me depending on the version of Excel or the version of Windows, or even if, whatever device you may be using, it may differ a little bit. I'm not too sure how much this has changed over the years, but it's bound to have changed a little bit. But it should take you there straight away anyhow. Otherwise, if yours isn't for some reason, maybe something to look up and you'll have to go there manually. Okay, I'm going to give it the name Awesome Functions. We'll give this file a name, just like you would in any other file. And I'm going to call it Awesome Functions, working with the idea that even though we've only really got one in here called Commission, it will list loads of different sub-procedures and function procedures, making them available to everybody in the company or whatever your style, or whatever your scenario is. I'll click Save to save it, and that add-in is saved. Okay, now with that done, next step will be to go to the Developer tab, which should be visible at the top, and to the Add-ins button. When I go into Add-ins, I can see the Awesome Functions add-in available, but at the moment it's not enabled. So I'm going to tick the box to enable that add-in and click OK, so Awesome Functions is now available within this file. And what I'm going to do is I'm actually going to close down Excel. So I'm going to close Excel down completely, and then I'm going to reopen Excel. And as I'm reopening it, have a look at the startup window. It's going to be very fast, but you should notice it enable the add-in as it does it. So if I close this down, no, I don't want to save that. And if I kick open Excel, so here we go. I don't know if you saw that or not, but it would have gone through the process of enabling the add-in as it went. So now, I'm just going to check that out. If I go to Developer and Add-ins, there it is, all enabled. Bit of a pointless for me showing that, but I just wanted to show you that it's still ticked and stuff. But what's better to show is if I go to my FX button, and if I go to the User Defined, that it is available and the documentation is there. So I'm now in a completely different file, and I don't have like that file open or anything. It's like this hidden file, this add-in that's got enabled at startup of Excel, and it's making this function available to me within any file, and I can distribute this to others and they can enable it and have it available in any file that they need. So that is the kind of add-in for distribution, and also a little bit of another way of looking at how we can set up the documentation of function procedures specifically, and the little kind of nuance that we get there.